at Opaque Systems, Aaron Fulkerson.
Welcome you all to the 4th annual Confidential Computing Summit. I'm so excited for you all to be here. Thank you so much for joining us. I want to start off by thanking our terrific sponsors. So beginning with our diamond sponsors, thank you all for your ongoing support. All of you have been here most of you have been here since the very beginning, since the very first Confidential Computing Summit. Oh, one other thing, before I even get into the sponsors, guys, because I've got some more to go through, I want to thank the Linux Foundation, Angela, and the rest of the events team. Thank you all so much. Having organized this event with Opaque and the last 2 years, or 3 years actually, but I was here for the last 2, oh my gosh, these guys are such professionals. I have aged so much every single year pulling off this event, and this has been so smooth, so thank you, Linux Foundation, so very much. So also, I want to thank our platinum sponsor, who also happens to be the sponsor for our Keynote streaming and recording, as well as our Wi-Fi, Alpha Compute. So thank you so much, Alpha Compute. And I will also call out that their CEO, Brittany Kaiser, has by far the best CEO manifesto I've ever seen online. So go to their website and listen to her video manifesto at alphacompute.com, I think. So every year we've had terrific poster sessions. And these are people who range from the bleeding edge of research around technology to really exciting technical deep dives. So I want to encourage all of you to stop by the poster sessions, speak with them, and then Nellie, will you stand up for a second? Nellie is the chair of the Confidential Computing Consortium. After you go to the poster sessions, find Nellie and tell her your favorite ones. Because Nellie and I are going to pick some of the poster sessions to come on the main stage at the closing of each day. So if you can find her, tell us which poster session you think is the real standouts. I was doing this because I knew it'd be like super funny to call you out, and then they're going to come up to you all day long. All right, so moving right along. If you need assistance, go by registration. Okay, so to help us kick off, I want to introduce the original gangster of all original gangsters related to Confidential. This woman has been a pioneer around confidential technology, privacy-enhancing technology at internet scale. She is one of the most important people in our space. Let me welcome Nellie Porter from Google.
Now you see the whole secret. Thank you so much, and welcome to Confidential Computing Summit of 2026. I am, as you probably know by now, the chair of Confidential Computing Consortium, and also product owner of this vital capability in Google. So for years, we were developing, we're optimizing, we're making this one of the most important goals of our lives, to make hardware-based security and confidential computing and preach it to a world that didn't know how badly they would need it. I think we succeeded. Congratulations to all of you. I think that the debate is over. Enclaves are ready and hardware is also ready. We made it. Congratulations to all of you. So what is the next for all of us? We never stop. Our customers moved over the simple chatbots and started to deploy autonomous agents. Those agents are making decisions on our behalf. They're actually running enterprise workflows. They're having access to the most sensitive data that our customers ever possess. And all of this data It's actually in the minds, because to be autonomous, those agents need to have mind. So now, imagine that agents execute on your tasks. They're spinning up another 20, 25 agents, depending what is complexity, and all of them have ability to get access to these secrets, to this data. It's becoming the biggest liability of enterprise customers of today. And if somebody would be able to see or have access to this open mind, those customers will be compromised. So I don't think it's a problem for this room, because we know something about AI mind, agent mind. It's all about memory. I think we first come to a realization that memory is a critical asset that needs cryptographic protection. And what I want to tell you is that we all focusing on encryption in transit. By the way, post-quantum cryptography is going to be very complicated here, as you probably know. We're talking about protecting data at rest. But the next big things that we need to start focusing is how we will protect data in mind. In agents' minds, it's all about context window. It's all about active state of execution. But this is a critical part that we all have to get together. We need to stop talking about implementing technology for sake of technology, and we need to help the world to have those agents safely deployed. Because as future will come, it will run by intelligent agents. And intelligent agents will be as powerful as they will be secure and trustworthy. So what I'm trying to tell you, we have work to do. Please don't stop. And we have all Lego blocks and all capability to make it happen. We're here to protect AI mind. Thank you so much, and welcome to the summit. Enjoy it.
All right, so I'm going to facilitate some introductions, but this next one I don't think really requires one. We'd like to bring on stage the CEO of the Linux Foundation, Jim Zemlin, someone who I've been friends with. I think the first time I met Jim was about 20 years ago at Silverado at an open source event. And just watching Linux Foundation from those early days of open source, where it was a bit of a niche thing 20 years ago, to where it's now running, of course, the backbone for all enterprises, all nation states, all governance in the internet. Jim's been at the forefront of this from the very beginning at the Linux Foundation. So thank you so much, Jim, for joining us.
All right. I don't have any slides today. I'm going to spare you all, maybe save a little more time. I do remember meeting Aaron. I met Aaron right around the time I met my now wife. And I met her on a blind date. And we went out for lunch, and she asked me what I do for a living. I'm like, well, I work at this nonprofit, and it's open source, and we kind of give everything away. You know, she had graduated from Harvard Business School, tech executive. Like, the look of disappointment was palpable, but I still married her. Today, I have such a cool job. You know, the Linux Foundation works across every sector of technology. We work with thousands of different organizations, hundreds of thousands of developers every day. And we get to be kind of at the forefront of really important technology. You know, today we're the home to MCP and the Agentic AI Foundation. We're home to the PyTorch Software Foundation and all the transformer technologies, VLLM and so forth, that are used for training models, post-training, and inference. We just get to be a part of so many interesting things. In fact, after this event today, I'm going to go give a speech this week at the United Nations, where they're having a conversation about artificial intelligence. And the big theme is artificial intelligence and digital sovereignty, as you can imagine, at the United Nations. Which gets me to this group. something that's, talk about having the right technology at the right time, even if you wouldn't have predicted a few years ago how important confidential computing would be to artificial intelligence, would be to digital sovereignty. I mean, this really is it. And I'm going to talk about confidential computing at the United Nations because one of the big difficulties with artificial intelligence for countries around the world is not necessarily access to software to build and train models or software to deploy agents. Like, most of that stack is open source. And there are a lot of open weight models out there that people can get access to. The bottleneck for a lot of the world is just access to capital and access to GPUs and data center infrastructures inside of their country, which many governments around the world see as the definition of digital sovereignty. What breaks that mold, as you all know, is confidential computing technology, where you can actually have digital sovereignty and you don't necessarily need a data center to actually reside within the boundaries of your country, because you have a provable way to know that you have that same confidential sovereignty, even if you're accessing that data center somewhere else. So this is just a critical linchpin, not just in the future of how agents get deployed and maintaining all of our privacy and security, but confidential computing in the context of the United Nations and sort of the world's digital divide is another essential building block that I think can give access to a broader number of people to this incredible artificial intelligence technology. So I just am grateful that the Linux Foundation is able to pick up the baton on the event here. Our events team is kind of all over the place. The Linux Foundation collectively has, I think, roughly a $350 million collective operating budget. And a lot of times people from the open source community ask me, where does all the money go? Why is that not used to pay open source maintainers? And the answer is because most of that money is running events like this. And if I gave Linus Torvalds $20 million to run KubeCon, I can guarantee you that KubeCon would suck and it probably wouldn't happen. And the main point is, the role of the foundation is convening, and to be able to work at an event like this and to work with an event management team, Angela Brown over there, the whole team is here to run this kind of thing, is a big honor. So I want to give them one more shout out as we kind of take the baton on this. And I hope you all have a wonderful event here in San Francisco, my hometown, and I'll be seeing you throughout the day. Thank you.
Okay, great. Okay. Okay, great. So everybody here should recognize the fact that you're working on the most important technology in the world right now. And I say that without any dramatization. The reason why this is a fact is that the work that we're doing secures what AI will become in the future. So for the next 2 years, all of you who are working on how do we ensure that rules are followed by AI and make it provable, you are literally working on the most important space in technology of the next 2 years. So let's talk about what we're building, the world we want to create. Imagine if every industry could utilize the best models with their most sensitive data on their most sensitive systems and have certainty that they've retained ownership of their data. Nobody gives up anything. So if you're a healthcare network, you can run the best models on your patient data. A financial services institution, an insurer, a nation state on citizens' data, knowing that you're retaining the sovereignty of your data. That's the world that we want to build. It ensures that we have a durable, thriving ecosystem that benefits from AI. It's the safest path forward and creates the greatest benefit for humankind. However, there is an alternative path. And this alternative path is one that we organically drift toward. And we've seen it in each technology cycle after technology cycle. And that is one in which, in order to use the best models, people are giving up their data. And that data then pools into one or two intelligences or minds that are owned by one or two companies that power the cognitive infrastructure for the planet. And everybody becomes dependent upon one or two entities. That doesn't make them a customer. That makes them a dependent. That creates a system that is very fragile and brittle, one in which there's a single off switch, one in which there's a single set of blind spots. And it is not a durable environment. So how do we create a durable, thriving ecosystem? Very simply, it's one word: sovereignty. We enable everybody to have sovereignty of their data. Everybody must be able to decide the rules for how their data or model weights are going to be treated. And that has to be encapsulated in some portable record or a passport that they can rely upon to be enforced and provable. How do we create this record in a manner that's provable? Well, where's the trust boundary? Where does the trust come from? Is it some third-party entity? We have a solution for this today. It comes from the silicon. It comes from the hardware. So here's how this works. And today, we're announcing a raft of open source releases that have been co-developed from a whole bunch of different entities. We call it Agent Trust. It's on GitHub. We've taken Microsoft's Agent Governance Toolkit, which is now deployed in millions of deployments. Within the first 2 months, it had over 4,000 stars on GitHub. The original creator, it was released under an MIT license. His name's Imran Siddiq. He's around here somewhere. He's the chief platform officer at Opaque. He joined us recently. We took that, we extended it, and we released it to open source. And what we're announcing is Agent Manifest, which is proof of exactly what an agent is, what rules it must operate under. And we've also released the first ever confidential MCP. So this is taking governance rules, baking it into MCP, and then enforcing it in hardware cryptographically so you can deploy it reliably with zero trust and prove what it actually did. So all of this gets bound into, all these actions gets cryptographically bound into a single governance record we call trace. Trusted runtime attestation for confidential execution. So this is not some one-off other standard. We're taking standards that already exist, open source libraries that already exist. We've been collaborating across a whole multiplicity of people within the ecosystem to release this, and it's available today. It allows you to see what ran, what data was touched, where it was run, everything you need to know, and you could produce this record before you distribute a workload to a host or share data. You can inspect the record and say, is it going to honor my sovereignty? Is it going to honor my rules? So it takes an ecosystem to achieve this. So we're upgrading the trust layer for this technology platform shift in the same way that we had to do for the internet to become a software distribution platform or an e-commerce platform. We have to do the same thing for AI in order for people to retain the sovereignty of their data. So it takes an ecosystem. And great news, that coalition exists already. They're all members of the Linux Foundation. We've been collaborating with all of them. They're all here at the Confidential Computing Summit. But the significance here is we're taking an open standard, AGT, we're extending it, we're making it possible for you to govern your agents, cryptographically enforce it. We're making MCP far more secure and reliable through hardware enforcement, and it's all available for free to all of you to build on. So now that we've talked about the open source and open standards that we've released in collaboration with a whole bunch of partners, thank you all for participating. Let me share with you briefly what Opaque's delivering for our customers. Oops, I went too far. Here we go. Let's talk about what people are doing today prior to the standard. That's a key point that I should have made to begin with, which is if you look at how organizations are embodying their standards, it's through manual processes and one-off, but they don't communicate with one another. So by having a standard that everybody agrees to, it's portable, it's also enforceable in the hardware, like I mentioned. So now I'll talk about what Opaque's offering to our customers and how we're building with them. First, let's recognize what the struggle is. For all of us, which I'm sure everybody here has already done this, who are building agents, we understand the challenge. The challenge is that these agents are like really adorable bionic puppies. They're incredibly powerful, they surprise you and delight you, and sometimes they surprise you and mortify you because they're incredibly fast, they're not housebroken, whatever they get their hands on they chew through, and periodically they leave embarrassing puddles of data around your house. So in order to govern these, there's two parts to it. What Opaque provides is a confidential AI platform that gives you the software layer building on AGT, an agent trust, to put governance rules on your agent regardless of what framework you're using. It's deterministic, it operates at the action layer, and then in order to take it the full way there so that you can prove, even while you're building, that it actually is being enforced, we enforce that with our confidential core. So that's hardware enforcement, cryptographically enforcing the rules of the agent and producing proof through attestation of what actually where did it run, what rules did it follow, et cetera. And we've been working on this not just with all of our partners in the ecosystem, but through work with our customers like Anthropic, Encore Capital, Accenture, ServiceNow. And there's two parts, as I mentioned. There's agent control, which makes it fast and easy for you to build the agent so that you can go like, what is it doing? How do I know what it's doing? And then the confidential core when you're ready to deploy and get up to scale, so that you can connect these systems together or connect your most sensitive data so you can scale faster. So all of this falls under the same umbrella, our confidential AI platform. And to deliver verifiability, you've got to have both the software and the hardware. So what does it produce? What does this look like? So you're looking at what precisely is produced. And this is coming out of Opaque, but this isn't something that Opaque cooked up in our own little code lab. This is actually building on existing standards. Because in order for this to work, to have a trust layer that can interoperate, we can't go off into our little code cave and build something ourselves. We have to build using open standards as part of a collaboration of the ecosystem. So that's exactly what you're seeing here. So this is an example of trace, right? That passport that you can decide whether you can access my data or I'm going to distribute my workload to a different host. And then what you're looking at here is an ear. So for those of you who are familiar with an EAT attestation result, that's what you're looking at here. So every single line in this is actually provable by a third party. So you can prove, where did it run? Oh, okay, I can see that we're using AMD as the hardware root of trust in this example. It's running on Azure. What ran? This is the AI bomb. And then what were the policies that were enforced at runtime? So the significance of this is twofold. One, this is taking standards that already exist, packaging it into an easy-to-use platform so that it's portable and anybody can interoperate with it. And then the other part of this is, it's the only way that you can reliably connect your most sensitive data and systems to AI agents, which are these bionic puppies that chew through everything and leave embarrassing puddles of data around. Because you can actually restrict it through hardware to follow your rules and then prove it to a third party. And that's the final thing, which is regulators are increasingly requiring this, and there'll be some speaking about that today. There's one other thing I want to call your attention to. Opaque also does this entirely with post-quantum cryptography. So with the technology of our partners, TII, who will be speaking here today and tomorrow, we provide, as part of our platform, post-quantum cryptography so that you have not just proof today, but proof in a post-quantum world as well. Now, where do all of you come in? Well, we've taken a bunch of open source packages and standards. We've packaged them together. We've released them for all of you to build on, all of you to use, all of you to run with. It's under Agent Trust. We hope that you'll go use it, take advantage of it. You already are today. If that's not clear, like I mentioned, we're building on Microsoft AGT. It's literally got millions of deployments out there. Your teams are probably already using these technologies today. We've just extended it further to provide additional guarantees, and it's free for all of you to use, and we hope that you'll actually participate with us in building it. And then, if you've built something and you want to connect it to your most sensitive systems or data, great, reach out to us at opaque.co, and we'd love to talk to you. Now, I want to leave you with one thought. For me, all of this in my entire career, even in my early starts around open source, has been about one thing: freedom. So when we talk about data sovereignty, we're talking about freedom to choose which is the best model I'm going to use for my data, for my use case. And I don't want to trade anything for that. So Dr. Najwa Waraj from the UAE is a world-renowned cryptographer. She builds AI at nation-state scale. She runs a frontier lab. She'll be speaking here today. She says it very well. There's no such thing as sovereign without verifiable guarantees. And then just to add to that, it goes back to what I'm really passionate about, as I mentioned, which is AI is obviously the defining force of our generation and probably for generations to come. Sovereignty over your data is the defining freedom. We should never have to pay for AI with our data. That creates a world in which it's monolithic and brittle, and nobody benefits from that eventually. Maybe a few do initially, but it comes crumbling down eventually. So for me, what I want you all to leave with is, let's optimize for freedom. That means data sovereignty. That means the freedom to choose which model you want without having to pay for it with your data. Thank you very much. So I want to introduce our next speaker. His name is Mark Russinovich. He is the Chief Technology Officer and the Deputy Chief Information Security Officer and Technical Fellow at Microsoft Azure. Here it says that he's one of the most consequential technical voices in cloud computing, but I would argue that Mark Russinovich is one of the most consequential voices in all of technology. If you haven't listened to his podcast with Scott Hanselman, strong plug, I'm going to plug it right now. It's a great podcast to listen to. Thank you so much for being here, Mark.
Well, good morning, everybody. First, I want to thank Aaron, and I want to thank the Linux Foundation for organizing this event. I've spoken at every one of them, and it's a pleasure to be back here and see the momentum grow every single time I come back. I keep thinking it's the year of confidential computing breakout. I've been predicting that for a while. Eventually, I'm going to get it right, and this year might be the year that I get it right. So I'm not going to talk to you so much about confidential AI, because there's going to be lots of speakers here talking about confidential AI. Instead, I'm going to talk about something a little bit different, which is based on the trajectory that we've been on at Microsoft for 10 years that we've been working on confidential computing. You can see the portfolio of products and services that we've introduced over that time. The list continues to grow, and it starts from hardware to services, fundamental infrastructure services, up into delivered services for our customers. We're definitely seeing a demand for sovereignty. We're seeing a demand for no boundary confidential computing. Confidential computing for every service is what we've been working towards. But last year, I introduced a way to talk about confidential computing and the promises that people expect and are looking for from confidential computing. Because when you talk about confidential computing, of course, at its core, it means protecting data while it's in use in hardware-based enclaves with attestation. But the workloads, how they take advantage of those enclaves, determines what kind of promises you can get out of those workloads. And so last year, I introduced this taxonomy that we started using internally at Microsoft as a way to kind of frame what are we doing, starting with on-confidential computing, in confidential computing, and transparent confidential computing. I'm going to talk a little bit about each one of these and give some examples of each one. But I'm back here this year after us working for a few years on what's next, how can we extend even these promises? And I'm going to talk about something we're calling confidential tenancy, which really is providing people the sovereignty that they really desire, the complete control over their data, not just the protection of their data. So let's start by talking about what on-confidential computing is. And this is a very powerful tool. This is, I think, what is going to enable the breakout of confidential computing is make it so that there's no reason not to run in an enclave. Because up to now, there's always been some cost to running in an enclave. Whether it's actual dollar cost to putting it in an enclave, whether it's a performance cost to putting it in an enclave, whether it's a complexity cost to putting it in an enclave. But we're at the cusp of all of those disappearing, no matter what the workload, whether it's AI or whether it's standard compute, whether it's a database, putting it in an enclave over this next year, those costs will eventually or essentially disappear. The performance will be on par with general purpose computing, including with communications between CPUs and GPUs, the AI accelerators, that with introduction of protocols like TDISP for attestation, mutual attestation of those devices and encryption of those communications, which has been lacking up to now, are showing up in the market. But on confidential computing, when it becomes easy enough to adopt, now everybody gets some defense in depth. Just toss your workload into an enclave, and now you're protected from the surrounding infrastructure. And you might get some additional protection from data leakage and exploits from outside. And hopefully we're at the point where it's just, why not do this? But to really take advantage of what confidential computing and protecting that data in use gives you, you need to be in confidential computing, which means you've taken the workload and you've actually architected it to ensure that the clear text never leaves a hardware protected boundary. This is something that we're calling the confidential trust boundary. The confidential trust boundary is the protection with hardware and attestations of the data and the code that has access to that data. And this is a little bit different than the trusted computing base of a system. The trusted computing base are those core components that the whole system is built on top of that can't fail to provide security. This is a little bit different. This is saying the data can flow anywhere inside this boundary and it's protected with mutual attestations and hardware such that I can extend it over arbitrary trusted execution environments. And the TCB of that system can be internal to that particular system. So CTB is a little bit broader, is the way we've been thinking about it. And in confidential computing means that you've actually put the components inside of the TCB. All the data runs inside of the CTB. We've also been thinking what constitutes the root of trust of a CTB. And it's really these components right here: the trusted execution environment, the TEE, the attestation services, and the secret manager, where the TEE provides evidence of what's running, what hardware is protecting it. The attestation service examines that, verifies it according to some policy, and releases an attestation token that the TEE, the workload, can present then to a secret manager to get access to a key to then go decrypt that data. These three components are the core root of trust for a CTB. And so with those kind of fundamentals in place, we can think about what is in confidential computing. And in confidential computing means I've designed the system based on this core root of trust, these components, and I keep all of the data within TEEs protected in this way. So we've been on a journey to move lots of critical services at Microsoft into confidential computing. And we're doing this to protect our own data and our own workloads, as well as to protect the data and workloads of our customers. And I'm not going to be comprehensive about all the examples, I'm just going to give you a few highlights so you get a flavor of what we're doing with in confidential computing and what in confidential computing means and how it's valuable to us at Microsoft. But one of the examples of in confidential computing is a direction that we set a few years ago when we were attacked by nation states that were able to get signing keys out of our consumer signing service, Microsoft Accounts, and then use that to get access to customer emails. We decided at that point the root keys are in HSMs, but the keys and the token signing itself is inside of a TE. And so we moved our Entra token signing services and our Microsoft Account token signing services over the last few years to be completely 100% across all regions around the world inside of a TEE. And this is a big step towards us protecting those signing keys. But we've also been taking a look at migrating services that our teams responsible for those services were running in what we call high security environments, which were outside of Azure's cloud, in effectively on-premises data centers with their own networks, their own Active Directory domains, their own administrators, and their own basically flow of software and hardware into and out of it to protect this incredibly sensitive workload and data from attackers that would have a lot to gain by penetrating them. One example is our payment services, where credit card transactions are processed. Now, one of the challenges that those teams all faced with these high security environments is the complexity of them, the capacity limitations, the costs overhead of them, having to buy, for example, new HSMs, and as the service kept expanding, keep on procuring them. And so a few years ago, the payment services team started a migration, re-architecting the payment services to run inside of Azure Confidential Computing with the goal of achieving the exact same promises that they were able to get in their high security environment, but in a commercial cloud, Azure, using confidential computing. And so you can see here a simplified architectural diagram of that payment service and how it protects the credit card numbers from workloads and exfiltration, translating them into tokens based off of signing keys, decryption keys that are used to encrypt and decrypt them that are in HSMs. We've also been migrating other sensitive services that are incredibly valuable to Microsoft, like our licensing key services. And about a year ago, shortly after the last CC summit, we finished a migration that we'd started of migrating Windows licensing keys into confidential computing in Azure. Again, another service that was in one of these high security environment on premises, completely migrated to Azure. And then, exciting to a lot of people that play games, we migrated our Xbox token signings, or our Xbox licensing service, which is called XKMS, into Azure. So anytime you're playing an Xbox game, you're interacting with a confidential computing service that is architected to be inside of confidential computing. And it doesn't stop there. Our full Microsoft signing services also completely inside of confidential computing. And then just recently, to help our customers with this pain of passkeys and having passkeys bound to a particular hardware device, breaking free from an individual device, how could we do that securely? We don't want these passkeys to be flowing out in the clear and then be leaked, compromised, and then be used from other devices that are not authorized by that user. So our Edge team looked at this problem, saw confidential computing as a way to actually protect the keys end to end, from one device to another, allowing a user to roam their passkeys. And that architecture is now up and running, allowing our users to roam passkeys between devices by leveraging a cloud-based confidential container which manages the encryption and decryption of those keys and migration between users' devices. So another great example of something that prior to confidential computing, without confidential computing, we probably wouldn't feel comfortable doing this, given the enormous risk of having these keys floating around. And then one more, multi-party computation. I've been talking from the start here about the value of multi-party computation with confidential computing, which doesn't have the performance overheads and complexities of fully homomorphic encryption, secure multi-party computations, but actually lets you run at native hardware speed, fully compatible with all software, and then allow multiple parties to collaborate with rules around who gets access to the data that's being shared. And maybe nobody gets access to anybody else's data. They only get access to the results. And maybe even then, only one or a few of the parties get access to the results. That's made possible with these confidential clean rooms. And we've got confidential clean rooms now with Spark Analytics in preview, which allow customers to come and perform analytics together, with the parties agreeing on contracts basically for what software is allowed to access the data, and then based off of attestations of the configuration and the code, releasing keys to the computation that then only allow those particular queries to operate over it, and only the specific parties to get access to the results of those queries. So this is something we're seeing a tremendous amount of interest in. You can imagine all the scenarios, from governments that have different departments that aren't allowed to share data with each other, to healthcare, where you've got different parties with different data sets, again, can't or unwilling to share data with each other, but want to get joint insights out of it, and the list goes on and on. And then the next phase, though, of confidential computing, the next step up, is something we call transparent confidential computing. So it builds on in, but it brings something else into the picture, which we recognized when We were talking to customers about not just being IaaS-based when they talked about moving data into confidential computing, not just saying, I've got control over all the code. But if you've got control over all the code, you're not able to take advantage of cloud services. How can we give customers the confidence to let our services enter the CTB with their data? One way we can do that is with confidential computing, to give them guaranteed auditability of the code and configuration that touch their data at any point in time. And we do this in a way that we describe in this Communications, the ACM article we published a couple years ago, a self-sustaining system that will preserve this guaranteed auditability property even as it's upgrading itself without users having to go manually approve every code update. This is all based on something that we call a Microsoft Signing Transparency Service, because what you have is a service that basically will only sign software, only sign artifacts, if it adheres to a certain policy. And it stores this fact that it signed it in an immutable ledger, and it returns a receipt that goes along with the signature that allows somebody to prove this thing actually adhered to some policy. And the relying parties for this can include the code itself. I'm only going to upgrade myself if it's in the ledger, and the policy that allowed it to be signed and put in the ledger says, A, the code is escrowed out of the party's control, and B, it was reproducibly built or had an attested build. And with those two properties, you guarantee that an auditor comes along, they can get access to the original code that went into that component, that service, and they can verify that it is actually what ran and had access to their data. Again, fulfilling that guaranteed auditability property of transparency. So Microsoft Transparency Service, we've just released it literally recently. And the way that it would work is you have a signing pipeline with something like Microsoft Artifact Signing. Ideally, a confidential builds pipeline. So you don't need reproducibility, but you need measurements and attestability of what went into the build. Then you sign the code, and this signing of the code at this point is just, hey, it's Microsoft code, it came out of a particular pipeline. But the transparency service then looks at a policy, again, a policy like the one I just gave you an example of, and if it meets the policy, records in the ledger, returns a receipt, and then that receipt can be leveraged by confidential services to gain trust in this thing. It can also be leveraged by a customer to gain trust in this thing, and through an auditor that can go and say, I need to look at the code. And instead of, hey, this is the code right here, they get cryptographic proof that that code is the code that has access to the data or had access to the data at a particular point in time. So this is our step on this journey towards transparency, and we're already building a number of our core root of trust, the CTB services, which are the most fundamental to confidential computing, in this transparent way. But I'm excited to talk about our vision to take this a step further, because one of the goals from the start with confidential computing and our thinking about it has been, how do we take, if possible, not that it would necessarily always be the case, but take Microsoft out of the CTB to get altogether. And so the way that we're thinking about that is mapping effectively what an air-gapped cloud looks like into a commercial cloud. In an air-gapped cloud, you've got an environment, and it's got something called a data diode. That data diode controls all the data that can go into and out of the environment, and it is the mitigation for a compromised piece of software getting into that environment because it cannot exfiltrate data. And this is the way that all nation states protect their most sensitive secrets, is with this diode, which has policy enforced for what can come out. We're implementing right now, designing and implementing a virtual data diode based on confidential computing that gives a customer complete control with their policies of what data comes out of a service provided by Microsoft. The data diode effectively is their boundary around our service, so that even if we get compromised or we put in a backdoor, the data can't come out because their policy blocks it. And they've got complete control over what goes in and out. And with this kind of fundamental building block, we can get to that sovereignty that Jim was talking about, where somebody can create basically an air-gapped data center that isn't just in one location like it is today on on-prem, but actually spans multiple cloud regions because they've got full control over the data that comes out of that environment. They've got full control over the data that goes in, and this boundary, then it can extend and create a bubble, basically an air-gapped environment that spans multiple regions, giving them not just the data sovereignty that Jim's talking about, the digital sovereignty, but also resiliency. Because now, if they're being attacked as a nation state, their air-gapped environment isn't sitting here in a data center that somebody can point to, but is actually in the cloud and able to move around. So this is our next step on the journey that we've got, is this vision going from on confidential computing, let's just make this the default, in confidential computing, designing with tools that are becoming easier and easier to use, workloads that protect their data all the time with TEs, to transparency, they'll be able to guaranteed audit what happened, when, and finally, confidential tenancy to really fulfill that digital sovereignty vision with cryptographic guarantees over what controls are accessible to that data. This is the vision that we're on, and this is what we hope to continue. It's an exciting year for confidential computing, and I want to thank you very much again for inviting me to come up here and speak.
Thank you, Mark. Oh, I'll take it. All right, thank you so much, Mark. I've actually followed Mark's career since before he was at Microsoft, which was 20 years ago. And he's been a consistent source of inspiration and motivation. So I strongly encourage you all to keep up with Mark on his podcast and just what he's constantly putting out, because it's something that's been a constant inspiration to me in my career. One of the things I want to say is when you're on the exponential, it's really hard to see the curve. So what we've seen since I've joined this movement around confidential is an exponential. We've seen exponential adoption taking place. And it's difficult to see that curve, but this year for sure, like everything Mark just walked through around all these confidential services that Microsoft's adopting, for all of you who've been here to see TikTok and Meta, and most recently Apple, who's now released the world's largest confidential AI deployment across billions of devices, clearly we're on the exponential curve. So on that topic, I want to introduce our next two speakers. And these two speakers often co-present with one another at Confidential Computing Summit, which makes for a fantastic session and also like the cutest dynamic duo you've ever seen. So let me introduce, once again, Nellie Porter and Anand Pashupati, who's the Vice President and General Manager of Intel Product Assurance and Security at Intel. I'm so happy to have them both here together. Thank you.
And it's all orchestrated. I will start and Anand will finish. So we will be talking today about future and future-proofing confidential AI. And again, today, inspired by Mark Ruzinovic's bravery, he usually presents demo live. So I will try this time to do the same and present to you very fun live demo as well, Mark. Okay, let me start. So again, you know who we are, and Anand will join me momentarily. So when our customers coming to us and talking about confidential AI, they have three things in mind. Number one, they want to ensure that our most and highly privileged administrators would not be able to see the data, the models, or agents that they develop on GCP and deploy to GCP. They also demand that their highly privileged admins would not see data and models because they want to isolate their own highly privileged insiders from these things. And they want to ensure that it's not contractual agreements. It's actually hardware enforced, attested, and verifiable capability and policies that we will deliver to them. And again, we are not talking about confidential VMs anymore. We're talking about confidential systems. And those systems is actually including CPUs, confidential head. Again, it's built on hardware capability coming from Intel and AMD and other vendors, connected to GPUs, NVIDIA GPUs, and again, the communication between them, network storage, all confidential. And with new technology, exactly as mentioned before, TDs, when all of this encryption is happening in hardware, we see significant ability to provide performant, latency-free capability to our customers. So we, as Google, and honestly every other cloud provider, have different GPU capability, different confidential system for every single AI workload. We started with H100s. We enabled single GPU because we didn't have ability to provide performant communication between multiple nodes. We moved to Blackwell. Confidential B200 right now is used by a few customers. One of them you already know is Apple and a few others, but we will bring it to a much broader set of customers as we're working on that. And literally today or a few days ago, we announced availability in public preview our mid-size GPUs. Our customers bring in their domain specific models and agents that need those mid-sized GPUs. They don't need these multi-GPU monsters. So we bring in this confidential GPU to them, combine, and again, with our compute services in our Kubernetes GKE services together. Everybody talk about sovereignty. So no surprise, it's definitely significant effort and investment on our side. Google has multiple offers for customers. We have ability to provide for them distributed cloud environment when they can take multiple racks and again deploy in their data centers. We offer Gemini for those customers, and as you can imagine, Gemini required significant protection. So we're running Gemini in confidential computing environments to ensure that this IP that we highly value, exactly as IP of our customers, is protected. We also have in France and Germany dedicated cloud environments run completely by different partner operator, ensures that Google and Google insiders never have access to any of services and capabilities over there. And from my specific team, because I own encryption in Google, we're also introducing for sovereign customers this what we call confidential external key manager. And external key manager is the ability for customers to have full possession, control, and transparency for their keys. We're utilizing confidential compute environments for this capability and also protecting every single cache of their data encryption keys in our possession to ensure it's fully confidential. And when I'm talking about anything cryptography related, I can't miss my wonderful Wally. So again, as you can imagine, the cryptography is now not only AI coming toward us, but also advances in quantum computing is becoming absolutely possible. Google introduced dates, commitment to our customers. We will move all our services, all of them by 2029, fully to post-quantum cryptography. And it means internally, we need to do it much sooner. And it's significant undertaking for us and industry and our customers. We've done some good jobs there because all our traffic internal for all customers' data is already quantum safe. We also use Chrome. If you use Chrome, you're in good shape. And also all our external, again, networking systems, load balancers, and everybody is also quantum capable. So we are moving really heavily in the world when post-quantum is becoming reality. So to again summarize all of that, because we don't have too much time, data in mind, as I started this conversation, is very much in mind for us. We're also talking about sovereignty and capabilities that confidential compute can offer for sovereignty, and post-quantum readiness in absolutely critical part that all of us need to contribute to. And now, demo. Let's see how I will do it. Can we switch to my system, please? My password was not revealed. Good shape. Okay. Okay. Interesting. Okay. Please. Yes. Good. Okay, so the demo is called Data Inline, no surprise, in agentic AI. And the use case that I want to present to you in this short demo is very basic. Company A and Company B. Company A is evaluating Company B for their M&A evaluation, and there's usually Company B sharing every single possible sensitive piece of data that they possess, the code, their environments, everything, their business, revenue numbers, everything possible. The worry that we all have and our customers is memorization. Memorization and decay, because this data is actually in agents' minds. And when, again, distillation happening, all of this data is stored. So re-engaged agents would be able to use it. In this use case, I prepared my environment, so you will not spend too much time waiting. But I have, again, confidential TEs running. In this confidential TEs, I will run 2 agents that will do this evaluation, M&A evaluation, because time will come when those intelligent agents will do this work for us. So you will see it live, and we'll see what we will do. Also, those agents have their dedicated keys. We call it auto key. It's generated for those agents, so they would be able to protect those memory distillation information that coming to, again, file store or SSD. So let me simulate, again, those agents. So 2 agents in this particular thing. So audit lead agent is continue to analyzing, and code agent is also analyzing. And the sound is exactly the right, because the drama is coming. I love that. It was not staged. So context window reached 100%, because it's so much data that they actually processing. And what will happen right now, distillation, again, event will hit. And now the whole data, or partially all of the data in their active memory, will be shoved into LLM to provide the most important facts that those agents need to remember to continue their investigation. In my case, the agents, they're not malicious. They encrypt this data. So as you can see in my demo, if I will verify the decryption is happening, and those agents would be able to continue evaluate the documents that they need. But in case M&A will not go through, or you need to remove this piece of memory from agents' minds, you crypto shred it. And I think it's one of the most important things that we need to remember, ability to clean this memory. Short-term memory and long-term memory. And short-term memory, as you can imagine, can be cleaned when I will kill my CVMs, my TEs. But for long-term memory, I'm crypto shredding those keys. So now you will see that this demo is not fake, because I may fail when I will verify the wiped agent memory is actually wiped. Maybe it's not, because as you can see. Okay, let me try again. We again have some time until we percolated all of these disabling things. Okay, one more time. Come on. The final time, I'm sure it will happen. Please be with me. Yay! Okay, so decryption happened. Thank you. Decryption happened, and we finally get rid of these things. So if agents will continue working on this particular data and this particular code, we can rotate the key and continue running these environments. But when we don't want that and want to kill everything, we're simply destroying the environment. So it's how we'll ensure that data that our agents have in their mind is actually not only protected, but deterministically destroyed. Now, the next, we will see, where's my clicker? Now I want to switch to the slides, please. And Anand, please join me.
You know, it's a tough act to follow when you have to follow Mark and Nelly. But I guess as a foundational provider, that's the price you pay. My name is Anand Pashupati. I run product assurance and security for Intel. I was on the stage 2 years ago where we were talking about how to find the money with confidential computing. I was giving all these examples. One of them was Mark's credit card example of how people are protecting valuable assets with confidential computing. And at that time, we had started talking about the importance of AI. It was just beginning. Everybody was saying that's the fuel that's going to drive confidential computing. And here we are today. When you look at some of the research data, 75% of the enterprises are using some form of confidential computing. And from an Intel perspective, trust domain extension, which is a foundational technology for confidential computing, is being used by my friends at Microsoft, at Google. You see all the other global cloud leaders doing it. Top enterprise environments are using Intel TDX. And we have a great partnership with NVIDIA from a confidential AI perspective. I still believe AI is at a tipping point. And there is a significant amount of friction that exists from just people trusting the technology, regulatory compliance, and just the protection of the data and models. And this friction has to be eliminated, and I have an assertion that Intel TDX is your WD-40 to eliminate this friction, because it gives you hardware-based isolation so that nobody can see what's actually happening inside the confidential VM. Your infrastructure provider cannot. Nobody can inspect the workload. So that's the isolation piece. The attestation, Mark talked about it, Nelly talked about it. It's a very critical element where you can actually attest to the integrity of your confidential VM system. And last but not least, you hold the keys. Pardon the pun. You hold the keys to your data, and you control who has access to it. Now, if you just look at building on this stair step from towards value, the value really is revenue, efficiency, gains like that. But it has to be built on some level of trust and safety. The utility will come through training and tools and all that. But how do you make sure that the infrastructure is trustworthy? And this is where Intel TDX comes in, because it gives you that isolation, the attestation, and the control to make sure that you can, as a customer of the system, focus on value. There are a range of confidential AI solutions that are available today. So if you just use the CPU with AMX, which is the active matrix extension technology from Intel, you get about 6x against a system that doesn't use it. And it's really for small language models, it's for machine learning, agents, etc. But if you want to get a system which includes a GPU for larger language models, a bounce buffer or an encrypted bounce buffer solution is what is available today at GCP as well, where you can now share data between the CPU and the GPU, but with software. And as my speakers before talked about, the TDIS protocol is coming, and we are building our TDX Connect solution with it, where you'll get line rate traffic between the CPU and the GPU. And at the end of the day, all of this is wrapped around with Intel Trust Authority, which gives you independent attestation from a multi-cloud, hybrid cloud environment. And towards the GPU spectrum, you get one attestation. So you get the attestation for the system rather than one individually from the CPU and one individually from the GPU. Okay. The other topic we kind of touched upon was data sovereignty. A lot of people have been talking about data sovereignty more from a location perspective, that if I'm within the location of a country, the sovereignty of a country, my data gets protected. But then at the end of the day, one simple mistake, one simple configuration issue, that data will get exfiltrated to regions that it's not supposed to go to. So you need to give access to that control in order to get complete data sovereignty. And this is where my assertion is Intel TDX also plays a role, because along with geolocation and with verification that the data is actually protected, because you control it, it's the same, isolation, attestation, and control, you can give full data sovereignty. I'm going to switch topics to PQC for a second. Intel, again, as a foundational hardware provider, gives you two different approaches to PQC. The first one is just how do we support PQC in our platform itself? And that conversion started with Xeon 6. And we will go through this transition till 2029, where all future platform generations will support PQC. Now, we are also trying to accelerate algorithms in hardware, and we support AES 256 today. You can use that acceleration in order to protect against harvest now, decrypt later attacks, and we'll continue on that journey as we add additional algorithms to accelerate. The bottom line of all of this is I'm with Mark. I think this year, if not in the next 12 months, is going to be an amazing time for all of us to be in this industry, because AI is absolutely going to fuel confidential computing. Thank you for listening to me. It's great to be here, and we'll continue the conversation.
Okay, so our next speaker is a fellow San Diegan. He and I get together, we drink San Diego IPAs, we have walks on the beach, and we eat California burritos together. That's actually not true, but it could be true. It could be true in the future. Let me introduce Hugo Romero, who's a fellow and corporate vice president of security and architecture at AMD, where he leads the end-to-end product security strategy across hardware and software. Today, Hugo's going to be sharing with us about protecting data at the agentic AI era. And we also were very proud to make an announcement with AMD today around agent trust and some other stuff that we're doing. So check that out online. Hugo, come on up.
Good morning. Generally excited to be here again. I think this is the year, Anand and Mark said, the year that I think confidential computing is going to be mainstream. Yes, Aaron, we need to get together. We've been talking about it for a while. We never get together. Today, I'm going to start with talking about something that happened. It happened last year. A company was testing an agent, and they were building an application. They had a code freeze in place and explicit instructions to not modify anything. The agent was in the live environment, had access, continued to do stuff, ended up deleting a commercial database. So the company, to be fair, they owned it. They put in the right safeguards, the right permissions. But really, this really highlights where the era that we're going into. These agents are no longer just generating code, answering questions. They're taking actions on our behalf. So that's a broader question. really the broader lesson is going to be, how are we going to protect against that? This is the agentic era. So if you think about how it evolved over time, we went from a place to just AI was answering rule-based scripted systems, went to virtual assistants, then went into chatbots, then AI automating things with AI and tools. And today we're in the autonomous agent era, where now the question is, what are we going to allow these agents to do for us? Because once they act, we need to follow the workflow and verify and attest that they're doing the right things at the right places. As agents become more autonomous, more steps, more tools, more coordination is happening. That's what makes them agentic. They're deciding and they're acting. A lot of this coordination is now shifting to the CPU again, because that's where a lot of these sensitive data and APIs are. So the more these workflows are shifting to the CPU, the more orchestration is happening, the more the attack surface is opening up. So if you think about what agentic means, that means these agents are going to need access to tools, credentials, sensitive data, APIs, actions, all really to create this business impact of new ways of doing things, which is exactly what technology is evolving to. So we need to follow that workflow. We need to attest the workflow. I'm going to highlight an example here to illustrate. It's in a financial industry example. A woman sends out a prompt and says, please rebalance my portfolio before earnings. This kicks off a series of agentic workflows. There's going to be an orchestrated agent that is now going to try to interface with her portfolio, that's going to go look at her portfolio. It's going to be a interface with a compliance agent, execution agent. That execution agent is going to have access to trading API. And all these places, as you can see, there's multiple ways where we can have some security incident, whether it's injecting a prompt or it's really interfacing or having an agent that has extra permissions to do different things. All these things are really expanding the ability to have breaches. So what can we do about it? So this is really the rest of the talk is based on this. What we want to do, we want to make sure that we build an attestation gate, that we can actually attest these individual agents, not only to see who they are, but really to know, are they acting properly? Are they executing in the right environment? Have they been tampered with? And this is essentially what confidential compute does. So let's connect the dots. We're going to need an agent, has to have access, and we want to make sure that it verifies that it hasn't been tampered with, that it's valid, it has the right permissions. This is something that we need to verify, but how do you verify? We really can't trust software to verify that. We're going to need to root it in the hardware. The hardware is going to have to be the one that really gives us that assurance that this hasn't been tampered with, and it's really running the way we want it to run. The good thing, this is not new. You know, AMD has been making confidential compute products since 2017, 5 generations of server CPUs, production at scale. And really, one of the big things that we do understand is confidential computing is not just our foundation, it's a whole ecosystem. Really, we're already production at scale with the major cloud providers. And one of the big things that we really believe is security. We don't want to see it as a black box. Security, we really understand that we need to be transparent. So we focus a lot on open standards, community work, because we feel that that's the way we're going to give more assurance to the world about confidential computing and the benefits of that. The beauty about the confidential computing hardware is that we have multiple ways of using it to protect your workflow. You could optimize your workflow. So here I'm going to share like 3 patterns. One pattern being taking each agent and putting them in an individual confidential VM. That gives you maximum isolation. You know, they get own key, own measurement, and it gives you the ability to contain any breach there. Second pattern could be you could create a virtual VM that has the orchestration, the control plane, and builds agents within there. Gives you a little bit more high density, lower overhead. And an emerging model that's coming up, it's a hybrid model where you have one orchestrator VM that kicks off ephemeral, you know, confidential VMs that get started and killed once they complete their task. On its own, confidential computing is really the foundation. But it's really, we see it as 3 layers, right? So the first one being the agents, the tools, the data, the APIs, the actions. And the middle layer is where our partners come in. Our partners provide the policy enforcement, supervision, evidence, auditability. And at the bottom, of course, is AMD's trust execution, isolation, and attestation. I want to zoom in the middle layer and talk about some examples of our partners. So I will start with Ajuna. Ajuna's built this, their control plane is in a confidential compute environment, and from there, they're able to watch the different agents and test them to that within prompt injection, policy, integrity, or just auditability. Another approach is opaque. We heard Aaron talk about it, my drinking buddy in the future. But their approach is really that you set the rules and you get proof it actually was enforced. Every agent gets their own CVM, but then they go in there and create the ability to verify the agent before it starts, enforces the policies, and it creates an auditable record that you can hire a third party to audit what happened across the board. So not every agentic flow is going to be working in the cloud. Some of the needs are going to be different, and sometimes the data, the workflows have to be closer to the operations. One example could be low latency at the source, think manufacturing, edge AI inference, think telecom, and regular sovereign data that we've been talking about earlier today, that some of the stuff that has to happen in either healthcare or a nation state wants to protect a certain technology, and an operational continuity. Utility companies where you can't depend on having an internet connection. So when AI runs closer, you need to still verify and validate those workflows. And that's exactly what Azure Local comes in. Azure Local is as Mark mentioned, it's a way for us to really connect these different type of environments in one way, whether it's public cloud, hybrid on-prem, or edge disconnected air-gap networks. The beautiful part about this is that it's the same foundation. STV across the board, and you could still do the same kind of thing, but across the board in a hybrid environment where you have still secure provisioning, guest integrity, composite attestation, and policy-based key release. There's going to be another talk here in the Gold Ballroom at 1:15. I invite you guys to go in there and hear more about the details about Azure Local. So I want to finish the talk with 3 takeaways. One is, again, agentic AI is changing the way we need to protect the data. We need to follow the workflow. 2, there's a proven foundation SCV has a proven foundation to build to protect that workflow across the board from cloud to local. And the third is that our partners are already providing very good solutions to really take that governance and make it a reality. My last takeaway here is I want you to kind of think about the example of the woman who just sent 5 words in a prompt, and all the data flow in agentic that got manipulated and potentially exposed. Think about that. Think about that workflow is one workflow. In your organization, there's going to be many workflows already happening. The decision to be agentic is already done. So we're going to go agentic. It's already done. It's already in play. It's a decision is, are we going to verify in the trust model, or we're just going to assume that it's trusted? Thank you.
Thank you, Hugo. Okay, thank you, Hugo. And if any of you are visiting San Diego, Hugo and I will treat you to a California burrito and a walk on the beach. Just let us know. I want to direct you all to our coffee break session. So I want you all to go mingle, talk to the sponsors, enjoy yourself, learn something new. Let's build something great. Be back here at 10:40. 10:40. Okay, welcome back, everybody. And I say welcome back, everybody, to the people in the hallways. Welcome back, everybody. Caw-caw! Caw-caw! Let's bring everybody in. Caw-caw! All right, so I want everybody to be here for our next speaker, Mike Bursell, who's the executive director of the Confidential Computing Consortium, the organization dedicated to advancing and standardizing the technology and hosted at the Linux Foundation. For those of you who are unfamiliar, which I'm sure most of you are familiar with the CCC, the Confidential Computing Consortium, it is the working group within the Linux Foundation that's advancing the adoption of confidential computing. They've been a pioneer. I have learned tremendous amounts of information from the CCC, so I strongly encourage you all to follow the CCC and also follow Mike Bursell. Come on up, Mike Bursell.
Hi, folks. So great to be here. I don't live in San Diego, but I might take you up at one point. So what a thing. I think here I'm preaching to the choir, right? Most of the people here know and believe in confidential computing, or you wouldn't be here. But I'm also guessing that most of the people here talk to customers or speak or work with people who speak to customers and need to be able to promote what we do and explain what we do to them. And that's kind of where I'm kind of trying to go with this presentation. So we came up with this, agentic AI is running our infrastructure. Who's accountable when it goes wrong? And the answer is, it's not me, right? The answer is, it's you. And this, I mean, it may not be you, but it's going to be your customers. And this, if you're talking to CISOs or security architects or board members or auditors, this is what we need to get across. We've had some fantastic, very complicated diagrams. I'm a security architect. I love that sort of stuff. What I want to do is bring in some simpler messages that we can take across to the people we work with if we're going to make everything confidential computing universal this year, particularly, right? And this is the first thing we need to be able to say, that your infrastructure already looks like this. It's AI agents talking to everything everywhere. And if it doesn't, it will very soon, or you're done. You're just done. You're just done. Because everyone else is going to look like this. Because AI is everywhere. It's touching absolutely everything. And we also know that traditional defenses fail. I was going to say the network perimeter is dead and host perimeter is dead, but I was talked out of that. Because we'll still need them, right? They're still important to have these pieces. But it isn't enough. And the other thing is that reactive defense isn't enough because we can't be fast enough. There's an asymmetry that is introduced when AI gets into the picture. Even if we're using AI to defend ourselves, the number of people coming at us from different directions with AI means that we can't react fast enough. Oh, and the other thing is, traditional virtualization doesn't truly protect the stuff that you need to be keeping safe. So, enter the Linux Foundation's Confidential Computing Consortium. Our job is to promote the work that everyone in this room, everyone watching, everyone in the overflow rooms does, which is confidential computing, the technology, the standards, working with regulators, working on open source. We're part of the Linux Foundation. We believe in open source. I'm not sure we've talked enough about open source yet today. If we're talking about trusted computing bases and all those other bits and pieces, in order to have that trust, we need things to be open source. And so that is why open source is really important in this world. We also sponsor academic research. That's something that we've just started doing. We put out a call for submissions, expecting 4 to 6 submissions, had 37, and then 7 more came the day we closed. So that's going on a lot. We're also a safe place for technical discussions. a number of the people who have spoken already are competitors with each other, right? They and we work together within the Confidential Computing Consortium because the Linux Foundation is set up to allow us to have these conversations. We can talk about technical things, we can even talk about some business things because we're part of the Linux Foundation, which gives us the safe space to do that. And we absolutely try to foster and work on thought leadership in this space as well. And part of what we need to be explaining to people is there is this architectural shift from reactive security. You've got software, you've got processes, you've got procedures. These are all good things, but they're not fast enough, they're not good enough, and they're not verifiable enough. And so this is where the cryptographic attestation and the hardware isolation, which is part and parcel of confidential computing, allows us to build a stack with all, as have been shown by some of the speakers already, which we can rely on, and that's where we need to build. We need to build on the top of that stack, and your customers need to understand that this is what they need to build. On top of a stack which is rooted in and supported by and built together with confidential computing. This is the story we need to tell before maybe we go into the really complex stuff about why confidential computing is important. So last week I was in Mumbai, don't talk to me about jet lagged, and before that I've been to a bunch of other conferences as well, and AI has just realized that security is a bit of a thing. About time, frankly. I'm a security architect, and it's taken a while. They are all over Willison's lethal trifecta, which sounds like some sort of Harry Potter thing, but it isn't. And it's very good. It's about, there's 3 different things you need to worry about, and it's kind of a retake on the CIA triad, if you know your security architecture: confidentiality and integrity and availability. But it's irrelevant if you don't get the infrastructure right. And this is a story we need to explain to folks, right? That if they don't get the bottom stuff right, you can ignore this because everything's gone anyway. So if the RAM is unprotected, your confidential data, the sensitive context, all of it is available. And I want to show a really, really, really simple example. And thanks to Hugo for kind of setting me up with this one, right? So I've got an MCP agent which is talking to an MCP server, and I want to buy 500 Mike Co stock. Of course, Mike Co is really big, and it's, retailing about $7.50. No surprise there. And I'm going to buy it for lf.org because they believe in me, and that Mike Co, so not me, of course, and so they want to do that. And there's the bank account. I made up those numbers. Don't try and use that. It's not going to get you anywhere. So just to say, okay. And so the agent goes to the server and says, use this stuff, right? That's great. There's so many things that can go wrong, I don't know where to start. But just change that number, right? And everything we've tried to do goes to pieces. But that, just change your buy to a sell, make the numbers different, buy a different stock at a different number on behalf of someone else, and put it somewhere else as well. These are the things that we are beginning to trust our agents with, and this is what will happen if we don't protect what we're doing properly. And this is ignoring stuff that could be happening on the agent side, any sub-agents, all of those sorts of things. So this is the picture we can show our customers. We put a nice green safe box around that bit, and that bit is now protected. Don't let's not pretend there's other stuff that that could go wrong, or that we can't, that also needs fixing. But defense in depth, we get that. We got the integrity protection. You can't make changes. We've got confidentiality protection. You can't take stuff out. And we've got the attestation, which proves that we've done this to all the people who need to know it. And this means we can start talking about all of these sovereignty bits and pieces, right? It's because sovereignty isn't just about national sovereignty. It's not just about, UK companies being protected from scary US companies. We're allies, it's fine. There's a lot more to it. It's also organizational sovereignty. If you talk to a multinational who operates in different countries, they need to be putting controls in so that things don't go across borders where they shouldn't. But personal sovereignty as well. I want to make sure that my data is protected, that my identity is protected, that my financial, my health, my family data is protected. That all comes in. And of course, it plays with the agentic AI. So it's not just your data, it's your processes which also need that protection and that proof. So at the CCC, we are trying to lead in this area to provide the opportunity for companies like yours to get involved in these conversations, to push your view, to learn from other people, to work with regulators, to work with standards bodies. If you have open source work that you want to put into in a safe place which can get support from all the things we can do at the Linux Foundation, we do that. I've already talked about working together across the industry. And also we're working with regulators worldwide to make sure they understand how important this is, and to act as a block rather than lots of different individual voices. So these are the things we do. And if any of these matter to you, I would like to talk to you and find out how you can become a member, what we can do for you, what you can do for us, and what we can do together to aid the commonwealth of the industry and of the ecosystem. So what do we need to say to our customers? What do we need to say to them that they need to change? Well, they can't wait for security to catch up anymore. Yes, they want to be doing AI, but they mustn't just say, oh, we'll do this bit now and it'll be fine. It will not be fine. We need to tell them they need to demand these cryptographic guarantees, which are provided by confidential computing, and to prioritize that hardware-rooted trust, which we've heard about from the other speakers already. All of the stuff they've said is absolutely on point, love it completely. Sometimes we need to be able to say it simply to folks, and these are one way of saying that to them. So that's me. I decided to run short, make it punchy, give some space for other folks. I would love to meet you, love to find out what you're doing, and love to talk to you about confidential computing and the Linux Foundation. Thank you very much.
Thank you, Mike. So I'm so thrilled to have our next speaker here. She's someone who has been building out AI programs at a nation-state scale. And she thinks about sovereignty at a global level. She's a world-renowned cryptographer, a Princeton PhD. She's the CEO of the UAE Technology Institute, TII, I always forget what TII, Technology Innovation Institute. Yes, I got it. And I'm really happy to have her come all the way from Abu Dhabi. Please welcome Dr. Najwa Raj.
Hello, everyone. I'm not sure whether to say good morning, good afternoon. I think Mike, or good evening, actually, it's in Abu Dhabi. Mike mentioned jet lag. So you would have to excuse me. I'm not going to walk much. So the jet lag is hitting hard. But first, I would like to thank the Linux Foundation and Aaron for all the hospitality and for welcoming us over here. I would like to give you today a flavor about what we're doing at the Technology Innovation Institute when it comes to confidential AI. Fascinating talks before. We heard a lot about hardware-rooted security, about trusted execution environment. And I love where Mike finished, because this is what I'm going to present, where we want to move from confidential AI to be policy-based to actually be rooted in cryptographic guarantees. So obviously, AI is embedded in every aspect of society today. We see it in healthcare, we see it in government, we see it in national defense. However, if we think about the most valuable data that we have today, it's still not at the disposition of AI. And the reason is not algorithms, the reason is not compute, the reason is actually trust. And this is where the whole topic of confidential AI, which we have been hearing about it, I'm not going to preach for it, comes into play. Everybody is excited about using AI, but when it comes to sharing data, this is where hesitance comes in. Hospitals want to protect patient information, banks want to protect financial information, governments want to protect national sovereignty, national secrets. Companies want to protect IP and they want to protect trade secrets. But really, AI's greatest potential is in connecting knowledge across organizations. And this is where confidential AI comes to make these policies, to allow data to remain protected at inference time, to allow it to remain protected at training time, and also to allow to have some sort of trust for us to know who we're interacting to, especially as AI is moving progressively into agentic platforms. And in order to address the topic of confidential AI, and as we elevate them in our work that we are doing in the Technology Innovation Institute, we look at it across three pillars. There is the data protection when we are using AI. Today, when we do a query, the minute it leaves our device, this query, more often than not, it gets exposed in plain text into some hyperscaler infrastructure, into other devices, and then we don't know where that information is being leveraged and is being used. There is data protection at the moment of training. Today, valuable information and sensitive information, it sits in silos. Because of the sensitivity and sometimes because of regulations, collaboration is almost impossible, and we're not leveraging the sum of all when it comes to intelligence being derived from this data. And then finally, as AI is moving into agents and it's progressing into those agentic platforms, more often than not today, because we don't have a uniform or a universal standard for identity, we don't know what we are interacting with, we don't know who we are interacting with, and most importantly, we don't have verifiable proofs on the actions or the decisions that those agents are making. So the way we are addressing it is through three pillars. The first one is, how do we deal with inference? And this is where we are going back to fully homomorphic encryption, which I'm sure all of you are aware of. We think about it as complementary to trusted execution environment, and this is where we are collaborating with Opaque on. When it comes to training, we look into federated learning in combination with multi-party computation, and this is where we talk about private federated learning. And then finally, authentication and trust, where we're looking into the identity of agents and the authentication and identifications of agents with large agentic ecosystems. Maybe a parenthesis is, obviously this work is not coming from me, it's coming from the team, and this is where I have Dr. Victor here in the room, and you will hear more about the details of the technologies, and Dr. Shauki as well from our team, and collectively we are working on these technologies. We see this as a full stack, as an AI stack, and all of these technologies put together, they provide us with this confidential AI technologies Data moves into models move into agents, and with this AI stack and another technology that we're working on the control plane of securities, put on top of technology of trusted execution environment and through our partnerships with Opaque, and also with the topic of the day, I would say post-quantum security, this is where we are providing this end-to-end stack across AI and the whole life cycle of AI. Allow me to go into the details of each one of them in a very quick manner, and I'm happy to discuss those in details later on. First, let's talk about inference. VEIL stands for Versatile Encrypted Inference Library, and at its base, we have fully homomorphic encryptions. Queries, they include sensitive data, they include data about new products, they include data about customers, and they include other data. And sometimes the confidentiality of the query itself, it contains more or most sensitive information more than a database query, or actually more than a database content. Query leakage can reveal more than the query itself. And then in most cases, we will be at violations of regulatory and compliance risks. What fully homomorphic encryption enables, one, it enables computation over encrypted data. So instead of the query going into plain text and its content being exposed to the cloud or to the hyperscaler, the data remains encrypted and the inference of the data remains encrypted, the result is generated, and then it is returned encrypted over the user and over whoever sent the query. FHE-based operations do not require iteration between untrusted parties in order to perform the computations. It's a one-one with the server, and it is quantum safe, protecting inference against store now, decrypt later, and all the future quantum threats. You may ask, okay, FHE has been there for a while. It is computationally expensive. And really what excites me most about this technology that we are doing today is despite all the computational overhead of FHE, with the algorithmic improvements and with the usage of hardware accelerators, it becomes something that can be usable and that can be deployable. And this is where we have developed a library that we can make available for medical applications. We have developed it in the form of an SDK, and it has been used by our clients for skin cancer detection and then for other type of medical analysis. Moving on into the training part, because really inference is half of the equation, or it is part of the equation, and this is where we bring in the concept of private federated learning, and this is where we look into privacy when it comes to the training phase. We have multiple issues today. There is one, the fact that whether we're talking about healthcare, whether we're talking about finance, whether we're talking about governments, that all of them sit today on very valuable information. Because of the sensitivities, because of local and international privacy law, this information being siloed in environments and cannot be shared, we are losing a lot on the combined and the common intelligence. Privacy regulations, as I mentioned, they put limitations on the sharing of data. And then even if you say, okay, we can use federated learning, it still requires trusting the aggregation server, and then which means that if you have a malicious or if you have a consensus server, the reconstruction of the private training and reconstruction of the aggregated model can be compromised. And this is where PetalGuard comes into the equation in order to solve the reliance on this trusted aggregated server. It tackles the issue of data extraction and conventional federated learning. We, unlike differential privacy, which still lacks when it comes to local updates and yielding low accuracies, and then it also tackles the issues of data extraction in the usual federated learning that we know about. And the way we do it, and I think we heard about multi-party computation earlier during the day, PetalGuard combines federated learning and multi-party computation One, in order to perform decentralized aggregation, where locally trained models are never sent to a central aggregator. However, aggregations run over random shares that are computed, and then they are tackled through MPC protocols. We have zero data exposure. We have end-to-end cryptographic guarantees, no accuracy loss. We go through multiple iterations of this federated learning through the aggregators and through the final aggregator, and it is modular and scalable. What I'm talking about is actually something that's not theoretical. I'm not talking about university research. It's something that's deployable. Federated learning is available through the AWS marketplace and directly through us being deployed with clients. And we are collaborating with Opaque, and we are deploying it with our post-quantum cryptography in order to provide, through multi-party computation and information theoretic security. All the communication are protected using post-quantum crypto, leveraging the cryptographic libraries that we have developed in TII. And then finally, we have Prisme, because AI authentication, identity management, as we know it today in the public key infrastructure, is something that cannot deal with the ephemeral nature of agents and something that cannot allow us this authentication and the identity management of agents themselves. Without going to the problems themselves, I think we are all very well aware of them. Is one, agents are of ephemeral nature. There is really no stable identity. Without this verified identity that is associated with agents, a malicious service can impersonate a trusted agent, let alone all the rights that an agent, all the root access that an agent can have over our platform, and then standards are fragmented. And this is where our agent's identity and access management solution comes in, which is Prisme. It unifies all the standards that we know of today, whether it is PIFE, whether it is MCP, whether it is A2A, and provide us with a way for every agent to have an identity, every process and every transaction to be auditable and to be attested for, and then this is how we establish trust in the into the agents and the agentic processes that are running into our platform. We are complemented, Prisme, and ironically, will almost have the same name with a platform that is called Agents Guard, and it is really a control plane security that is running, putting the policies, putting the autonomy budget for the agents that are running on our platform. I went fast through these technologies. Our vision for the future is for agentic platforms to have these three components: to provide private training, to provide private inference, and for every agent to be attested for and to be authenticated using its identity. We see this as a whole ecosystem of trust. I do believe that the future of AI is not about who's going to build the largest model. It's really about us as scientists and technologists to develop this trust ecosystem where we can have a trusted execution of those agents on our machines. So the future of AI will be built on trust. And this trust should not only be in policies, should not be in governance frameworks. It should really be built on cryptographic guarantees. With this, I end. Thank you very much for listening to me, for giving me the opportunity to show you very briefly what we are doing at the Technology Innovation Institute. And I'm happy to have further discussions with you. Thank you.
Please sit. Please run the panel.
Sure.
So we're going to have our opening keynote panel now. And I'm so grateful that we have Dr. Araj here. As some of you may be aware, in the United Arab Emirates, they are some of the most forward AI adopters. In fact, there's a national mandate to adopt autonomous AI agents for 50% of the workflows across government agencies and enterprises. So there really is nobody more accomplished and experienced in rolling out nation-state scale AI, as Dr. Araj and our colleagues are here, who are also here. So I encourage you to meet with them and speak with them. So on this very topic, the next panel is on the sovereign stack, nations, enterprises, and the demand for verifiable AI. And we have basically like a super group like the Traveling Wilburys who are going to come together and talk about this. And moderating is Frederic Lardenois from the new stack. So Frederic, why don't you come on up, and then you can introduce everybody else that comes on stage. But we've got just a great panel for y'all. I don't think we need them.
Thank you. Sorry we didn't get to talk ahead of time. All right. I'm always afraid somebody's going to keel over here with these bar
so
stools.
difficult.
We've got,
Closer.
two people jet lagged. Hugo's thinking about West Coast IPAs. So, yeah, who knows? Usually when I do these panels, and a lot of moderators say, these panelists don't need any introduction. I think in this case, usually they're lying, but in this case, I think that's true because you've all been on this stage just now. But for those who just came in, maybe missed the panel, can you just briefly introduce yourself?
Nelly Porter, Google.
That's it?
Hugo Romero, AMD.
Mike Bessel, Confidential Computing Consortium.
Najwa Arash, GII.
Mark Sinovich, Microsoft Azure.
All right, that's about the quickest introduction I've ever had at one of these. Usually somebody goes off for 5 minutes. My timer, by the way, says we only have 3 minutes left, so we can fix that at some point. Thank you. So in this panel, we want to talk a little bit where we are with sovereign AI at this point. And so maybe Hugo, you can start with this. We've talked a lot about CPUs and trusted enclaves. But when it comes to AI, we typically talk about, we have to talk about GPUs as well. So maybe we can start with that. Where are we right now when it comes to confidential computing and GPUs? Not just VMs, but GPUs, and I'll get to our other folks.
I think we're missing one representative of this topic on our panel to start this conversation.
Indeed, indeed.
Would you start?
He's sitting down there.
Hugo was going to start.
Yeah, Hugo, if you want to start.
Yeah, okay.
Absolutely.
Yeah, so where we are today is we have the standard for TDISP, right? So we have a TDISP, we have the ability for the CPU to connect with the GPU, right? So we have that, and that's something that's already deployed, right? And then it's something that is going to continue to provide that, and not only for GPUs but other endpoints. So that's something that's going on.
Mm-hmm. Mark, kind of how are you doing that in the cloud at this point? Like, how are you connecting your GPUs to this secure enclave? You've talked about it a little bit, but
Yeah, I mean, so we introduced first the A100 had preliminary support for confidential computing. We introduced that. Then H100s. Now we're looking at what's coming with Vera Rubin, which is very exciting, and MI455 from AMD. Also very exciting parts because that supports TDISP, both of them. It also supports protection over Infinity Fabric or NVLink. So you get this basically can scale confidential AI acceleration, not just from one GPU on a node, but to all the GPUs on the node, to now GPUs across a whole data center. And so that's the unlock for, if you take a look at inference, many of the models today consist of both CPU components as well as they're multimodal and support multiple different submodels that are executing on different GPUs. So you need that connectivity across devices and domains with confidentiality that now this accelerated hardware protocols give us. And then when you talk about training, of course, where you want to protect the model's IP while it's being trained and the data that goes into it, you need potentially scale of hundreds of thousands of GPUs. And so we're well on our way to getting there in the next year.
I think one of the interesting things from my point of view is that when we first started thinking about this, it's kind of a naive thing. We've got a CPU and we probably want to connect a GPU to it. And it's a lot more complex than that. As you've just said, you want to be able to have more than just the one GPU on that machine, and then it goes in that data center and then beyond. But there's also the sort of temporal question about, well, you're not going to put them all on in one go, right? You're going to be adding them at different times and then taking some out. And you need to be able to be sure that you've got a trust fabric that supports that. You know, your attestation at the right times. You talked about deleting things early on and making sure that, you know, as you remove a GPU, it's not going to have access to the right stuff. So there's how you build sort of a composite CPU, GPU things, I think is going to be one of the really important things that we build over the next few years.
Now that we've reached this age of agents as well, you know, not sure you talked about that quite a bit. How has that complicated things for you?
Yeah, actually, so as an institute, we have been building multiple platforms that are based on agents, right? And the way I see and what we're trying to do actually in our agentic platforms, and you will see probably Dr. Shawki talking later about the GeoInt platform that we have developed. We have developed a scientific platform, and we are developing cybersecurity platforms that are based on agents. We are looking into it into a modular fashion. We are putting an architecture together where the main architecture is the harness. We are looking into the autonomous, we have the governance layer, we have the orchestration layer, and we are looking into the autonomous loops and the verification loops. And we are looking into the components that differ from one agentic platform to the other in order to standardize it. Because as you said, it's going to be quite complicated to look into it as different platforms at all time. At the same time, we are aware, and you know, I personally see the same pattern as before, where you have software that's being deployed, and then security comes or confidentiality comes as a second thought. So we're trying to deploy those platforms, keeping in mind what is the controlled security that needs to be done, what are the policies that need to be imposed at the governance layer. What are the checks that you need to put? And then especially when you are running agents that are coming from outside that you didn't develop, that you didn't put the identity, how I'm going, if needed, how I'm going to sandbox them in order to release them if the decisions is verifiable or is verified from a security standpoint. Now the complication comes that, and Aaron mentioned that in the UAE itself, there is a mandate to move into 50% agentic workflows. And this will complicate things tremendously, right? From a cyber perspective, from a privacy perspective, and confidentiality perspective. And this is where we're trying to work with the regulators in order to say, okay, how are we going to impose, or how are we going to put together policies and regulations for confidential AI? Where are you going to use trusted execution environments? Where do you need software in order to check the workflows and to check the execution of those? Where are you going to have to sandbox agents before like they go into the machine, and etc.?
Did you say 50% of workloads are supposed to be agentic as a mandate?
50%, yes. And I don't remember now the year, but yes, 50%. And this has happened almost 2 weeks ago when this became as a law in the country, yeah. So just imagine, you know, we've been talking in the UAE about agents shops, agents boutiques, agents everything, and now we have to move 50% of the government workflows to an agentic, to be agentic, yes.
Yeah, and their security cannot be coming second, right?
And trust me, nobody is thinking about security. That's the problem. Yeah. So it's like you use 50% as agentic, and nobody is talking about security, privacy, confidentiality. We spoke about confidential GPUs. I think this is where now we're starting to think about we need confidential GPUs for some of the workflows that we're going to implement.
Well, Nelly, you're laughing. I know at Google you take security somewhat seriously, I think. But is that your experience as well with when you talk to customers? Is that this confidential computing thing comes second, third, last?
Security, privacy is important topics for most of my customers. But again, because of velocity of and demand that they have from different places to deploy agents and trying to figure out how to deal with that. It's coming usually from CEOs, from board, from CISOs, and usually people on the ground, this, again, normal humans that need to do what they have to do, they absolutely stand how to, again, continue to protect the enterprise's secrets and workflows and bring more agentic AI to the place. So we all talk about, again, the areas of policies, but something we didn't probably talk too much about, something I want to bring to this conversation, is a policy augmented by humans would not work. And the reason why, because we honestly, as humans, have no idea what agents trying to reach out and what they need access to. It's why this identity and access permissions that we're so used to simply would not work. It's like VPN. When you add access to something, it's continuous, those agents will continue to access that. So you need to have human on the loop, not in the loop. Because when we have human saying yes to every single question that agents will say, it's not useful at all. So we need to have ability to put agents to be auditors when the elevation of privilege is happening, when those agents trying to access the secrets or perform some delete database operation, we need to have ability to validate justification why these runtime things need to happen and have some policy in place what allow or disallow in this matter. But it has to be agentic, it has to be scalable, and it has to be trustworthy, so it have to run in confidential environments anyway. But all of this policy gardening and the agentic and the ability to provide the scalable infrastructure with GPU, CPUs, networking, we forgot about networking, storage, all of this system, it's not a confidential TEs anymore, it's the whole entire confidential system. And it's what we need to start, continue to talk and continue to emphasize.
What is still missing in that system? What do we still need to build? And I know, Mark, you talked a little bit about what's coming next, but maybe you can tackle that.
Well, I think a lot of things need to be built still.
How far are we in this process?
Well, and I want to, so there's a couple things, I think, when you talk about specifically about agents, when we talk about governance, I think one of the requirements, which is kind of independent of confidential computing, is being able to have policies around what the agents can and cannot do, and to prevent against prompt injection attacks, as well as prevent execution of consequential actions without some approval, whether that's a human or another system. That's independent. And right now, we don't have those systems in place. Basically, it's human in the loop, just have the agent go do whatever. And if it's going to perform one of those things, a consequential operation, summarize my email, it has access to Teams. It can send a summary of that to whoever, including people that aren't authorized to see the contents of that email. Today, it's the agent decides to do that, human, go approve it. And based off of limited information and all the problems we have with that. So that's one problem that hasn't been fully addressed yet. And there's work that we're doing at Microsoft, and other people like Google are working on it too, to come up with a way to actually implement policy that controls and governs exactly what an agent can do. But the other one I think is interesting is identity aspect, which really hasn't been fully worked out yet. We all talked about it. We all know what we need to do, but it's moving from, whether it's agent or a piece of software, moving away from this concept of identity is something I assign, who it is, to what it is. And it's basically what we're calling workload-based identity. And that's what we're starting on this path, but there's a lot of work to do. But when you talk about an agent, not who the agent is, but what the agent is, that's what dictates what it's able to do and access. And that's only possible with confidential computing, actually measuring and attesting to what this thing is, including its code and configuration, and potentially even policies that allowed it to get to where it is through the supply chain, like we've talked about with the transparency service. All of those things define the what, which is, I think, going to eventually replace, for autonomous systems, humans will be who, software systems will be, and hardware systems will be what.
Yeah.
So on two things. Firstly, if you're interested in trusted workload identity, we have a special interest group in the Confidential Computing Consortium working on that, but hugely important. The second thing that, to both your points actually, both Mark's and Eddie's points about the governance, we need a bottom turtle, right? And to make sure that in the end, something is making the decision. I have concerns about that being both human and AI. AI is because I don't believe that they're fully trustworthy, and I'm not sure we know enough about them to make them trustworthy yet. But on the other hand, humans are too slow, and also we have the Euler click-through problem, right? If I'm sent a thing saying, is it okay for this to do it, and I'm not sure, I'll probably just say yes. And I'm not sure what to do about that. I think there's, as you say, still work to be done.
Yeah. Hugo, you're our hardware representative here. Is there like something you can do there?
Please help us
Hugo's
out.
problem, that's great.
Please help us
So
out.
I really want to just say, like, I gotta repeat, like the foundation is there, like the hardware is there, and that's something that we have because the technology is moving so fast, and I think if we didn't have that strong foundation, it would be in big trouble. So the strong foundation is there, and I think all these questions are going to be answered, and I think there's a lot of good thinking going on it, but I think really that's where we have strong footing, and I feel good about that part because AI is moving so fast, and we all have to be on board the ship, right?
Is it moving too fast for everybody to react when it comes to? Mark, you're saying yes.
Yeah.
Like, are we lagging behind in confidential computing?
I liken the phase that we're in with agentic security to late 1990s internet usage, which is, hey, we know that there's risks, but it doesn't seem like only bad things have happened, so it must not be that high, to, you know, the wake-up calls that we started getting that forced everybody to take internet security much more seriously. We're not there yet with agentic security.
You were shaking. You were saying yes, Nelly.
Completely plus 100 to what Mark said. We not here again, and it will continue to evolve. We need to figure out how to make, and again, whatever Lego blocks we have to solve this puzzle and help, because we have opportunity to help, but it's still, again, exactly +1, identity, access, decision-making. Humans are not, again, really equipped to do that in the time. That's absolutely shrinked for AI decisions. So we need to figure out how to entrust those agents to be the proper arbiters of those decisions. So the only what I will say, humans is who, agents is what, but all of us need to answer why. Why we need to get access to X, Y, Z, and what we will do with that.
There's one other thing I think I need to say, I think I'm contractually obliged to say as a part of the Linux Foundation, which is, yes, we've got the hardware foundation. We also need open source as part of the foundation. We need to have things we can look at, we can check, the community can be part of, the community can look at and know that what we're building on with that hardware allows us, everybody, to have something they can trust in. Without that, it's very difficult to build things, and that is part of what the Confidential Computing Consortium is there for. End of plug.
Sure. And I have no contract with the Linux Foundation, but the Linux Foundation did announce the agent name system today, the ANS, based on the DNS system to give agents identity. So there's all kinds of projects happening there as well, I think. One, maybe switching topics just a little bit. It's, you know, when we're dealing with confidential computing right now, that also means we have to trust the vendors we're working with. And Nashwa, you published an op-ed today in Fortune that I saw earlier today. And in that one you say, and I'm just quoting this here, no single cloud provider or model developer can be the sole authority on trust. Now we've got two cloud providers here, but maybe you can explain that a little bit, what you're saying there.
I think it goes back to what I was explaining before, right? Because today, if you look into how you're doing the training of your model, and I'm not talking about agents over here, I'm talking about the model training you see, and we as an institute, we trained our model, we trained our LLMs, etc. And then all the information that we have used in order to train LLM is open source data. And what we try to get sensitive data, or when we try to get proprietary data and in order to do the training, the first question we were asked is, are you using a hyperscaler infrastructure, or are you using in-country GPUs that are in an air-gapped environment? And whenever you say, okay, I am with a cloud provider where you are exposing your data in plain text and the rest, there is no trust guarantee that there is no leakage of data, there is no exfiltration of data, and you know, like access to the data that you are training with. And I think that along the same token, you can talk about inference. When you are putting your prompt out there in plain text, or when you are including sensitive data in your inference, you cannot trust the hyperscaler, or you cannot trust the provider, regardless what they tell you about the key management system, regardless of what they tell you that you manage your own environment, etc. You cannot put your full trust in there. So this is from that aspect.
Sure. For our cloud providers, how do you feel about that?
We feel very strongly that we are not trying to be trustworthy. The goal for us is to prove and actually do not get our customers to believe that all of what we do is built on our contractual agreements. We want to ensure that we build this environment specifically and investing heavily in the trust infrastructure so that customers can verify every single claim that we are making about access to the data and, again, access to the workloads, environments, AI and not AI based. So I don't think cloud providers as, again, trying to become trustworthy. I know that it's contradiction, but I think we don't need that. To be successful and provide our services to our many, many, many customers, we should not ask them to trust us. We always ask them to verify what we do, and we're trying to provide cryptographic claims for them to do that. Mark?
Well, first, I think there are a lot of customers. We ask our customers to trust us.
You do?
And, you know,
Do they say you're
I mean,
trustworthy?
trust is earned, right? I think in general, trust is a complex equation. It doesn't come with a binary. And some of the ways that we earn customers' trust is through our track record. It's through the actions that we've performed, through the way that we've executed and protected their data and handled it. Another way that we earn customers' trust is with third-party auditing. And this is something that all the cloud providers have, third parties that come and audit us. We also self-audit and make attestations, but we've got third parties, whether it's SOC or ISO or FedRAMP, that are coming in, auditors looking at us and evaluating the claims that we make, and then verifying and making statements. But where we all want to go, and I think this is for our own protection of our own data and our own supply chains and our own infrastructure and our own systems, as well as being able to make stronger claims to customers that they can independently, cryptographically verify, like I talked about in the transparency section, is we want to move to a world where you can go get cryptographic verifiable evidence of the claims that we make. And that's a simple statement, very complex to actually achieve. So we're going to be on this journey for years to get to the point where you can say, this piece of code that's running in production, it's actually, this is the way it's governed, and by the way, here's the way that it was created and built, and what policies determined that it could run and become a what that has access to my data. That is something that we're all building together, and the CCC plays a key role in us standardizing the way that we do that as well.
When it comes to all of this, it's not just trust, but also when I'm a nation state and I'm thinking about sovereign AI, I have maybe some different thoughts about that, because all of the big companies, the chip makers, they're all US based at this point, right? Do you get any pushback from that, where people say, well, especially now in Europe, and we live in a complicated world right now, it's hard to trust you right now, potentially.
By you mean US people or?
Yes, not you. You're excluded. You're good.
I'm not saying that, right?
You're part of us. Don't even pretend.
You're British. You have pups.
Yes,
you're good.
Yes, you're good. Yes.
Okay.
No, but thinking about the clouds especially, but also kind of Hugo on the hardware side.
So sovereignty requirement becoming more and more critical for us to do business globally. And we, global company, we have regions everywhere. And customers have different way to process the sovereignty requirements. So some of them need to have, again, more stronger confidentiality and integrity assurances in our cloud environments. We see that controls that guarantee data residency and our external key management when they have full control over cryptography that they use to protect their data. Some customers prefer to use our fully partner-operated environments in France and Germany, for example, where sovereignty requirements much stricter. Some customers absolutely don't want to use cloud, want, again, air-gapped and completely different. So I think the requirements are different depending on workload, depending on their risk tolerance. But we see that most of customers want to have control. They need to have transparency and resiliency. They want to ensure that whatever will happen, they continue to do business, and it's critically important for them across the board.
Mm-hmm.
If I may add, actually, to what Nelly is saying, as you know, an entity that's not US-based, and this is something that we felt during the crisis that we went through over the past few months. I think sovereignty comes at different layers, right? And you can achieve your sovereignty to an extent if you don't own the infrastructure and if you don't actually own the compute chip. And this is something that, as a non-US entity, I can tell you that this is a problem that we face, right? So you can achieve your sovereignty by having your own models. You can achieve your sovereignty by having your own agentic platform. You can achieve your sovereignty to a very large extent by having your key management system, your cryptographic stack, etc. But there is still a dependency on the compute chips, and also on the infrastructure. And this is where the sovereignty layer stops, actually. And maybe to go back to your previous question, it's also very important for the hyperscalers, for the infrastructure providers, for the compute chip providers to establish this continuity of provisioning this in order to establish this trust loop with the big organization outside the US, right? Today, if, for example, I don't have access to the H200s or the B300s, I'm mostly stuck, right? Or on TPUs, when in the case of Google, I'm mostly stuck. And the reassurance of having this infrastructure available is something that will increase our trust in relying on the hyperscalers and the infrastructure providers.
To reflect on something that Mark said earlier, trust isn't binary, right? It's gradated, and people don't care about security; they care about risk. And digital sovereignty, whether it's national or personal, organizational, is about managing risk. And confidential computing and associated technologies allow you to make different risk decisions. They change where the risk bits live. You're going to need to trust your cloud providers to some degree. You absolutely need to be able to trust your supply chain, your hardware supply chain. But we need also to remember that, if the supply chain or the cloud providers were to just sort of fall over a bit and let the US government see stuff, the reputational damage to them would be enormous, and the risk that they're doing that is so low because of that. So we need to take all of this together. These people take security and risk very, very seriously, and confidential computing is about helping to build that and allow us to reason about risk and mitigate risk as part of our discussions about sovereignty. Mm-hmm. And that absolutely applies to the supply chain as well.
Yeah.
Hugo.
Yeah.
Hugo, can I trust you?
You can trust me for sure. Yeah. So one of the things that we're also working on at AMD is we're building out what we call the the silicon provenance, we're starting to build out that part where we're building out, where we're taking cryptographic measurements from the whole design cycle all the way to the fab. And that's something we're working with Mark to eventually we're going to give you that whole, the whole provenance chain. You can see where that chip was made and every single delta, what happened there. But again, like Mark said, I think you need to trust, but you need to verify. And other things that we're doing also, and also working with Mark, is we've done with OCP, we've done what we call OCP safe, where we actually, audit our code and we have third parties generate stuff, and we cryptographically sign that, so you can always go back and look and see, hey, look, this code was already audited, and you should feel better about our platform. So there's a lot of stuff we're doing there to provide that assurance.
Right. I can trust that it ran on the right chip, that it's got the right governance. Can I trust or can I verify that it ran in the right place as well, in the right geography? Like, where are we with that? And not sure
there's work going on. I'm aware of some early standards around that. I know that the cloud providers are also working on how that is. And I think that's going to continue to matter. I wish it didn't, but I think it will continue to matter because no security is perfect. And there's availability as well as confidentiality and integrity we need to aware, which is something the cloud providers can work on.
Mark, you want to?
Yeah, I mean, so first of all, a claim and a token that says this hardware is running in this data center is something where we can provide. Then it's trust us that we're telling you that this hardware is only authorized to have this claim if it is actually in that right place. We're also thinking further than that to say the hardware itself can attest to where it's located based off of GPS or some other system that ideally is encrypted and has integrity so that you have a higher degree of trust. So, and this is kind of the whole wave of verifiability. It's kind of a line moving where it gets more and more sophisticated. We're able to verify more, and more customers, as the line moves, will demand more verification. And so this is a journey that we're going to be on across all these aspects of what can I verify, how can I verify it. And it starts with the most sensitive workloads and the customers more concerned with risk that go first. Nation states in their clouds, for example, and their workloads, whether it's intelligence or defense, some of the first because human life is at stake very directly, and the whole nation's security is at stake, to everybody following along behind that, basically.
Nelly, just to give you a chance to also, you said we also do that.
So in 2020, 6 years ago, we introduced what we call shielded VMs. Today, all GCP services running in shielded VMs. As part of our VTPM claims, we provide location where this actually VM running, and it's as usual attestations that you can receive from VTPM. You would be able to understand exactly where your workload is running. So it's absolutely in place and customers can get it. Again, the location matter, but probably not as much as workloads is spin up through huge workflows connected in between and through multiple data centers in multiple regions sometimes. So it's interesting to know that it's running right here in my house, but it's probably not sufficient.
All right, quick lightning round to end this. We meet again here next year. What do you hope we don't have to talk about anymore? And what do you hope we can talk about at that point? We'll just go down the line, and you've got 10 seconds because we're already over time.
Okay, so agents, how we will ensure that we will trust them a little more, and most importantly, have control, deterministic control of crypto shred their memory.
Hugo?
I think I think we're going to talk about is all the new innovation of how we're trusting these agents, right? And what we're not going to talk about anymore is any overhead running confidential compute. It should be ubiquitous.
All right. Mike?
Open source, everywhere, transparent and expected. What we're talking about next year, open source everywhere, transparent and expected.
You just want to talk about open source.
I really do, yeah.
So I've already figured that out. No, sure.
Yeah, I think what I wouldn't want to talk about is can I trust an agent that is running on my platform? And what I would like to talk about is standards for identity of agents or workloads.
Yeah, and I said this before, and Hugo kind of said it too. I hope that next year, that the next 12 months is the breakthrough where there's no excuse to not be confidential from a hardware capability perspective. And I think we're right there.
All right. I hope I don't have to talk about agents all next year, but that's a very different question. Thank you all very much. You were great panelists. Thank you. Yes, thank you. Thank you. It was fun. Went a little bit over.
Okay, so it's lunchtime, everyone. I just want to direct you all to the column ballroom, where lunch will be provided for all of you. Go, eat, drink, be merry, and socialize. Yeah.
Thank you so much for spending the time here. And my name is Ren. I'm coming from Azure Confidential Computing as a PM manager. And jointly, we have Ash together with me will do the presentation as well. He is from dev manager from Azure Confidential Computing. Today, we will talk about how to secure the future with our Azure Confidential Computing. Quickly go through the agenda. We will talk about the new product release and some of the new initiatives the team has been actively working on. And later on, we will talk about how we're going to secure and protect customers with confidential VM. We also have an awesome demo to show the confidential AI by working with NVIDIA and also Cryptopia. By the way, since we only have 30 minutes, I probably will go a little bit faster, so feel free to stop me if you have any questions. This is our Azure Confidential Computing product portfolio, which has been shared by Mark previously. The green mark actually is a new product we just announced recently. So first of all, in the left side, we have released a general availability for Intel-based confidential VM, which we introduced the NVMe accelerated for local and also remote storage by connecting with Azure Boost device. We, from the data, you can see the output from the storage has been 5x compared with previous generation, the legacy Stagazi mode, and with 16% latency reduction. And we will have accelerated networking enabled coming very soon for the Intel-based confidential VM. Meanwhile, in the last about 12 months, we are working very hard to expand Azure Confidential Computing, the regional coverage. Till today, we have covered 50 plus Azure regions, including public and also US Gov, and across 140 availability zones. And meanwhile, we also established like Azure Migrate Backup, Azure Site Recovery, all these kind of features be compatible with Azure Confidential VM. Recently, we also announced the general availability of Azure Integrated HSM. Starting from Azure AMD v7 VMs, customer can be able to launch their VM attached with Azure Integrated HSM, which is hardware-baked, certified and by the FIPS 140-3 Level 3 as a key cache, which means customers, they do not need to expose their key in their VM memory in clear text if they want to achieve the performance. So that Azure Integrated HSM basically enable and protect customer keys through the whole life cycles and also providing very high performance for the cryptographic operations. The key usage listed here, including the TLS termination, database encryption, and also signing operations. We do have the demo, which we would like to show how it works. Can basically tell customer do not need to make some of the trade-off from security versus performance. I hope that the volume should be able to go through. Let me see. Okay, wait.
Let's first take a look at the key we created in Azure Key Vault. This key is protected in the cloud by Azure Key Vault and impossible to view. Now let's use it to run 5,000 RSA side operations. This application sends HTTP requests to AKV to perform the RSA operations remotely. As you can see, this workload completed in about 7 seconds. Next, let's run the same workload, this time using Azure Integrated HSM. This application performs secure key release to bring the key from AKV into the local Azure Integrated HSM device, and then uses it to run the RSA operations. As you can see, this workload completed significantly faster, only taking about 0.3 seconds. Today, customers often face a trade-off. Improving performance can mean moving keys into VMs in clear text, which introduces security risks. With Azure Integrated HSM, keys remain in the FIPS 143 validated boundary and get performance comparable to using the key in clear text.
Thank you. And also, one thing I want to mention is, today the Azure Integrated HSM is ready for the general purpose DA and EAV7 VMs. We were working to make sure it will work with confidential VM. Today, it is Windows released. Linux guest OS support will be coming by end of this month. Next one, we will lightly touch on the new initiatives we just talked about is the confidential live migration. Confidential VM today is not being able to live migrate it, but as a cloud provider, live migration is very critical, especially when we do the security update. We want to live migrate customers to the latest, the greatest node with security patch without impacting customer workload. And also, as a cloud vendor, cloud providers, we want to achieve the efficiency when we do the defragmentation. We also need to live migrate customers from one server to another server, but we do not want to, number one, break the confidentiality. Number two, we do not want to give the customer disruption. Here, we have been working with Intel to do, actively working on the confidential VM live migration. And this is a high-level process steps that we will go through. Number one is remote attestation. The remote attestation basically to identify the scenario listed here. The customer confidential VM actually is running on unsecure node. And we have some of node has already been updated. So Azure attestation basically come in to do two things. Number one, they identify the destination of the VM, CVM, will be secure and completely patched with a higher SVN. Number two, they also will attest the migration TD in the destination node, make sure this is running 100% in the TE environment. Once the attestation is success, you can see the migration TD from the sourcing and also destination has been established the communication channel. And then the last step is the confidential VM will be moving from the unsecure node to the patched node without customer even notice. So we do have, I think Mark has demoed the live demo. For the live migration, you can see the customer blackout period is very minimal because we have limited time, so today we will not go through live migration demo, but if we have time, we definitely will happy to go back to the demo if we need. So next one is confidential AI. I think in the previous session, the G42 team comes in and talk about like for the current AI environment, actually the most useful data makes AI is now very useful in the regulated industry is actually precisely the data that we want to protect. That makes confidentiality to protect the customer data end to end, including their model and weights, is very critical. So the demo we want to show today is to see how we can leverage Azure Confidential GPU by protecting the proprietary models and also private data on Azure, Microsoft Azure with NVIDIA Confidential Computing and also Protopia stained glass transform. So the flow basically is looking like this. First of all, the SGT is a stained glass transform provided by Protopia. They basically is stochastically remap all the data, the pixels that we will show it later on, remap the data to protect the customer data before the inferencing, during the inferencing, and also post-inferencing. And also, the Protopia had their own model and weight, basically can guarantee all the remapped data can be perfectly going through the inferencing workload without performance penalty. And a confidential GPU provided by NVIDIA protect the customer model and data, model and weights. Basically, you can see the data coming from end to end will be protected perfectly, leveraging Azure Confidential GPU with NVIDIA and also Protopia, the SGT pipeline to make sure the end-to-end data protection and privacy protection. So let me quickly go through the demo. So first of all, you can see they're waiting for the platform attestation has been successful. And then the data flow actually starts. In the left end, you can see this is a live camera shows the live picture from the street. The right side is actually from the host view through the system stochastic remapping pixel. You can see all the insensitive information is actually in the right side. There is no customer information, PII data there. And then with the confidential inferencing comes in, they go through the attestation. In this demo, I'm sorry, it's a little bit small, but they go through CPU, the CVM attestation to make sure this is confidential VM. It is running on the TE environment. And also they go through the GPU attestation as well, make sure the GPU actually has turning on the confidential mode, and then achieve the end-to-end attestation, make sure that all the data has been protected in the TE environment. All right. So lastly, I think I would like to leverage this opportunity to talk about some of the security update and operational challenges on the confidential computing. So today, we have very inspirational talking about all the confidential computing, about the futures, about confidential AIs. But I also want to say operating confidential is something that we need to be aware it is some of the challenges we need to go over and overcome together jointly from all the silicon vendors and also the partners, solution partners. As we talk about, like, latest security patch is very critical to address known and some of the recently discovered the vulnerabilities. So timely patching on the confidential environment is very essential, especially to protect customer sensitive workload. But there always be certain stances that the security update need to reboot the server. So how are we going to make sure that, so first of all, we're working very hard to work with the silicon vendors to minimize the reboot requirement during the security update. But still, there are circumstances that security update will need reboot the node. How are we going to do that? How are we going to make customer minimize their impact during the process is we break down into the 3 phases. In this first phase, we will collaborate very closely. We are actually collaborating very closely with silicon partners to do all the qualification on every single security update. And then we lock down the maintenance window and give customer early notification at least 30 to 45 days prior to the actual maintenance window comes in. In the step 2, we call it controlled maintenance window, which means the customer will be in certain regions. If we do have the enough capacity, we will send notification to the customers if their VM will be impacted during the updates. And then customer will choose a maintenance window. Basically, they choose their own best time frame for themselves. They will come and call the maintenance API, try to migrate their VM from the unpatched node to the patched node. So customer has their own control during the phase 2 period. We call it control maintenance. Once the control maintenance window is over, we move to the stage number 3, which is scheduled maintenance. What does it mean is Azure actually come in and to update the nodes one by one. We call it in-place update. Basically means Azure will come in to apply the security update, reboot node, and then reboot customer VM. From customer perspective, their VM during this time period, their VM is going through the maintenance phase. The whole process will take about 30 to 45 minutes. However, customer can opt in, can choose, they can listening to some of the event. Like Azure has notification if the Azure come into this specific server, need to reboot the server to apply for the update. 15 minutes before that, customer will be able to receive the signal or receive the event, then customer can do some of the grave shutdown or backup things, but I hope the backup should happen during the phase 1 and the phase 2, but at least the customer will have the early notification 15 minutes before the server is starting to take the security update. So this is where we are. I know the process is not ideal. We are still working with all the silicon vendors to make it a better way. Impactless update, this is what we are putting the mandate to the silicon vendors and also all the partners. But still, there are some cases unavoidable security update will need reboot. This is a process we are working on. Lastly, I will hand it over to my co-presenter. This is the most common questions we got from customer. How Azure VM provisioning and boot and attestation work goes. So thanks, Ash.
So we thought we'll preemptively answer this question before we start getting into Q&A. I think the two most common asked questions is obviously how does updates work and how does attestation work. Run covered the update story. There is live migration work that she previously highlighted that should take some of the burden away. But then the plan maintenance and the control maintenance windows will actually enforce some of the updates on the customers. That said, I think the customers first asked, what does attestation actually do? How does it work? Just to walk through this whole scenario, let's just say that a customer intends to actually boot a CVM. Thanks for the video there. So the CVM deployment starts, the TE gets initialized. What that basically means is we want to create something called a measured boot over here. We start measuring the components. The CPU starts initializing the memory encryption first, and then starts initializing the VTPM, and then basically starts measuring all of the components that are about to boot and starts storing them in the PCRs. With that, what it basically does is it starts creating an VM identity. The next step, once we have measured everything, is to actually make that tamper-proof. Which basically means that we're going to use the hardware root and basically attest that, sign that. And the following step, obviously, up until now, the OS has not booted. Most of the OS images that are actually created are created in clean rooms, encrypted. And we need to actually get the key to decrypt the OS disk and start the boot process, during which we usually use an attestation service at this time. In this case, in Azure, we use MAA. And we usually send in all the evidence, the TE quote, the measured quote, and once that MA actually verifies that, then the key is actually released to the system. Once the key is released, the OS actually is unlocked, and then the boot sequence continues. This is the high-level view. I'm going to actually pause. Well, actually, it did not go through the automation here. Sorry, okay, there. I'm going to pause. Probably this gives a very high-level view of the system. Don't want to move away from the mic. That said, I'll open this up for questions so that we can actually provide more in-depth answers to any of those questions, any of the sequence we talked about. Arun, do you want to join?
I also want to add one thing.
I think we don't have the mic, so we can't move away from the desk.
I also want to add one thing. In the Azure, every single CVM has on top of the OS disk, they have the VM GS disk, which is a VM guest state. And the VM guest state is always being encrypted and protected, which includes the customer ingest UFI and also VTPM. Either customer can choose use trusted platform, so we can have the platform platform managed key to protect customer VM GS file, or customer can choose their own customer managed key to protect their VM GS file. I think the Ash previous talk about is mainly from the customer managed key scenarios. So they can do the protection on the VTPM, eventually do the protection on the data disk encryption sealed inside of the VTPM. So if we have time, we can go through the live migration demo as well.
I honestly don't know. Do we have more questions? How much time do we have left?
9 minutes.
3 minutes?
Oh, we have 3 minutes.
There we go. 3 minutes. Any questions that we can answer?
Oh, here.
Oh, go ahead.
I wanted to get a bit meta about it and say, for people that want to learn about deployments in Azure, what is the best path? Specifically, I run a consulting firm that works with a lot of finance companies looking to do secure deployments. And a frequent question is, how do they embark upon the learning path?
Is your question actually related just to CVMs or in general CVM or VM deployments in Azure?
VM deployments.
Okay, so let me repeat the question. How do I embark upon a journey on deploying VMs or CVMs in Azure? What is the way to learn, or what is the documentation process? Is that the?
That's right.
Azure Learn is a very good resource. I would start with that. Has a good enough documentation and demos available there. That's the first one. I would say depending on how big the customers are, there are actually sales reps as well as assigned architects, solution architects that you can actually request for if the customer is big enough, depending on the contracts they sign. That's the second mechanism. The third one, obviously, lots of learning material available on Azure Hub through documentation. So these are probably the three resources that come to the top of mind. I can probably dig up more and send you information.
No, that's very useful.
So. Any other questions? Did not realize there was a clock here. Try to speed things up for no reason. I should have probably asked the question first. The demo? Do you want to do the live migration demo? We have about a minute.
Sure. Let me quickly go through the demo. So this is live migration demo, and on the left side, this is original, the CVM is running in this server. Right side is destination of this second server too. And you can see inside of the confidential VM, we have hello world script is running. And now starting to do the live migration, this is the MIG TD. The migration TD is working, and we fast forward all the demo, and you can see it about 92% completion. And then now you can see the confidential VM has been migrated from left server 1 to right side server 2. And you can also see inside of the guest, customer blackout period is hardly to be observed. So this is of course this is demo, but actively we are working very closely to deploy into the whole Azure confidential computing, the VM, starting from Intel, our v6 confidential VM. All right. If no more questions, thank you for your time. If you have any questions, feel free to ask Ash and myself offline.
Hi, everyone. Thank you for making the choice to see our session right after lunch. My name is Sam Lugani. I run product management for Google Cloud for confidential computing. And with me is Ranjit, who leads our engineering team for confidential compute. We're sort of in this new chapter of confidential computing, and really, you've heard a lot about it, but the inflection point really has been AI. The massive change that we've seen over the past few years in people's embrace of confidential computing has just been crazy over the past 2 or 3 years. Of course, the reason is that we need to use AI in a privacy-preserving manner. And at its core is a lot of the data which is used to train these AI systems. Now, that data has to be protected because it can be manipulated, it can be poisoned, and you need to make sure that doesn't happen for the model to be effectively good. And then, of course, there's the models and the weights themselves which need to be protected as well. So at its core, you have this AI system with models, data, weights, all of that needs to be protected. Inferencing needs to be done in a privacy-preserving way. And what better to have AI and confidential computing be married at its total, in its true sense. So what is confidential AI? At its base, there's confidentiality. You've heard about it. There's isolation with respect to VMs and other VMs running on the same system. And there's integrity and verifiability. All of that comes through attestation. And all of this results in being able to run inferencing agentic workloads in a privacy-preserving manner. So we're here to talk about how real companies are using confidential computing and AI systems and building things which were really hard to do previously. So you'll see some examples of what folks are doing, along with a few demos as well. There is this company, AI Genomics. It's in the AMR space, or AMR stands for antimicrobial resistance. What really happens is that in a lot of hospital settings, people get treated with a host of antibiotics, antivirals, and over a period of time, they can develop resistance to these drugs. Now, a good use of confidential computing beyond the business side of things is if it can actually help us improve our health and the healthcare of our loved ones. And with confidential computing, what this company is doing is it's ingesting data, healthcare data from different institutions across the world. It's trying to understand how they can better treat diseases and offer reduced AMR resistance. When AMR resistance is reduced, it results in better health outcomes in hospitals, especially for patients who are dealing with serious diseases. So Jonathan Monk, he's the head of bioinformatics at AI Genomics. Let's hear from him as,
AI Genomics provides deep epidemiological analysis, linking strains to investigate outbreaks with precision. But the most informative reports often require the most sensitive data: patient age, travel history, and lifestyle factors. AI Genomics customers asked for uncompromising privacy, and AI Genomics delivered. Last year, we shared a vision for a more secure cloud. Today, it's a reality. The entire ID AMR platform now runs on Google Cloud confidential VMs, ensuring that data is encrypted even while in use. In addition, AI Genomics is able to protect its AMR algorithms from misuse and preserve IP. Our next step is to start using confidential space. This allows for securing processing in the cloud without ever uploading data to AI Genomics servers, protecting both customer-sensitive information and our proprietary algorithms. IDAMR isn't just a pathogenomics platform. It's a secure ecosystem where innovation meets absolute privacy.
So this is an example of how confidential computing is benefiting our lives, our health in a net positive way as well, which is a great thing about good technology. Oppo is another company. They manufacture devices, mobile phones, etc., and they've been using confidential computing for a while. They've created their private compute cloud offering for their AI-centric use cases. And then there's Cohere. Now, Cohere is building state-of-the-art foundational models that rely on confidential computing, and they're relying on confidential computing to ensure that the private AI inferencing and model protection that their customers need actually happens in practice. So they're using confidential GPUs on GCP today and helping their customers process proprietary data as well as the models with the assurances that those models actually get protected. Symphony is another example. Now, Symphony serves as a central communication hub for global financial entities. They're literally processing millions of mission-critical messages every day. And they've created a vault which is based off confidential space, where they can say that Symphony itself is outside the trust boundary. They don't actually see the messages of what's happening between these different financial entities. So at its core, you have a regular, for example, instance type in a cloud environment where there is no added protection against the privileged cloud admin. Confidential workloads add that aspect of confidentiality when you turn on confidential computing, which is stronger protections against the privileged cloud admin. And then we build solutions like confidential space on top, which exclude the operator from the trust boundary as well, which essentially means that the operator or the workload owner also does not have access to what's going on inside the TEA. So this is sort of what our portfolio looks like at Google Cloud. At its very base, we have the confidential infrastructure that we've built, which is confidential VMs and GPUs across Intel, AMD, and NVIDIA offerings. We have our attestation service, and now we integrate with the Intel attestation service ITA as well. And then on top of that, we have different GCP services that support confidential computing, like confidential GK nodes, Dataproc, Dataflow for streaming analytics, and Vertex Workbench as well. And then we have built solutions and apps on top of that, such as confidential space for things like multi-party compute. So here's how it looks like within our console. This is the cloud console that we have. We have integrations with Gemini Cloud Assist. So for example, if I have a compute-intensive workload, I can say, well, what is the best machine family for me to use within Google Cloud? And the idea is to make it easier for customers to actually do this. Side by side, I can start creating an instance type. And as I create an instance type and I go into security, it's a single button. It just says enable confidential compute. You'll click it and you'll be presented with a couple of options. So in this case, you can use AMD SCV, you can use AMD SCV SNP, or TDX. Gemini Cloud Assist suggests the C3 series is the best optimal machine family to use in this specific case. So we're just going to select TDX. And then that's going to default to the machine family, which is available in that specific region. In this case, it's going to be C3. So all I need to do is I press confirm, and then I can actually create that instance type. Or I can actually go back to the machine configurations and select GPUs. So in this specific case, I can go back and click on GPUs. There is this, so I'm going to select the H100 here, which is available. And it automatically defaults to the machine shape, which has confidential computing on it. And just by doing that and pressing create, I can create a confidential VM with GPUs, specifically in this H100 example. Great. So our journey really continues. Our goal is to make confidential computing accessible and available everywhere. And so we have a couple of launches that we want to talk about. We've published some of these launches earlier today as well. The first one is confidential C4. So we're expanding our Intel footprint. We had the C3 machine family, which was based off the 4th generation Xeon processors. C4 is based off the 6th generation Xeon processors, and that's in preview. That's in preview now, and then going to GA very shortly. This includes support for Intel AMX as well, which is advanced matrix extensions. It's CPU-based acceleration, which a lot of folks can actually take benefit from, especially for agentic workloads. Live migration support is now available on some of the AMD families, specifically C3D as well. And then we have the prompt encryption SDK that Ranjit is going to talk about a little later. But there's one more thing. I really often get asked this question: how do we make confidential computing on GPUs more accessible and available? And I'm really happy to announce that today we have the confidential G4, which is powered by the NVIDIA Blackwell series RTX Pro 6000, available in preview globally. So it's not there in a few regions. It's available everywhere RTX Pro 6000 is available from a Google Cloud perspective. There's no code changes required, and there's minimal performance impact. So it's really our journey towards making confidential computing on GPUs a little more accessible to everyone. We've talked about it in more detail. So there's a QR code there. You can scan it and you can read more about what we have to say. So with that, let me invite Ranjit, who leads engineering for confidential computing at Google.
Good afternoon, everyone. Great to see you all here. Now, for this next section, I just want to maybe take us through the details of maybe 3 critical aspects as we all look to build out a confidential AI solution. We have confidential VMs, confidential GPUs, and we'll also talk a little bit about what it means to secure prompts end-to-end across the ecosystem. Now, all of us here are very familiar with confidential VMs, and so I'm not going to belabor the point. I think at the end of these couple of days, we're all going to be TEE'd out. But I think we all know that CVMs offer confidentiality. This is in the context of per VM's hardware-specific ephemeral keys that are used for memory encryption. We also have workload integrity that CVMs bring us. And finally, we have the verifiability through hardware-based, hardware-rooted remote attestation. Now let's talk about GPUs for a second here. Right? Now, in a typical VM with just a GPU attached, the communication between the CPU and the GPU is unencrypted. And in addition, what you'll also see is that the host OS and the hypervisor do have full access to what is running on the GPU. Now, to ensure that our models and, importantly, our data are protected, we build on CVMs with confidential GPUs. Right? And when you pair a confidential VM with a GPU that is running with confidential mode turned on, all communication over the PCIe link between the CPU and the GPU is then encrypted. This is done with the help of a driver that is running in the guest OS using an encrypted bounce buffer. In addition, all GPU to GPU communication over NVLink on the same machine is also encrypted. Now, all of this, as Sam alluded to, is done transparently the moment you enable confidential compute on the system. Finally, we also get cryptographically asserted claims from both the CPU and the GPU to ensure that you, as a user, can verify the properties of this environment before you run your sensitive workloads. Now, this is a powerful system, right? You can run these demanding AI workloads with all the protection that confidential compute brings to the table, and do so without having to change your workload. Now, we've talked about confidential VMs, we've talked about confidential GPUs, and how they essentially provide this protected environment to run our AI models, to run the workloads that we care about. But what about the data that is exchanged between these client applications and this protected environment? These could be your user-generated prompts, associated responses. All of this is also sensitive, important information that we'd like to keep protected. As Sam mentioned earlier, we have recently talked about our confidential compute-based prompt encryption SDK to help with precisely this. And we talked a lot about what it means to have open source code available. This is open source and available for all of us to use here today. Now, this SDK takes care of establishing an end-to-end attested and encrypted communication channel between the client application and the server environment that is running your protected workload, filling in that last mile gap. What I maybe try to do is maybe just take a couple minutes to dive into exactly how this will work here, right? The first step is to generate a set of instance keys, and this is essentially an ECDSA public-private key pair. This is done by the server SDK that is integrated into the workload. The inference workload will then use an OIDC token to essentially prove its trustworthiness to the client. Now, before it is granted this OIDC token, there is an attestation verification flow that happens between the inference server and the attestation service. The server SDK essentially gathers attestation information about from the CPU, the GPU, and the workload, and sends that off to the attestation verifier. And once that is verified successfully, the workload then gets back an OIDC token with relevant claims. And this includes a binding to the instance key that we just saw generated in the previous step as well. Now we come to the point where the client wants to connect. And in step 3, the client application initiates a standard TLS connection to the server. And this potentially is routed through a number of intermediate nodes as well. Now, once this TLS connection is established, the client and server SDKs independently extract session-specific keys that will be used to eventually verify the TLS endpoints as well. In step 4, the server SDK then packages the OIDC token, the instance public key, and a session signature and sends it over to the client. Now, the client SDK, in this case, receives all of this attestation information, and it executes a multi-step validation process. First, it verifies that this OIDC token is actually valid. And this cryptographically verifies that the server is actually running in a trusted execution environment. Secondly, if the signature verification that is sent by the data over all of this passes, it proves that the application server is essentially running on the same endpoint that shares the active TLS session. And this helps prevent simple replay or man-in-the-middle kinds of attacks here. Now, once step 5 is done, the connection is considered secure, and the client can safely begin sending and receiving data. And that those would be your prompts and the associated responses as well. Now, we've talked about confidential VMs, confidential GPUs. We talked a little bit about what it means to secure the channel end-to-end between the client and the server applications as well. Now, all of this essentially adds up to provable privacy. And we've talked a lot about why this is important this morning. We've also made this easy to use, right? Confidential VMs and GPUs, you enable it with a single click of a button. The prompt encryption SDKs are easily integratable into both your client and your workloads as well. Now, maybe in the next couple minutes that we have, let me just try to bring all of this together and see what an actual example would look like. And before I do that, I'm just going to pose a very simple question for us. If you had timely private access to your own medical data, how would this redefine your personal well-being? Sam talked a little bit about why healthcare is an important thing, and this is just extending that a little bit further as well. And especially in today's world where I think we're all of us are just running nonstop, and time is at a premium here, I think that this would be a game changer. So let's see how we can walk this out with all those pieces of technology that we just covered here. So to help us with this story, let's imagine that I have a medical provider, and this provider has access to all of my medical information, right? My medical history, reports, lab tests, etc. And to enable me as a customer to get timely and private information based on my personal medical history, let's say this provider has also made an AI-based personalized assistant that can run over all of this data. Now, in a non-confidential based workload, this would essentially be an inference workload that is running in an unprotected environment on an unprotected VM. And in addition, all prompts and responses exchanged with the server would essentially be in the clear. Yes, there will be TLS, etc. But if you wanted to, there are ways to be able to get access to that data. Now, as a first step, we can encrypt data at rest, right? This is simple. Google does this by default. Next, we can bring in confidential VMs and confidential GPUs to protect the inference workloads. And this also offers us the ability to get a verifiable attestation over this environment. And this will protect the workload when it's running on a shared cloud. And finally, we can add encryption of prompts and responses from the client all the way to the trusted execution environment that is running this workload. And this will protect user data end to end. Now, to see this in action, we'll just take a quick look at a demo. I'll show this on our recently announced confidential G4 platform, which are running the AMD SEV confidential VMs along with the NVIDIA RTX Pro 6000 GPUs, also running in confidential mode. And in this scenario, the client application and the inference workload have also integrated the prompt encryption SDK to essentially secure the end-to-end channel. Now, I'll start with just showing us the VM that is set up as the confidential inference backend. This is a standard GCE G4 AMD-based system. You'll also notice here that it is running confidential compute with SEV enabled, and it has a NVIDIA RTX Pro 6000 GPU also set up in confidential mode. So as we talked about here, we're going to go back to our demo scenario, and I'm going to engage with my medical provider through my unimaginatively named medical assistant application. Now, my provider has set up a policy here to require very specific confidential compute-enabled hardware and software. Now, in this first example here, what we'll try to do is essentially connect to a server that is not running in a confidential environment. What you'll notice here is that, and this could be accidental, it could be malicious, but what you'll notice here is that the client is unable to verify that the server is actually running in a confidential environment. It is therefore unable to establish a communication, and my prompts are disabled. And this shows the power of verifiable attestation protecting me as a user of the system. Now, in the second scenario, we'll move to where the client application is connected to an actual confidential backend. This is the exact same policy that I have here. And in this scenario, what we'll notice is that the connection is successful. Both my CPU and my GPU claims are verified by the Google Cloud Attestation Verifier service, and I have confidence that I am talking to the right backend in this case. And now I can actually check for timely information that is cross-referenced with my own personal medical information, and that is stored securely by my provider. Now, I'll tackle a scenario that is likely very familiar for all of us, right? We are all here. We're going to be doing a ton of walking over the next couple days. What you'll notice here is the assistant is processing my medical history, cross-referencing it with environmental data that it is seeing, and giving me some clinical advice. Now, because this is running in a TEE, and we have that secure channel established, all of this information is protected. No telemetry logs, model trainers, my CSV is going to know anything about me fracturing my ankle or fraining my ankle last month. And secondly, I can go a step further here, right? Go back to my medical information. I'm faced with a tough choice about dessert options this evening. What do I want to do about that, right? What you'll notice here is that this AI assistant is analyzing critical medical information, my A1C numbers, current prescription dosages. In a standard environment, I might hesitate to type some of this in. But in a confidential-based environment, I know that I am protected, my data is protected, and that nobody in the middle has access to any of this information. Now, as you've seen, all of this is sensitive information, right? And at least to me, this seems like the holy grail of personalized healthcare, right? The assistant has linked my personal activity, linked it with real-time available environmental information, and is giving me up-to-date, pertinent advice about what I can and cannot do. I think this is the power of confidential computing, right? This enables use cases that may not have been possible or may not have been easily possible before, and truly is an opportunity for us to enable and improve our lives, enable and improve our customers' lives as well. To wrap up our session today, we've covered 3 critical aspects of what it takes to build a confidential AI-based solution, right? We've talked about VMs, confidential GPUs, and securing an end-to-end channel to ensure that our user data remains secure. As Sam also mentioned, we've talked about a number of building blocks here. We have infrastructure that is based on hardware-based building trusted execution environments that provide things that we've talked about: confidentiality, integrity, and verifiability as well. We build on this foundational infrastructure with a bunch of services that are also confidential enabled. And finally, we have building blocks that are used for confidential applications as well. Confidential compute is both an unblocker and an accelerator, right? It helps us unlock the power of AI, but doing so in a privacy-preserving manner as well. To wrap up, Sam and I just published a blog earlier this morning as well that touches upon all of these topics and a little bit more as well. I definitely encourage you to take a look at that. We'd also love to connect with you a little bit more as well. Our time is up for the day, but we'll be around here, and we'd love to continue the conversation as well. Thank you all very much. Have a great rest of the session.
Okay, I guess I don't have notes on paper. So welcome back, everybody. I hope you had a lovely lunch and all of you have made new friends that you're going to build exciting new technologies with that protect people's data and model weights and help them unlock value from AI without jeopardizing human progress. I'd like to invite on stage our esteemed panelists. Why don't you all come on up and you're going to do your own introductions. Okay, so we'll just go down the line. James, you want to start us off?
Yeah, sure. Yeah, thanks, Aaron.
So why don't you start off with who you are, where you work, and your hometown.
Okay, great.
Great, let's do that.
All right. Yeah, James Edwards. I'm Director of Governance, Planning and Strategy at Midland Credit Management, a specialty finance company based in San Diego. As you can probably tell, that's not my hometown. My hometown where I was born is actually Haarlem in the Netherlands, just outside of Amsterdam. But my hometown where I grew up is a place called Cricklade in the UK, which is a tiny little village out in the English countryside. So, but yeah, nowadays I'm based in San Diego, just like you, Aaron. So.
Thanks for being here, James.
Yeah, I'm Shyam Menon. I work for Mytech Systems. I lead machine learning and fraud product for Mytech. I am based in Atlanta. My hometown is a town called Trichy in southern India. That's where I was born. And yeah, happy to be here and join you. Right.
Reshma?
Hey everyone, my name is Reshma Shetty. I am from the Bay Area, right here. I've been here more than 20 years, but my hometown is a coastal city called Mangalore in India. It's a southern India. I work at ServiceNow. I'm a senior director of engineering at Connected Customer Experience organization, leading all the learning platforms and digital technology.
Thanks, Reshma.
Hey everyone, Nikhil Gulati. I'm actually based here in the Bay Area. I'm local. I work for Johnson & Johnson MedTech. I lead engineering and AI for our global digital surgery platform. And my hometown is New Delhi, India. So I'm on the north side of India.
Great. So thank you all so much for being here. Encore Capital is one of the largest. Explain Encore, because I don't want to get it wrong.
Sure, yeah.
I know what you guys do intimately.
Absolutely, yeah. So we're primarily a debt collection company. We buy non-performing loans from other financial services providers, and then we collect on those loans.
So the world's largest debt servicer with subsidiaries around the globe. Great, thank you. And then Mytech, all of you guys use Mytech. They provide the global infrastructure for imaging for financial services. So every time you take a photo of your check, that's one of Mytech's many products. So everybody's familiar with Mytech. Did you want to give a little bit more to that?
Yeah, so we primarily operate in the area of, one aspect is what Aaron just mentioned. The other is identity verification and fraud prevention. And so we validate, authenticate identities both through documents and biometrics. And we are generally part of onboarding flows at most of the financial institutions that you know of.
Great, and I'm sure everybody knows ServiceNow, where Reshma is. It's my former employer, and in fact, when I joined Opaque, one of the first people I called to try to recruit to Opaque was Reshma. But she said no, alas. But I'm very grateful to have ServiceNow as a customer and Reshma on that project. But I don't know that anybody needs an explanation on that. So J&J, would you do a quick intro on?
Yeah, J&J is huge. So we are the world's largest diversified healthcare company. But I'm part of MedTech, especially around in surgery business, and we are globally tackling surgery, especially around robotic surgery, and that's part of my portfolio for software and hardware.
All right, so I'm going to ask the first question, which is take us back to a moment when trust us stopped being good enough for a project or an AI program that really required something that was more tangible evidence in order for you to unlock value. And I don't know, since I've got a bunch of questions, raise your hand and I'll let you go. Shyam.
Yeah, so I think it's not really a moment. I think it's an ongoing hurdle, at least in the space that I operate in, because we deal with very sensitive data. Like I said, it's PII data, it's biometric data, it's generally financial histories. They are generally protected by kind of the highest level of regulations. So the ability to kind of extract insights out of those data sets is incredibly hard. And generally in fraud, and those who follow the fraud domain, I think one of the hardest things to really do in fraud is to build kind of a composite picture across organizations, and most of the fraudsters operate across different enterprises. So you have to have the ability to actually look at what they're doing in one place and put that together with what they're doing at another institution. But the problem with the nature of the data is that sharing is actually prevented by regulation, competitive sensitivities, liability issues, et cetera, et cetera. So that is an ongoing challenge, which is why, confidential computing and what Opaque is doing is so interesting for us in terms of moving the goalpost in the work that we do, and that we're able to actually derive way more value in terms of just purely fraud prevention by extracting some of those insights that we can today. So I don't think we have crossed that hurdle just yet, at least on the fraud side, but that's what I would point to in my domain, at least.
Thanks, Shyam. Nikhil.
Yeah, I think I agree with Shyam. It's not a single moment, but healthcare industry has dealt with sensitive data for decades. I think two things that I've been observing have changed in the last 5 years is there's always been this default answer to don't move the data where it was generated, keep it locked, because to protect sensitive information. Forget about sharing, but it's like I can't even move it to a cloud because we don't know what happens, who accesses it, what's a verifiable trust in your words. So I think that trend has changed, and the reliance on anonymizing sensitive information is going away because of the multimodal nature of the data. You got videos, you got images, you got complex streams coming in. So no one can. It's very hard to actually deterministically tell that this is completely desensitized. So you have two options left. A, you want to actually create more value by moving that data, sharing across different parties. So obviously your contracts would allow you to do that. And the second is you have to have a guaranteed technology behind it so that when you go to your regulators or compliance, that I know how to actually do it now. And we can create a verifiable source of it. So we applied these principles, especially around anonymizing these multimodal streams, especially when you do surgery, and it becomes no longer a conversation of why you're doing it. It becomes question: show me how would you do it, and what is the thing that I'm going to hold and actually use it as a proof. So it becomes huge for us to be able to take that step.
Thank you so much. James?
Yeah, I think for us a real turning point was when we started to see our regulators and auditors start to invest in their own AI tools. So then they're no longer doing sampling of the evidence we provide to them. They're checking every single thing. So that was a shift from, okay, compliance can be something we apply after the event, to compliance has to be built into the process itself and really embedded in kind of whatever we're doing. Because when they're using AI to find the things that we're not getting right, they're going to find all of them. So it no longer becomes a best endeavors approach. It has to be 100%. So.
They also have been using AI tools to generate very lengthy bespoke questionnaires that you have to process too. How's that been?
Absolutely, yeah, that's been interesting. We're in a bit of a battle there with they're using AI to generate the surveys they send us, and then we're using AI to respond to them. And I think we're just about tying on that at the moment. So.
Well, if only there were a way for you to actually provide verifiable evidence of what ran, where it ran, with policies, and to say, hey, listen, don't send me another survey, just here's the record. Here's the governance record, you can independently verify it, answer your own questions, instead of you getting these 52-page surveys that are AI generated. I saved the best for last. Reshma, would you share an example?
Yeah, ours came from data classification and our intense desire to provide solutions at scale. So we wanted to go out of providing these localized solutions with data anonymization or other traditional ways of dealing with this data, regulated data, and we wanted to bring it to a solution where it actually is at scale. So that was really the need for us that drove us into getting into confidential computing arena. Yeah.
Yeah, and ServiceNow has really been a leader particularly in the last year, releasing an AI control tower that allows you to track governance across all the different workflows. So this is quite a testament that as a leader in AI, ServiceNow has adopted confidential underlying it to provide these level of guarantees. Sham, your models live on identity and fraud data, exactly what a lot of attackers would love to get their hands on, and regulators are very anxious to guard. How do you let AI work on data without ever exposing it and prove it to a customer that it stayed protected?
So today it's a narrative, right? There is no artifact that we point to and say, hey, here is the proof, right? But that's what's changing. So I mean, so if you went back about 10 years, if you had a fraud or decisioning model in financial services, all you had to give was the result, pass, fail, whatever. The last 10 years, it's slowly moved to explainability. Why? Right? Why did this pass? Why did this fail? Probably in the last couple of years, we get so many questions about how did you arrive at that decision? I think Nikhil mentioned that as well, right? And so, where did the data run? What did you run it against, right? What infrastructure did it run on? All these questions have become kind of part of that, what we consider model governance and providing that information back to customers. So that's the reason why the whole, that attestation piece of what confidential computing provides us is, so you're going from explainability, which, generally you can build an explainability layer on top of the models, but the integrity and traceability of what the model is doing is what confidential computing would provide us, right, as an artifact. Today, that's not the case, right? It's almost on a, they believe you kind of framework, at least because you really can't prove other than, an attestation that you provide from your legal team that this is how it is. But we are getting to a point with the work that Opaque and companies like that are doing is, you can actually point to actual artifacts and say, hey, here is the proof. You don't need a signature from the compliance team to prove that this is how it was done. And so that's the change that is coming. We can see that on a day-to-day basis. We get questions around that. So at least from my point of view, 12 to 18 months from now, this is going to become like a necessity for all kinds of model governance teams that operate in this space, in the ID and fraud space. And like I said, and like you mentioned, the data is so sensitive that the regulators are incredibly, alert about any kind of movement that in their mind jeopardizes private citizen data. And so that's the challenge that we're trying to overcome, and that's why this is exciting for us.
That's really helpful, and I'm aware that the EU AI Act has a requirement for runtime proof, which rather than having an attestation at the time of deployment that there's a particular configuration, there's a requirement that was slated for an August timeline. It's now been pushed back to January of 2027. And I spoke with the executive director, Anna Tallis, who wrote it. And she's zooming in tomorrow to talk a little bit about this. But there's a requirement in the EU and then other nations requiring this type of runtime evidence, which I'm sure you guys are planning for. Nikhil, patient data carries HIPAA, FDA, zero tolerance for leakage. And you now have autonomous AI working on this data in production. What kind of verifiable proof did your healthcare governance team demand before they signed off beyond data stayed encrypted? Like what were the requirements that you're seeing emerge, and what got them comfortable?
As I said, healthcare industry has been handling these data sets for quite some time. And the choice was sometimes very simple. We don't want to manage PHI, right? So that means you have to go through the whole burden of actually ensuring that there's no PHI. We are changing the conversation. We do want to manage it because there's value in it. There's long-term value in connecting some of these data sets. So beyond standard governance, traceability, and what we call as audit logs, right? To Sham's point, there is no single proof that you can point to. And the proof is actually becoming even more important because we're not just talking about data movement, we're talking about distributed processing. So you have data being generated at the provider side, and that's really local. You're going to do something on the provider side, then you're going to actually If you have intention to move it out and bring it together to a place, you're going to put it in a cloud somewhere in a region. If you have regional policies, you have to first make sure that regional policies are met. We can't just take it and move it away. And that is going to be some processing there. Then maybe there's an agent doing that, or there's a process that you don't even know of because sovereign rules dictate that these policies must be run in a certain way by a certain vendor sometimes, actually, which is what we learn all the time when we go to different regions. Then eventually you get an option to actually bring it where you are running your own solution and providing additional context to that data. You're giving it to an agent, or you're giving it to your data science team even manually trying to process that. So what's happening is that every step of that, you have different processing being happen. There is no way today, at least I know of, that you can actually say at every time when processing happened, what happened to that data set, what changed, who did it, which system did it, was it authorized to do it? There's nothing like that exists, because it's really about not movement of the data, but it's really processing at different steps of it. And if you can have that, I mean, that's really powerful. Then you don't have to explain the process. You just have to say, I know exactly what happened at each step, and that's why this is powerful.
Thanks, Nikhil. Reshma, ServiceNow is deploying agents across the largest enterprises globally. Many of these are regulated enterprises. So that makes ServiceNow an attack surface area for anybody who wants to get access to highly sensitive data across regulated industries globally. How does ServiceNow think about securing the product and creating verifiable proof for their downstream customers to prevent something like a SolarWinds?
Yeah. I mean, this is a foundational architectural challenge and a requirement that we solve by providing governance at different layers. So at a high level, we split it into three. One is preventative, one is runtime, and then the last one is more like detective after it's deployed, right? As a preventative, we not only do MCP scans, MCP server audits, and all of those, but we also get down to tool level. Instead of having an MCP deploy 20, 50 tools that does whatever, we get into a fine-grained level of tool-level access. Can this tool actually read? Is it allowed to write, or is it just read? So you get that granular level of scanning even before we deploy. So that's more like a preventative. And then we have, Aaron mentioned earlier, AICT. So AICT is literally our governing body of the platform for agents. So you pretty much get a holistic view of what are the agents that's deployed, what is it doing even during runtime, realistic risk scores, who's accessing what. So you get that whole picture of the agents through our AICT. So that is during runtime, right? And then post, we also get into detective audits, immutable, cryptographically signed audit trails that you can export, customers can export and use it for compliance and audit section. So yeah, but ultimately this is like a constant ongoing thing that architecturally you have to be on top of, providing not just once you deploy, but even after you deploy, are your agents actually running? Are they obsolete? What access did it have? It is something to be looking at your AICT, for example, and be on top of it in an ongoing basis. Yeah.
I should mention that the confidential MCP that we announced today was a collaboration with the ServiceNow team, Anthropic, and some others. But the fine-grained action layer policy enforcement that's cryptographically enforced with confidential literally came out of collaborations as ServiceNow as a co-design partner. So really grateful working with you guys. James, you operate in one of the most regulated corners of the consumer finance market. You've got AI workflows, some classic ML and stuff. I know that you guys are still early in your agentic journey, touching consumer data in production today. How do you guys think through using, how do you think about transitioning to using agents, if you want to talk about that? I know that that's an interesting area that maybe you can talk about. And if not, then focus more on how you guys think about processing data pipelines that are highly sensitive information coming from every credit issuer on the planet.
Yeah, absolutely. So, and we've always operated on the basis of trust but verify. And then I think as we move more into the world of AI, that becomes trust but verify, and then verify again, and then verify twice more.
We're strong proponents of don't trust, verify.
Yeah, So we are being very cautious with our, and we take our responsibility with the data that we look after very seriously, because it is very personal, sensitive information about people's personal finances, which is something we need to be very responsible with. So for us, it's about really making sure that we've got control of that through the whole life cycle, being able to monitor that from the moment that data comes into our possession to the moment we delete it, and then being able to evidence, along the way that we've taken great care of that at every step. So, every system that's interacted with, every agent that might have touched it, every human that might have interacted with it, are they really who we think they are? Is that system really doing what it should be doing? How do we protect that data through every step of that process? And that's where, the confidential computing capabilities and the attestation really helps us to be confident that we can track that all the way through the process at every step.
Thanks, James. So I'm going to open it up to all of you. There's a bunch of people here in the audience that are building AI, deploying agents. What's something that they should take down in the next 6 months that you're like, hey, start here or achieve this milestone? What would you recommend to the audience that are beginning their deployments around agents or data pipelines? Go ahead, Shyam.
I think I would say probably governance, structured governance. There has got to be an established structure, depending on what domain you are in terms of how you monitor what you're deploying, and both performance-wise and security-wise. And I think some of the structures that we have had previously, generally, they don't hold up in what we're seeing or what we are going to see in the next kind of 12 to 18 months. And so that would be the first thing I would say, that you probably need to have a governance structure established within the organization that is actually quite robust. And from what she was saying, we have, obviously ServiceNow has done a pretty good job of doing that. So that would be a good example even for smaller organizations that, you don't need that scale, but you have to have something similar to that to make sure that what you're trying to achieve is actually achievable within the bounds of what is legal and ethical and moral even. And so that's that would be my first kind of.
Yeah, that makes a ton of sense. And there's a CIO who's speaking here who I won't mention who she is because it's a publicly traded company. But one of the things she said to me recently at a lunch was, we're in a world where you have these Mythos class models that make it a certainty that your firewall is going to get infiltrated by an imposter agent. We know that these agents hemorrhage data just by virtue of how they're currently architected if they aren't running in a confidential environment with cryptographic enforcement. And we have this new emerging regulatory requirements around runtime proof. So there's really 3 factors here. Mythos class models all but guarantee you're going to get infiltrated. AI agents hemorrhage data in the current architecture and regulatory requirements. So focusing on governance and verifiability, Shyam, great point, as a starting point. Who wants to take a crack at what as a recommendation for the next 6 months for folks who are here?
Yeah,
Go ahead, Reshma.
I would start with data classification for sure. What is the data that you actually want in here? The other one, in addition to what he's already mentioned, is one of the challenges we saw while developing or implementing this is just aligning all the teams to actually understand what is this new model, new infrastructure, why is it different, what are the risks on cost versus gains, things like that, right? So I would say this is not just an engineering team building. You want your ops, your compliance, your CI/CD, you want everybody to be in line. So definitely start working across for your architecture and your whole pipeline to be in with you and to really understand the model and the design that you want to put.
Yeah, I was going to actually say something completely different. I think you should invest in building a very small adversarial team. You should figure out how to break your own system first. What are the things that can go wrong before anyone else asks the question, whether it's compliance, legal, privacy, whoever, ISRM, security. You should just invest in that small tiger team. Don't do it on your production data. So obviously, but try to actually figure it out. All your data pipelines, your models, how they're running. If you're running agents, what would break where is the surface? You should do that experiment as an engineering and team if you are running one. And so we are investing there. And I think there's a lot of experimentation required in this world because you just don't know what you don't know. There's a lot of stuff coming at you.
James.
Yeah, I think I'd kind of add to that to say find the areas of your business where you can experiment, the stuff that isn't customer facing, the stuff that's maybe lower risk, and use that to iterate and build out those processes, and then make sure that you've got all of those protections and that governance in place when you then take on the more risky stuff.
Thank you, James. Well, thank you all so much for tuning in to this session. Really appreciate you joining us. And we'll turn it over to the next session. Thank you all. Hello, everyone. Welcome back. Thanks so much for joining us for this panel discussion today. We've got an incredible lineup. We're missing Shauki. Oh, there he is. Hey, Shauki. Okay. So, State of the Union, confidential AI from the field. Why don't we kick off with introductions? Shauki, would you like to start?
Yes, so my name is Shauki Kasmi. I am Chief Innovation Officer at TII and co-founder of few startups recently launched with Dr. Najwa.
Thank you so much. And you've joined us from?
We come from Abu Dhabi.
From Abu Dhabi, that's right. Nelly?
Hello, my name is Nelly Porter, and I'm still from Google.
Hi, I'm Antoine Deligny-Lavaux, so I'm a researcher in the security group that is under Mark Rutsinovich, so I think I represent Mark for this panel.
Great. Jonathan Doden, founder of Equity Lab, and I'm here wearing two hats, both with Equity and also with the Confidential Computing Consortium, and excited to be here.
Thank you.
Yeah. Hi, I'm Harold Gilkey, work at AMD in our product security office, working on architecture supporting our confidential computing technologies.
All right, well, thank you so much for joining us. I'll start off with a really simple question. What does confidential AI mean? Is it your experience that it just means that it's running in an encrypted runtime? Is that what you guys think of as confidential AI, or is it something more than that? And I'll let anybody raise their hand and take the question. I don't know if we need all four people to answer that one, but anybody have a hot take on that?
If you don't mind, I will take our client's perspective to it. I think that they don't really understand the requirement of confidential computing. They still believe that securing their data and the access to their data is enough to claim having reached a mature level of security. And I was really impressed by the discussion this morning because it brings a completely different perspective, even for myself, on what true confidential computing is. We have a massive transformation happening in UA, which is the transformation of 50% of the workflows that should be fully agentic. And when we look at most of the pitch deck of many companies here, we are pretty much advanced compared to the reality on the field. Data is still siloed. Accessing the data is complicated. There is a very large diversity of versioning of in the technology stack. Giving a definition today of what our clients define as confidential computing and confidential AI, really far away from what I have heard this morning.
So that's a really powerful point you made, Shauki, which just want to make sure everybody heard this, which is in the United Arab Emirates, there's a mandate that within 2 years, 50% of the processes, the human processes, must be converted to autonomous AI agents. So this idea of verifiable or proof related to what these systems are doing, what they're accessing, what rules are being enforced, is profoundly important at a nation state scale for that ambitious of an endeavor. So it's a great call out. And so does somebody else have a thought around, is confidential AI just confidential computing, or is it something more than that?
So I think I have a few comments on that. So I think confidential AI means different things for different people and different customers. So what we very commonly see, of course, is the big AI labs. What they care about is their models staying secret. These are extremely valuable models. Some of them, like the Mythos class from Anthropic, potentially extremely dangerous if they leak. And for these people, I think they see confidential AI as mostly protecting models, right? And making sure they cannot ever leak. I think there are also many people that interpret confidential AI as making sure their data remains private, right? I use ChatGPT, I use Anthropic with my company's data. I want to make sure that no one but myself can actually access the data that I use or see the response that I get. And I think you have this new class of users, which are the agentic systems, and then confidential AI becomes something actually even more complex, right? So it becomes this idea that we can give identities to agents, that we can have interaction between autonomous, mutually distrusting parties. And I think that it's kind of also built on the two previous one, but it becomes a lot more.
That's a great call out, that the frontier labs predominantly think about confidential AI in terms of model weight protection, and then it varies from there. I think that Nelly's team at Google has established a new standard with Apple Private Cloud Compute that the consumer's data is kept provably private during inference time. So Nelly, you probably have an opinion on this.
Thank you so much, Aaron. And again, to step back before we will talk about private cloud computing, I think in our definition and some things that we educated our customers and customers of our customers is that when we're talking about confidential AI, it's not about TEs. It's about the whole entire confidential system, as I was talking about. From the moment users are interacting with the system, how to ensure that all of their data and all of their intelligence is coming without anybody being able to pick into that or take advantage of this, how those systems, irrespective of where they are, would be able to interact with this data, with this intelligence without leaking anything outside, and also the results, how it will be delivered. And to add to that, again, to add complexity to this world, we've seen multiple use cases when agentic, sorry, I bring in agentic to this conversation again, multiple agents trying to process the same data with guarantees that none of them will see this data. Because the problem with agentic, when they see or have even read access to this data, they cannot forget. So how to ensure that we will provide this MPC environment, multi-party computational environment, but now when the actors is actually agents and not humans, or combination of both, and how to ensure that this all confidential AI system is actually functioning and producing the results we're looking for. So it's multiple ways to slice these wonderful things, but it's never a single one, because otherwise we would already check box and move on to something different.
Thanks, Nelly. Jonathan.
Yeah, I think that it's interesting when you speak to the average consumer and you ask them about privacy, they're not going to stick their hands up and say, this is something that's important to me. And that's because there's a generational change about how we think about how we interact with the systems. We trade, as I think, Aaron, you put it really nicely this morning, that there's this kind of barter that we have today with the systems. And I think that now AI represents a frontier where we're saying, not this time. We're not willing to do that barter. And here's the reason why. What's really critical is that we keep not only the information confidential, but that we allow for a zone in which you have different types of intelligence that can interact with each other. What's the benefit of confidentiality? It's that I have more authentic and more intelligent forms of conversations. For instance, like if I talk to my lawyer and it's not a private conversation, that's a worse conversation, right? Or if I'm speaking to maybe a potential employer and that's not a private conversation, that means I can't actually present my very best self because I'm worried about that being leaked. Think about what that means. It means we've degraded the experience and the chance for these agents or other types of actors to actually come together and to have the most intelligent, the most effective, and the most trustworthy conversations. That's the ultimate outcome of these types of solutions, and that's why this primitive is in fact so powerful, is that it helps us establish this the highest degree of intelligence, and it for the first time, gives us a chance to not make that type of barter that we previously have had, or we've had to give everything away. And I think AI is so powerful that this is the baseline.
That's a really good framing about the quality of conversation is largely dependent upon your ability to be open and honest with the system. So let's hear from the silicon vendor who's going to tell us it's just about the DEE. Just joking. Please go ahead.
No, I mean, and that's one of the challenges or the oversimplifications is, hey, just put it in a TEE and you're done.
TEE, yeah.
Right? But it's much more complex than that, right? It's not just, yes, that's a fundamental, necessary and sufficient condition, but on top of it, right, there's the whole how are you verifying that is what your protections on isolation, your protections on rooted in that hardware root of trust. And then also as you're bringing this out now, so as we get to agentic AI, we get these systems with multiple different devices in them. CPUs are now controlling fleets of GPUs or accelerator devices, connecting to NICs, doing scale up, scale out. How do you keep those claims or those promises that you made about keeping your data private when so much of your data and your model is moving through the system? And so that's one of the challenges that we see as a Silicon vendor, is bringing that out to the community. There's obviously security protocols around that are being developed by this whole community. But as we interconnect these things across multiple configurations, the complexity goes exponential in terms of permutations of what you could have. And so, again, bringing it back to the fundamental rooted in hardware roots of trust, having some security primitives around those, and then therefore providing those protections.
So you bring up a really interesting point, which is something I've seen in the field with our customers. Is I don't know if we have a customer who runs an entire workflow end-to-end exclusively inside of a TEE. What we most commonly see is there's the agent control layer running inside of a TEE with verifiability, but then the communication channels to external tools or resources are attested, but not mutually. And they can get some guarantees around that as part of their workload that's sufficient for where they are today. So it's an interesting point you're talking about, where you have the CPU calling fleets of GPUs. We have customers that are doing self-hosted LLMs inside of a confidential GPU, but most of them are running what we would call our agent control layer inside of a TEE and putting enforcement and building an attestation record that's verifiable from that. So speaking of that, we've seen now confidential AI in production across sovereign and a variety of regulated industries. I'd love to hear from anybody who'd like to share on the panel an interesting workload that was unlocked from your experience because you could provide this verifiable layer. Does anybody have one that they'd like to share that's interesting?
I have one.
Great.
Not talking about PCC.
Does it involve billions of iPhones? That's a good one.
This is the billions of iPhones, but you will hear about that tomorrow, so I won't kind of leave the chance for you to hear from the horse's mouth. Another interesting use case, you probably know SWIFT. SWIFT is financial organizations that combine and actually working with 450 plus financial organizations worldwide. They validate and transact trillions of transactions per minute, something incredible. And the whole GDP, I think, of US is like 2 minutes for them. So it's kind of SWIFT. So for SWIFT, what they figure out that, again, fraud, financial fraud is incredibly, again, problematic issue. And they have developed a model to, again, understand the insides of fraudulent transaction. However, to validate this model, no surprise, they need real data, not synthetic data, coming from different vendors of their SWIFT community. So what they've done, they put it in confidential environment and were able actually to run verification of this model to understand efficacy of it. So there is wonderful, again, things that we forgot. It's not about, again, training and inference, but also verification or performance validation sometimes. So those very sensitive data and sensitive models that are happening all in the entrusted environments.
Thank you, Nelly. Somebody else want to add an interesting workload? Come on, Jonathan.
Yeah, happy to jump in. I think that out of the many inspirational uses of AI, the one that gets me up in the morning is thinking about personalized medicine, because what we're on right now is the precipice of this enormous change in healthcare, in which now AI is going to not only be able to help create various forms of accelerated drug discovery, but potentially even personalized treatment plans and even medicine on the fly. And this sounds insane and fantastical, but actually we're actually putting down the tracks for this. But here's the critical thing, is that for personalized medicine to work, I not only need to have a digital twin of myself with my own data, but I also need to look at population data. That's the only way to start doing, you can imagine, these kind of automated clinical trials. So we've been really inspired by the possibilities of being able to take very sensitive patient records that are not only personal, but also at a population level, and use that to accelerate the ability to really zero in on what a personalized solution might look like. It's truly a change. And you asked, like, what is something that can only be done with confidential AI? This is, in fact, it. And the ability for CC to provide the layer of confidentiality to do the work, great. The ability to verify that it has been done to the compliance, the next level, and then to portably be able to take those proofs into different environments so that you can get the maximum amount of data. That's really that horizon that we see. And again, there is simply no other way to do this, to be compliant and to arrive at that type of solution rapidly.
So Dr. Shawki, the UAE, once again, leading in this category, has taken the Falcon model family and fine-tuned it with the national healthcare records. So that I don't know if you have anything you want to add to that or a different story, but
No,
I
mean,
continue to be impressed with how forward and advanced you are.
So I think it's not a secret that we went through an interesting conflict, and during that period we have launched a startup called Tactica AI, which is an intelligence platform looking at providing the best insights on the localization of enemy assets, and you can imagine that in the moment, in this period, you have a very large number of partners, countries, and organizations supplying intelligence that you need to ingest and fuse very fast. And because the technology is becoming mature when it comes to confidential AI, we were able to bring in models to detect specific type of assets, without breaching the level of security and confidentiality that are imposed to our clients. So it is a strong enablement for on-demand partnership, data transfer, intelligence sharing between partners, and we have been able, which is interesting, we have been able to connect intelligence services to communicate and exchange data very fast, while the standards and the security requirements are yet to be drafted. So it's we have a shout out to the other people. I think they are leading the innovation in confidential computing, because we can see that it's not a hardware problem. We know how to secure computation. What we don't know today is how can we guarantee to assess and audit behaviors. So technically speaking, where our focus is today is more on what an agent is doing and how it is doing it, and why it is doing it at that particular moment, while the computation is already a problem that those guys have solved. And this is interesting, because it shifts completely now our focus. And for the platform we have developed, specifically for intelligence application, it is a true enablement to be able to rely on TEE and confidential computing.
Thank you. I can ask another question, but if somebody has another interesting workload, or I don't want to cut you off.
I think I would have also chosen the healthcare, because the applications that we are saying here are quite amazing. And I think it's one of these fields where a lot of potential has been unlocked by confidential AI. So for instance, the ability to do clinical trial between companies on medications This is something that before was almost impossible, or you have to create very complicated legal structure and enroll on hospitals, third parties, get patient consents. So all of these extremely complicated processes can be really simplified, and that's I think will deliver some amazing progress in the healthcare industry. So I'm very much looking forward to more of that.
Great.
Yeah, I think to your both of your points, I think it also helps enable access to some of the more forward-leaning frontier models of some of these things, being able to do, doing healthcare things inside a confidential compute with more forward-leaning models that they can take advantage of the scale of the cloud that they previously couldn't. And so not only are you enabling it, but you're enabling it, I guess, better or stronger, more capable models.
Great. The next question, which I'm really excited to hear from everybody, their answer is, what's a technical assumption that was disproven about confidential in the last 12 months? So since our last summit last year, we've seen a tremendous amount of adoption and incredible value unlocked through the use of confidential. I'd love to hear from any or all of you. What is a technical assumption that people had that we've just disproven in the last 12 months?
I think performance. One of the initial, bringing in confidential computing and in the access controls or encryptions and things like that were, that was a barrier to entry. What's the performance impact of this? And I believe over, not just in the last 12 months, but over, generations of developing these products and working with our partners in optimizations and learning from those, constantly improving, such that the performance delta is not as high or it's not as negligible to the point where we really are going to get to a ubiquitous confidential computing.
So it's a positive thing. I can bring the negative things.
Oh yeah.
So, for long time, confidential compute was building their attestation and other capability based on predetermined integrity story. We were expecting to build those extended hashes started from whatever, and building our claims and capability is very deterministic. When agentic AI become reality, and the decisions are made not only about these 4 lines of Python code that running in your TE, but also why is they trying to do it? And definitely sometimes those agents becoming confusing and confused deputy. So with all of those situations, the integrity that we're so used to is not working anymore. Because the ability to prove that it's the same 4 lines of Python code doesn't help to ensure that this particular thing is actually making decision based on piece of data that was tampered with, that you have no idea. I'm talking about indirect, again, prompt injection, for example. So I think these simplifications that we made when we started all of this movement, working on confidentiality and integrity of the systems, needs to be rethought, rethink, redesign, again, adapting to this much less deterministic world.
Just want to plus one to that, and in putting on my hat here to speak on the behalf of the consortium, this is why the consortium is so important, is that this isn't static technology. This is evolving, and it's responding to dynamic threats. Something that I'll add as a part of that conversation is that the reality is now that if you think about actually the standard of what we want, what do we mean by verifiability by a third party? What we mean is independent verifiability. And one of the challenges that we've had is that as we've thought about how to take integrity, let's say that's on-prem, and go to the cloud, Nelly won't be completely happy with me on this, is that I have a challenge because on-prem, I can actually establish full integrity because I know exactly what I've built. In the cloud, there are abstractions, and the firmware is attested to some extent. However, there's a lot more to the operating system than just simply the firmware. We have things like, the RAM disk, we've got the file system, we have like all sorts of different things. This is the system that you're talking about. Exactly. So what you have here is a moment, I know this sounds very wonky, it's maybe for more of the room than projecting out like the company line or the industry line for the cameras, as it were. This is the most important part in which confidential computing can become ubiquitous because we can create these integrity guarantees up and down the stack and across different types of topologies. This is what's critical. I need to know what ran on Google, also ran on Microsoft, and then what ran on-prem, and we need to have an attestation layer that is unified. That's exactly why a consortium is so powerful, because we can come together and make those types of claims independently verifiable. And a shout out to Apple. You guys did this originally when you had confidential computing on your own silicon. It was awesome. It set the standard, and now's the time when Nelly's going to announce soon that she can give me an independent attestation of much more than just the firmware. Then, we will kind of return to that gold standard. We can do it. I'm saying this because I know we can do it, not because I think it's impossible. So that hopefully gives you a sense of like where, as an industry, I think we can come together, and that's going to be like a rocket ship if we can get that.
Nailed it. Now it's time for the deep cuts, which Claude helped me with. So Harold, AMD's December 2025 blog framed the trust mechanism for confidential AI as something provable. Privacy is verified by remote attestation, speaking of the topic. Now, you lead the work at AMD's product security office at the silicon level. What's the hardest open problem in extending the attestation across the full AI pipeline?
Yeah, so it's a good question. And I think, kind of going back to my earlier comment, as we bring in more devices, accelerator devices, switches, network, interface cards, things like that, right? Each one of these is a device with its own root of trust, its own firmware, can do its own independent attestation. The challenge I see is really the composition of all those. How do you take all of those independent attestation evidences and chain those together into some simplified meeting thing that you can hand to a verifier, right? And so I think that's one challenge is how do we get there with that? The other thing is, once you've done that, right, that was sort of a, snapshot of how the system came up or how you've configured things. What is the life cycle or the lifetime of this confidential, TCB or whatever? How long is it up? How are you doing maintenance on it, bringing up GPUs, taking down GPUs? What does that mean to your attestation story that you made a promise to, right? So working through all those. And then kind of echoing some of the comments up here too, in terms of the attestation, right? Now you've got multiple devices, potentially multiple vendors. Suddenly you could potentially have, different evidence formats, different reference value formats. We really need to move more towards open standards around those and getting attestation reports that are much simpler to consume by other tools and independent verifiers. Not that every new device that comes out breaks their tools and they have to rebuild them and things like that. So.
Great call out. And of course, we were talking about that during the keynotes from the top of the stack down around that concept of a portable governance record that we should all coalesce around. Deep cut, Antoine. In ACMQ, you frame the core problem this way. Confidential computing lets a user authenticate code running in a TEE, but users also need evidence this code is trustworthy. So attacking the same gap here between attesting what's running and trusting what it does is the whole game for confidential AI. What's the hardest unsolved technical problem in closing it for production AI systems?
Wow, I think I could give you.
You've got a minute and 43 seconds.
I probably need a full hour to answer that question, but I will only pick one aspect. I have probably 20, but I'll pick one, which is a very interesting question, right? So this is the issue of multi-tenancy and states in the inference systems. I'm not even talking about agents yet, right? Because we talk about agent memory, which is its
even more complicated. Yep,
it's quite complicated. But even just simple inference system, right? The problem is that you actually have a lot of shared states there, and the critical one is the KV cache, right? And if you look at a Copilot session, you will probably see something like 95% token cache, right? So
that's a lot of private information.
Exactly. So that's a lot of private information. And some of this is actually observable between requests by different users, right? And that's a very tricky problem. So if you look at Apple PCC, what they say is that they make every inference request stateless, right? So they basically clean up everything between requests. if you do that, you get great protection in that case. But then if it would multiply the cost of using Copilot, GitHub Copilot by 20. So that's something that I'm very interested in, and that actually requires, if you want to fully solve that problem, you may actually need to go very deep with accelerator manufacturers to introduce like hardware cache partitioning notions or something like scalable AOV to split contexts while sharing the model weight. So you really need very complex, interesting technical solution if you want to solve that gap. But I expect we will see some real attacks that use the KV cache.
To add to complexity that you said, now a new type of accelerators available on the market, it's called LPU. And those caching, again, those specifically accelerators are doing and storing KV caches. So again, combination of GPU, CPU, TPU, LPU, we're all in the fun.
And DPUs on the network wire.
Absolutely. Not talking about GPUs.
Yeah.
So we will have plenty of PUs to deal with and making them confidential.
I should have gotten through all the deep cuts because I have one for Shauki and Jonathan that recalls.
It's better to pass.
I think we got to go. They're gonna pull us off the stage with a hook. But this was so much fun talking to all of you. Thank you so much for all of your time and joining us on the panel. Thank you all.
Thanks for having us.
Good. All right, I get to be the one who gets to call everyone to order. Thanks, everyone, for being here. So my name is Rob Nertney. I am a principal software architect at NVIDIA. I'm joined today by Spencer Gilson, and today what we're going to be doing is, hoping it's up, good, talking about confidential computing and some of the future solutions that are coming with Vera Rubin. You're going to see I've got 25 minutes to go through pretty deep topics, so we have a lot of other talks that you can go see, presentations from GTC, but hopefully this teaser will give you some time to see what we've been working on, where we've come from, and where we're going in the future. Now, looking at this, we'll kind of level set. So I've seen and met a few people here today who are here trying to figure out what is confidential computing. I'll see a lot of other common faces over the years where we can say, I know what it is, I want to see what's new, I want to meet people who are using it and how it's going. So we're going to level set, we're going to go through into what's happening kind of in the future here with Vera Rubin, and then other solutions for attestation that are outside the realm of confidential computing, because these things go together, the verifiability of our workloads, not just for the privacy and security of the trusted execution environment, but other use cases for fleet deployments as AI starts to proliferate through the planet. Now, today what we've got is a story of confidential computing. We started with Hopper in 2024. This was a single GPU that you could plug in either PCI Express or the SXM HGX boxes. And the idea here was we were the first to bring that trusted execution environment to a PCI accelerator device. And what this allowed you to do was offload the prompts, the weights, the models, and in a testable, verifiable environment. We partnered with Azure, we partnered with Google, we've partnered with a lot of customers in the clouds who were able to bring this in and allow people to start to use this and figure out what it was all about. Then we had the AI explosion of agentic AI, the early days saying, I need more compute in this box, but I also want that confidential computing. Now, we didn't have NVLink encryption enabled on the Hopper devices. So what we did was we used attestation to allow users to choose their own adventure when it came to threat models. And we came out with what we called protected PCIe, because we wanted to take a very conservative approach, as many of us here do, when it comes to confidential computing, and try and make that your data doesn't leave your environment in plain text. So when you start hearing in the Hopper generation, you'll see confidential computing, that's PCI Express, fully protected, and protected PCIe, which has the same PCIe protections, just plain text NVLink. They attest differently, so you know what mode you're in. On day one, we had a high availability attestation services. This had our RIM service with measurement files. It had an OCSP to check for the revocation status of these measurements for firmware, for drivers. And then with that, if you just wanted a one-click, one-stop verification service, send your evidence up. We do the verification, back comes a token telling you have attestation. Blackwell came, generation 2. Everything gets better with the next generation. We moved and encrypted those NVLinks. This enables you to have different topologies inside your fleet. 1 GPU, 2 GPUs, 4 GPUs. Still within the HGX box. With this, you also say, well, with Blackwell, what else could we add? The RTX Pro series, bringing the enterprise to having more flexibility if you don't need a whole box of B200, B300. RTX Pro 6000, you can have the smaller models, your edge deployments, have that solution ready for use. Now for attestation, we had 2 flavors kind of historically in the past. One is the use case attestation. This is confidential computing. You are a tenant sitting in your TEE. You need to go to the GPUs, the NV switches, anything that basically was NVIDIA owned, and said, tell me what your evidence is, your state is. I want it chained to a device identity that can go to NVIDIA authenticity, and then I want to chain the measurement files to a measurement identity rooted at NVIDIA, and then I want to make these together, do the comparison, the verification, and continue. Now with this, we use TCG-style RIMs. This was sufficient for our needs. This was the time, the best use case of how we were able to get that out. We also had something called infrastructure attestation. Now, this is kind of the little-known attestation that's been around for actually much longer. What this allowed a third-party infrastructure to do was to challenge the rest of the chips on a system that we provide. This includes the HMC. This includes, you see the FPGA here, the GPU, the NICs. Basically, if this was a NVIDIA-provided firmware, you as an infrastructure out of band could take this, challenge it against a co-RIM, and validate that, yes, nothing happened in my supply chain. Now, this, all we did at the point was we said, another team over here wrote a co-RIM and provided this with the access APIs to go challenge these devices and get those measurements. What you're going to see in today's talk is we're going to bring this together and show how in the future we're bringing these two disparate things into the larger story as well with the NVIDIA attestation solutions. One slide that basically has many hours of talking behind it is, of course, we announced this year at GTC, the scale up, the next step in that journey. 1 GPU with Hopper, 8 GPUs with Blackwell. NVL72 Vera Rubin is going to bring the whole rack scale with confidential computing across all of those GPUs into the CPU realm and give you that full end-to-end protection now at a rack scale. So what we want to go through here is some of the story going into, well, now we need to bring in the ARM processor. What is CCA? What do they talk? Do they talk co-RIM? Do they talk profiles? How do we integrate this with the last group that was up here with standards bodies, the standardization of profiles and talking within an IETF co-RIM standard so anyone can verify this. Anyone can take that evidence and put it together with their own solution to make sure that what you're running on is what you expect it to. Now, when we scale up to 72, we're no longer in a box. When you're in a box where it's just 8 GPUs, you can look down and say, okay, I can bind this to a CPU. I can go and take all 8 of these and independently attest them and bring this into a single node where I'm sitting in a TE. But when you go to multiple nodes in a rack, you have to ask yourself, how do I now attest my neighbor? How do I make sure that this node is something I trust? How do I make sure that all the constituent parts of that are also attested? So what we have to come up with here is the ability to have some sort of software stack sitting on all these nodes. And who's going to be the leader? How do I challenge them? How do I make sure I can get encrypted paths to them? Because now I have to do relay attacks. I have to do replay attacks. I have to worry about these things when talking outside, even within a rack connected by an NVLink array. So what we've been doing here is some of the considerations. I get a lot of questions of like, what's next? What are we going to do? When are we going to scale up? And the idea is that we have got line of sight to what we want to do here. And the roadmap is bringing it right here where we can say, with these considerations, you're going to start to see the software stack helping the verification part of this scale-up solution. You're going to have the stack basically discover the nodes. It goes through and says, okay, are these mine? Do they belong to me? Have they been assigned to me? Now I have to get trustworthiness between them. Everyone needs to authenticate to each other. I need to make sure that, okay, I know you, these are mine. And then we set up a policy, because one thing NVIDIA prides itself on is the choose your own adventure as to what happens when anything in your system you can figure out via a series of claims, verification results, what you want to do with things. Obviously, we have to secure all the data paths. And then throughout this process, a big thing that we always want to worry about here is saying, do I periodically attest? Do I want to enable that? I need to periodically make sure that if there's any sort of error handling, right? How do I get reliability information out of this? All this is being taken into consideration when we start working into the scale-up solutions. So what you'll start to look forward to on this as we kind of go into our next area with my partner over here, Spencer, is trying to see what it takes to scale these solutions. A little bit more deep going into what the industry is looking at and kind of the things that we like to go through to try and make sure that the CPU, GPU, and that whole story is cohesive. So with that, I'll pass over to Spencer.
Thanks, Rob. So what I'm going to be discussing is a different type of scaling, and it's going to be the standards we're going to use in order to scale attestation in terms of maintainability across all of our different devices and new modes that we're going to be supporting. So previously, we've kind of relied on SPDM for Hopper and Blackwell and NVSwitch attestation, but we have been lacking a direct mapping to the RIM. So in many cases, this requires a lot of handwritten verifier work in order to properly do attestation. So we understand that a lot of our partners have their own reasons to maintain their individual verifiers. So we're looking at how do we make the mapping of evidence to co-RIM to attestation results even more smooth. So looking at the solutions out there, CoEv is going to be a pretty big addition to Vera Rubin. We're going to embed it both in our SPDM transcripts for Rubin confidential computing, and we're going to also embed it in our ARM evidence. So you might be familiar with ARM's platform and realm tokens. We're going to take that a step further with concise evidence as well, so that you have a pretty direct mapping from, like I said, the evidence to the co-RIM. Dice TCB info is going to be there, of course, to attest and verify all of the layers above the firmware that you're running. And that has a pretty natural mapping to co-RIM as well. Just based on what's available right now, we're building on top of co-RIM draft 10. We're hoping for no more binary or wire format changes, but we'll see. In terms of attestation results, we're kind of convening around EAR, and we're looking at A4SI in addition to that. Now, briefly going into the differences between Hopper and Blackwell versus Vera Rubin. Like I said previously, we had a pretty hefty handwritten verification flow. We're hoping a lot of this will be made much more standards-based and generic with the transition to co-RIM plus CoEv. And with this, we hope to onboard CPUs, NICs, DPUs much faster in all of their different modes. You also get a lot more variety in what you can express in terms of evidence. With TCG RIMs, you really only get digests, which partially leads to this reliance on handwritten verifier logic. With co-RIM, you also get a pretty cool capability to express what should and shouldn't be in the TCB across different modes. So different microcodes and different firmwares might need to be measured in CC versus other modes, and you can actually switch between them programmatically without needing to bake that into the verifier. We're also looking at using RIM locators to identify the relevant reference measurements. This is more of a minor point, but this has been yet another point of handwritten logic for Hopper and Blackwell that we're looking to eliminate with this generation. Now, going a bit more broad to the other use cases that we're enabling with kind of this standardization effort. A big one is fleet scale attestation with fleet intelligence. Fleet intelligence isn't strictly an attestation solution. It's really a fleet visibility solution. You can get a bunch of great data on your power consumption, performance statistics, CVE reporting, the firmwares you're running. So you as a fleet operator get great visibility into all of your NVIDIA hardware. A pretty big component to this though is hardware attestation, where through NRAS you can get a guarantee that you're working with NVIDIA authentic hardware. And this is generally available at no cost for any GPU data center customers. Now, speaking more broadly about the future of attestation at NVIDIA, first we're looking to expand the surface of what we can verify, like I said, both in terms of modes and different devices as we onboard them. This has pretty big implications for DSX, which I haven't talked about, but we'll have an attestation component as well as fleet intelligence. Both of these can greatly benefit from attestation, and we're going to use it. Next, we're going to look at standardizing the whole stack of evidence, co-RIMs, and attestation results across all of our devices. This will take a few generations, but that's the rough direction we're heading. You'll be able to use our verifier, but the hope is that based on these standards, you can more easily maintain your own verifiers should you need to. And finally, we're looking at other opportunities to manage attestation across your entire fleet. Fleet intelligence being the first, but looking to strengthen our SLAs on our services side and adding different capabilities there. Yeah, thank you all. I'll hand it back to Rob for a final word.
All right, thanks, Spencer. Yeah. So I think what we end up wanting to show here is how we started this story where when attestation was just simply a supply chain look, right? A series of hashes and digests, something that we basically said, here's what you should expect. We're going to post this on a website. When you download your firmware bundle, you can start looking at the comparison here. To an industry nascent technology, confidential computing, where we started with maybe this size of room for confidential computing summits, and now we're at big places, people from all over the world flying into town. And then bringing in the realization that the industry needs to standardize. We need to come together and realize that everybody needs to verify because they're all going to provide evidence in a different way. Am I going to be a DPU? Am I a CPU? Am I x86 versus ARM? And the story comes together with the standards bodies and us at NVIDIA trying to make sure that we're at that tip of the spear, balancing the new technology with making it scalable for the future with anyone who wants to come in and bring confidential computing to their piece of hardware. So with that, we have lots more that we can end up talking about. So please feel free to reach out to some of our other talks. But I want to end with the fact that, NVIDIA's confidential computing. On here, we're hearing a lot of, I guess, a transition from what could be done, or I have hopes and aspirations for confidential computing, to these are people using it. These are people deploying it. They are counting on these attestation services. They are counting on the infrastructure attestation. They are counting on the scalability of standardization so they can write their own verifiers. We have partners such as Opaque. We've got partners such as we've set up here. We had Google, Gemini, Apple, Anthropic, all coming to deploy this because they're trusting this technology. You're going to be able to have model providers send their models to systems on-prem. You've got users with on-prem data now able to send them to the cloud. So with that, I'm really excited to be here with you guys to see that this is that turning point where people are using it. There's a big roadmap ahead of us, and we're really excited to be a part of it with you guys. So thank you so much.
Yes, sir. Right. Oh, cool.
Are we live?
Hello? Hello? Ready?
All right, welcome everybody.
Welcome everyone. Thank you for coming to our talk. I'm Komei from Google Kubernetes Engine. We have Keith here, UTL from Google Confidential Compute. Today we are giving a talk about GKE Hypercluster, a specialized orchestration layer we built for frontier of large-scale AI workloads. Yep. So before we look at the engineering, let's examine why confidential compute has become a very important, non-negotiable. I guess people already joined many talks today, so this is very repeated part, so I'll keep it short. Basically, our customers, they care their proprietary model weights, and also our customer care about their prompts, so they don't want their prompts to be exposed to both cloud provider as well as Kubernetes operator. So today we built the GKE Hypercluster to meet those needs, basically support the T in the Kubernetes platform, and I'll jump in how we did it. So before we actually jump in the architecture, let's recap what's the standard Kubernetes gap we have between T and the Kubernetes. So when we try to run the confidential computing on standard Kubernetes, we hit many walls. So the reason is mainly because Kubernetes is designed in a way to share the resources, or we can say in the other word, the node, Kubernetes node is monolithic. So basically the guest OS runs a heavy local agent stack, which includes, for example, the kubelet, giving the admission API interface. Also, there are many daemon agents like the logging, monitoring, and also it gives the debugging shells. So this doesn't meet the minimum sync guest requirement for the T in general, as well as if we sync this from the TCP point of view, when we have TCP, we have to audit workloads, anything running inside the TCP, and this makes the TCP, if we make the node as a TCP, that makes the TCP very huge, so it's very hard to audit. Also, from the operator access point of view, as I said, Kubernetes provides the Kubicado exec, and also admin have the capability to SSH into the VM you have. So there's no way that we are preventing from the both cloud provider and the customer's own Kubernetes provider, Kubernetes operator, from the accessing to node from the hardware point of view. And normally how this is done is using the policy. So Kubernetes does support the capability to harden your workloads or your nodes so that you cannot easily access. For example, we have the access on demand. So our operator can only get into the node when you approved, but that's still not enough to provide a T here. And also from the measurement point of view, we have the confidential node, which provides the basic measured boot, but that one only stops at the OS kernel, VTPM, and the loader. It doesn't actually measure what the actual workload is running, which is actually an essential part for the T. So how did we solve this? Our solution to these hurdles was basically to have the decoupled architecture. We called it linked runner model. So instead of forcing the runner nodes to run the full Kubernetes stack, we split them into two. So the left side you can see is the traditional Kubernetes control node. It runs the kubelet, containerd, and all other system daemon set. The actual AI workloads are stripped down into the other node. We call the sealed VM, which has run the minimum set of the software, and also they're all measured. So here we only need to run the scene layer of what we call the launcher agent, as well as the containerd, so that you can spin up the pod. So we basically touring down all the monolithic K8s node, Kubernetes node into two, and split them into the untrusted Kubernetes node, which runs the same way as the current Kubernetes node, and also dedicated sealed VM to run your AI workload. So let's look at how this works under the hood. So when the GKE control plane actually scheduled pod, when you create a pod, the GKE control plane will create a pod and the kubelet pulls it into your node. This is similar here as well. So this layer doesn't change as from the API point of view or user interface point of view. It works the similar way as well. But in the normal way, the pod will actually schedule on the control node, the left side, untrusted node, commits node. But in the GKE hypercluster, we basically proxy that into the sealed VM we talked about. So there's no Kubernetes running on the runner. And how do we do that? So we built a layer called the CI proxy. When the pod that needs to be run in the T is scheduled on the actual Kubernetes node, the CI proxy basically will proxy the CRI API call to the launcher agent in the sealed VM. And the sealed VM will actually start up the pod and containers inside the sealed VM. So from the developer point of view, this is still conformant to the pod topology or the semantic. So all the work you do, scheduling pod, all those works the same way. And yeah, let me see. So we also, when we schedule in pod, we also have to bridge in the pod networking. Because a lot of Kubernetes features are built on top of the assumption that the pod IP is the one working underneath for each pod. And then, for example, that's how you have the data plane eBPF layer, and which supports the network policy. With this architecture, we also need to support the pod IP so that all those Kubernetes features will work the similar way. Well, how we did it, basically, similar at the layer, when we create the pod network namespace in the Kubernetes node, the same way as well. So basically, all the pod network from the control plane point of view still exists in the Kubernetes node. Then we actually built using the Linux networking feature, Geneva tunnel, to tunnel the traffic to the workload running inside the sealed VM. So data plane network traffic routes directly via the data plane v2, and which is also wrapped via the VPCSC perimeter in this case. And so given this one, all the pod network works a similar way. And if you have any Kubernetes networking feature you're using for your AI workload, will work exactly the same way, including ingress, networking policy, as I said, and also the service, Kubernetes network service. So I talked about the pod networking, and now let's also dive into the general networking VPC setup for this architecture. So here we have 3 networking taking place. One is the pod network or the cluster network, basically your standard Kubernetes node connecting to your cluster control plane. This is where you get all the Kubernetes traffic and the control traffic to your Kubernetes node. And then we have this shim network we called, which is actually the network connecting your standard Kubernetes node and the sealed VMs. This is also the networking tunnel I mentioned, used for the networking tunnel I mentioned before. Normally, this network is isolated to the connection only, so it's not exposed to internet, and also it's also controlled by the firewall, so it doesn't reach to any outside of the even the Google services also. And since I said this is for the AI workloads, a lot of time you also need additional networks for your AI workloads. That's the third one on the right side. This is also dedicated to the linked VM, the sealed VM side. Basically, you can use it for high bandwidth traffic if you need really high speed for downloading your model weights. So you can use this network, and this is isolated from your untrusted Kubernetes layer as well. And here, if you have to use to access for example, Google Cloud Services, you do set the VPCSC, so make sure that all the needed security is there. All right, now I'll pass to Keith.
Thanks, Kome. So Kome has talked a lot about what had to change in Kubernetes to kind of split out the pod into this separate environment and take the regular Kubernetes like node work and have it be in an untrusted space. So let's zero in instead on that trusted space, the TE aspect, the linked runner or sealed VM that he mentioned before. So inside of the sealed VM, what we have is a stripped down, measured, and fully untested environment that builds up to a commitment of having zero operator access. This is what makes it like a true TEE. Some of you may or may not be familiar, but a few years ago we did release our, Google Cloud released the Confidential Space product that has these features. And actually what we've done here is taken that same baseline, our attested container optimized OS platform, or ACOS. And that is the basis for the Confidential Space TE, and it's also the basis for the sealed VM here in Kubernetes. You may have noticed in the keynote earlier this morning, Nelly also mentioned that we use confidential computing to protect Gemini when it's running on-prem through Cloud's GDC product. And this is really us kind of putting our walking the walk instead of just talking the talk. We're using the same ACOS platform to protect our IP when it's running in your environment. So that's how we are trying to let you know it's okay for you to trust your IP running in our environment because it's the same controls. We trust it to protect Gemini. Now, with ACOS, all of the normal administrative pathways, whether they be the kubectl exec or SSH or the cloud guest agent, these pathways are all gone. They're just not there. And instead, the only influence you have is through a kind of curated, limited set of input parameters to tell it what to run and what to launch. So, and all of these things that influence the execution of the job are all part of the attestation. So like even people that have full administrative access to either the GCE or GKE control planes here, none of them can change that commitment to having zero operator access or the signature of the workload that's been launched. Once it launches and it's running what it says on the 10, and it's not running anything else. Now, like any good TEE, you aren't taking our word for it. Throughout the stack here, we have measurements coming from multiple independent trust elements that we have. And a lot of confidential computing really talks about the guest layer, the CVM. That's a very important part. It's a very valuable part. But things actually start much lower than that. What we have in this product is we start with the Google Titan chip. This is the same security that is embedded in like Pixel phones and all of our servers throughout Google production. And this serves as our physical root of trust that establishes the machine as a legitimate Google hardware running in our data center. And also outside of the guest still, we are locking down the host operating system using TI, the Titanium Intelligence Enclave. And all this builds up to the point where we have the actual guest itself. And with the guest, there are options here. You can be using our shielded VMs. Now I mentioned those earlier, with a VTPM as the root element of trust. And also confidential computing. So you can have AMD SEV also using a VTPM, or moving on to having the trust be in the CPU itself with things like Intel TDX. As Kome just mentioned as well, the drive for this product has largely been coming from AI workloads, and AI workloads, they need more processing power, more oomph behind them. They need accelerators. So for those accelerators, if you're running on Intel, you do get the AMX extensions right out of the box, but with GPUs and TPUs, those also are supported being attached to the hypercluster. So in that, they have their own trust elements with like confidential GPUs. And what this really builds up to in the end is a remotely verifiable set of evidence that shows that the environment is living up to that promise that I introduced before, that there's zero operator access, and that the integrity of your workload has been maintained.
Yeah, thank you, Keith. So we talked about how we have the no operator access in the T or sealed VM. Let's also talk about how we prevent Kubernetes operator malicious one can schedule workload and that getting scheduled workload into the T. So what we have here is, so as I said, the GK control plane in general or Kubernetes operator is treated as untrusted in this model. So they can attempt to inject malicious configuration or anything via the pod spec. To prevent this, so we have the launcher agent we build into this policy layer, or you can call it, think it as an API gateway defense. So the policy actually takes the customer provided policy, which defines the shape of your workload. You can say, for example, you're not allowed to change the container execution path. You're not allowed to change the environment variables. Those things will be, you can specify that in your T policy. And when the container is actually scheduled, the launcher agent will be evaluating your pod spec and container spec against the policy you provide. So anything that's not conformant to the policy you provide yourself will be get rejected. So the container will not launch at all in this model. And we also enforcing the code level integrity with this model as well, with the cryptographic launch. So not only the pod spec, we also support your container image to be signed by the your CI/CD pipeline. So the same T policy actually can take your public keys you use to encrypt your container image or sign your container image. And when the container is loaded in the T, we also, before we launch in the T, we verify the signature assigned by the public key you provided. And whenever if it doesn't, the public key provided is not right, or you're missing the public key in your T policy, we also deny the boot of the container as well. So with this mechanism, you can prevent malicious workloads that's not defined by yourself to be scheduled by the malicious Kubernetes operator.
So what's on the screen now is really an example of using the attestation to get to kind of the heart of the issue here, and that's secret release into this environment, because you want to establish the trust that the environment is what you expect it to be before those secrets ever enter it. So what's shown here is the kind of the happy path, the easy button that we provided to integrate with Google services. So we do support taking the attestation evidence that I described earlier that has different parts of the stack measured and included there. It integrates with our Google Cloud Attestation Service. That Google Cloud Attestation Service processes that evidence and gives you back a digested, easy to use kind of an easy to write policy around set of claims about your workload that is something that you can put in your IAM access configuration for your KMS keys. That makes it really easy for you to be able to say, I want this data or this key that has my secrets encrypted with it. The only thing that is able to decrypt using that key is the workload that I've written, the one that I expect to be deployed, and only if it's running without administrator access in the TEE. Now, to decouple yourself from Google as the cloud service provider, you can also use your own versions of these. You can be using KMS or IAM systems elsewhere and the attestation verification. So what we've really tried to do with this is create a collection of best practices, an to use way to have a TEE platform with a clean separation between what the platform can provide and what you yourself care about, which is your business logic that needs to run inside of the TEE. So like once your pod is running, it can behave like a normal application does. It should still do things like authentication and encryption to keep your application layer logic secure. But now it has this extra information, the attestation, to be able to help you with that process, to integrate it in where it's most critical. With this, we really have taken, we started with our confidential space platform a few years ago, and brought together this with Kubernetes to have extra ease of use.
Yeah, so far we focus mostly on the confidential compute or security side of this architecture. I just want to say this actually has a scaling benefits as well. So as you can see, as I mentioned, we are decoupling the workloads with the Kubernetes node. So this actually brings us to, for example, 1-64 mapping of the standard Kubernetes node to the workload sealed VMs. So reduces actually the GK control plane workload because there's not so many Kubernetes nodes needed for the GK control plane to process anymore. So this actually gives us the 64 times the API server reef, and also we have our design partner validated with this scale working for their workload, hyperscale workload as well.
Yeah, so putting all this together, what this has done is, we've talked throughout this, is we've minimized the TCB. We've shunted off the pod into this tightly scoped, secure environment, and locked it down and had attestation around it. And we keep the goodness of Kubernetes. Everybody knows Kubernetes, everybody uses it all over the place. And you're able to still have that integration, still have that familiarity, and have it be part of your business deployment model. And we've kept this like zero operator kind of proof around your data as a hard enforced cryptographic attestation. So yeah. So with all that together, what Kome was bringing before, we have a really easy to use secure TEE. So I think we timed it pretty well. We were shooting to have a few minutes left for questions, and we have 2.5. So any questions?
And the actual Kubernetes node, are they localized? Is the locality relevant as you connect them to a network?
Yeah, they're connected via the network. So that's the 3 networking model I showed VPC. So there's a dedicated, we call the shim VPC in between to connect them. And that's a more isolated network you'll use.
They aren't co-located on the same physical machine, if that's what you mean, but they are located in the kind of high bandwidth locations to each other.
So latency is observed latency.
The latency is ignorable in so for in normal case, you put them into the same zone or same region, and the latency in the data center network is likely less than 5 milliseconds.
Yeah. Yes, in the back. We don't use hypercluster specifically. The baseline of the TEE, the ACOS operating system, is common between hypercluster on GKE, confidential space, and Gemini on-prem.
So you feel like you take the model weights in this feel comfortable with it sitting in just different enterprises?
Sitting in different, what was that?
Like companies.
Well, we do it. GDC is a product. We have Gemini running out in the wild. So, yeah. You take that one?
Yeah, that's a good question. So the storage if you need to share, it's hard to be handled in this case. So in this model, you cannot share the model, the storage. So the storage is actually attached to the sealed VM itself. So normally how we handle is it's either need to be connected via the networking. For example, we have the Google Cloud Storage GCS Fuse. That's the more networking-based feature. Or we can have the more local SSD, which needs to be attached to the VM from the beginning. So those will be supported. Yeah.
And to clarify, when he was saying that like sharing between pods, since they're not on the local machine, we can't just mount the same path into two different pods anymore. However, you still do have other methods of, you can use any storage mechanism that is across a network, like GCS. So.
Yeah, you can still use those.
And since it wasn't on mic, the config secrets in Kubernetes is what the question was there. And yes.
How much of that is already available?
It is already available product. So if you have question, you can.
So I can do today, statement verification for these secrets for SNP, TDA.
So I was going to say that not everything on all the slides are currently available. Yes. So. I don't think we can fit that in the next 40. Oh, we're 40 seconds over. So negative 40 seconds. I can't cover that. But we do support confidential VMs with TDX. Today, we don't yet have platforms capable of CCA. That's on the slide as something that in the future, and also with S&P. There would be SEV, but not SEV S&P today.
The VMs are, so the question was how fast the VM can boot up. So this is same as the control plane boot up. So these VMs are basically GC VMs. So in our model, you normally, since it's for the AI workloads, you normally provision those with a reservation app. For example, it's a TPU or GPU, so you have provisioned them. And then you will have to use you schedule the workload the same way you create the pod, and then the pod will get provisioned. So we didn't handle that problem in the VM provision problem in the Kubernetes layer. It's still the problem for the GK control plane layer. So use the GK control plane to provision the VM, sealed VMs as well. Similar to you provision the standard Kubernetes node.
All right, we are 2 minutes over, so I think we're going to have to cut it off here, but both Kome and I will stick around here or out in the vestibule or whatever for further questions. Okay. Thank you for your time.
We're about to start. Hello, everyone. Can you hear me? Awesome. Let's get started. All right. So we are going to talk about something a little different from what we have been talking about. So we start all the way from software and then end with the talk where we actually go deeper into the hardwares. Let's start with something like software governance is a claim which says, hey, you tried. We actually talk about things, hey, AI, prompts, bunch of stuff, and then we have a lot of tools and stuff which actually helps us say that make sure the agent does this, make sure the agent does this, make sure you follow the rules, you make sure the prompts stuff this. Hardware comes in, hardware governance proves that you indeed did that. So as we saw from a bunch of talks in the morning where we really went deeper and say that, hey, how we can bring in the hardware guarantees, how we can bring in the attestations, how we can run stuff inside the TE, and then we can do a lot. We can do a lot of stuff. And we have been actually hearing about stuff which says, hey, agents and prompts and governance and like policies and all of this stuff. So in this talk, what we are going to do is we are going to figure out a way where the two worlds can meet, how we can think of a future where we don't really have to think about the two things very differently, like really just focusing on the hardware and like just trying to say that, hey, where we stop, or also just on the software and saying that as we are cool as far as like policies and stuff are in place. How do we bring the two? And then that is where the real magic happens. So this is Imran. I'm the Chief Platform Officer in Opaque. I was part of Microsoft when I built Agent Governance Toolkit, which is something which has been widely adopted. We released in April. In this talk, I'm going to start with Agent Governance Toolkit and end with how we are tying up the software and hardware together to bring the entire trust and governance in place. So some of the basics which we already know, we have been talking about this for since morning. Agents are not LLMs. They are not chatbots. They are like much more than what we know, and they would be much more than what we know today. Agents can do a bunch of actions and all types of actions today, and they would be more powerful tomorrow. So the question is, what do we do? Do we just pick and choose where things make sense? Like, for example, like, can we just start thinking about agents? And when we think about the agents and LLMs and all of this stuff, we just think about the governance. Or when we really are making some key decisions and stuff, we think about the hardware. So I think one of the things which we really have to start thinking about is it's not like multiple problems, it's like same problem which we have to think about. So what do we have today? We have a lot of AI governance software. One of the things which I built was Agent Governance Toolkit. A bunch of stats here. It works with all of the agent frameworks, which people use to build agents. It has integrations with all of the stuff. There's a huge adoption. There's a good community ecosystems. But there are still a lot of questions which are still unanswered if you focus only on the software. Questions like, yeah, the policy was there. You deployed the agents with the policies. The policies were being used to govern the actions. But how do you know the policy which was used to make a decision to allow a particular action was indeed the policy you deployed the agent with? Very simple question. Maybe the policy is correct, but like, is it the policy or what version was it? And there is a lot of questions around that. Hey, which model I really deployed versus which model is in production? There's a lot of things where the software in itself is not going to answer you, because the software, the governance, everything, including your agents and LLMs, are at the end of the day in the same box, and agents can do a lot of things. Couple of things, some examples. They're not like very exhaustive examples, but like some examples where software governance is awesome, it's important, we have to start with that, but we cannot just stop there. Like for example, if you have policies and you have agents which are powerful, which can do anything, they can actually go change the policies too. Or you could have policy tampering, but software is not going to really just guide you, help you there. You could have, other thing very important is, I want to, as part of compliance, I want to know what my agent did, what actions the agent has taken, what led to those actions. And maybe I think the answer would be like, hey, we are going to log all of these things. We're going to have the logs, and then eventually we'll be able to verify all of those logs, which is good, which comes from the governance frameworks which we have today. But the question is, agents can actually go tamper the logs too. So there is a lot of things which the software can actually help you, but I think you have to really go beyond that. And that is where I think we are setting the stage for some of the things we have been working on. The last slide, which says that, hey, maybe we have been talking about TEs since morning. We saw a lot of good examples about like, hey, attestation and task execution engine and like hardware guarantees and all of those things really can help you. But the question is, deterministic systems, obviously, like you really want a guarantee about like which process is running, if you're talking about the containers and all of this stuff. But now in the non-deterministic world, where you're talking about agents and LLMs and prompts and so on, which like a bunch of stuff which makes like an agent, just trying to actually say that we can trust the hardware in which you're running will not help you. You would need a little bit more than that. And I think that is where I think this slide says that hey, TE attestation proves a lot of stuff. You can actually have this application binary hash, firmware measurements, a lot of stuff. But in the agentic world, when we are talking about all of the compliance coming up, and there is a new compliance laws coming every day, there is a lot of requirements, which says that, hey, can you tell me exactly when an agent took an action, what led the agent to even make that decision to take an action? I think that's a very important question. You cannot prove it just with TE or just with the agent governance. You like need something beyond that, and that is what we are going to talk about today. Yeah, so a little bit about AGT. Thought maybe I'll just do a recap of what AGT is. Agent Governance Toolkit, which we built as part of Microsoft. It's an MIT license. We open sourced it from day one. And then the whole idea with this one was we want to give it to the foundation. We are actively working with AAIF, which is part of the Linux Foundation, to move AGT as part of that. We are in very late discussion of that. AGT is like entire governance framework, which it starts with policies, which is a basic governance story which anyone wants when they talk about agents, but it goes into observability, into the hypervisor, into the sandboxing, into the mesh, and a lot of other scenarios too. So it's like a huge feature-rich, available in a bunch of 5 different languages, and like it's a full package which anyone can use. It's open source, customize it, and solves most of the problems. If you want to have agents communicating to other agents, you do have security. If you want to work with MCP, you have MCP security. If you want to think about observability, like how my agent has been doing over a period of time, how hallucinations are happening, you get it. You get all of those things for free. So AGT is like solving a lot of problems which you would generally have when you're working with the agents. But I think the whole problem is who can guarantee? Like, for example, when you are deploying an agent in production with the agent governance toolkit, who can guarantee that the logs which are getting generated are indeed the logs which we can trust? I think the whole theme which we had today was trust. Like, who brings the trust? Who brings the trust? And then I think that is where the next slide we are going to talk about some of the new open source projects we have been working on. Aaron mentioned in the keynote, and then we'll just go deeper into each of them and like how do they help us. So the first one we talked about is the CMCP, confidential MCP. So we are not reinventing the wheel. We love MCP. We love MCP, and we really want to go ahead with the MCP. AGT supports MCP security out of band. So AGT plus MCP, you get a secured security with MCP, and you can get all of the stuff done. What we are bringing to the table is a confidential MCP runtime, which says you can have your policies running in a TEE enclave. So which changes the ball game altogether. And I think instead of like your agent directly talking to the MCP servers and using the policies through AGT, we are bringing a little bit different architecture, and that actually gives you a trust, which I have been talking about. And it's one of the examples of trust. We'll talk about a different kind of trust we are bringing today. So here what happens is the policies which you are going to run, it will be part of this CMCP runtime, which has this, which is running inside this enclave. And then we have this, there's a lot of details which we can go, you can look into the project also. These are all open source from today, which says that, hey, you can have different level of guarantees depending on like where you sit. You could start with the software guarantees saying that, hey, I'm good with the encryption, or you can use the basic hardwares, the ones which are available in your boxes, or you can keep going until you are like really running in the TE environment and confidential GPUs. So you have all of those options. And this guarantees that the policy you really wanted to use for governing your agents is indeed the policy which is running in the production, and you're not just relying on luck. It's a trust which gets guaranteed, and I'm going to talk about like how this guarantees some of these things come. There's a lot of information, but I think we have open source all of these projects which I'm going to talk about. So there's always you can go back to the links and see it. Second thing which we have been working on is trace, which says, prove me, like really, where is the proof? How can you prove me that, hey, what did the agent do? What was the policy which was used when the decision was made? What was the hardware the agent was running on, like, and so on and on and on. So what we have been working with our partners, AMD, Intel, and a lot of other partners, is trying to come up with a standard which call that, hey, we are named as Trace, which actually is not again reinventing the wheel. We are reusing. I'll talk about this in my future slides too, where we are coming up with a new standard called Trace, which says that, and we are also planning to contribute it to COSI. So we are actually working with that standards committee, which says, can we all close on one format in which we are going to generate all of this information so that auditors, when they need it, they can verify it. And then, so I think it goes back to the question we have been talking about since morning is, how can you verify? Can trust be verifiable? And I think this is where this comes in. We do have this initial version of the spec, which we are refining with our partners already in the project called trace.agenttrustio.com. And I think we are working with refining it depending on the use cases. You also have trace test and trace. So you can actually ensure that if you are working with a governance, software governance framework, which is beyond agent governance toolkit, you can actually make them also emit the logs, which aligns with the same trace standard. And to make things easy, we work with the agent governance toolkit team, and we got this trace standard implemented. So the new logs, which is going to come as part of 4.1 release from AGT, will start emitting the trace logs. So you can actually have some standards already baked in by all the consumers of the AGT. And the last, third most important thing which we released today, and then we mentioned in the same in the keynote also, is the agent manifest. And this is what I was talking about. When you deploy your agent to production, the question is like, what even agent is? Is it like just like LLM code which we go deploy? Is it beyond that? And then we think that it's like really a lot more than what then the LLM is. It is a system prompt. When you are designing your agents, you have a bunch of prompts which says that, hey, what are you going to do? How you're going to do it? What are your guardrails? What you're not going to do it? What formats? And all of this stuff. That's a prompt. You deploy it in the production, and you don't touch it actually, because until you really are coming up with a new version of this, and you really want to hash it and attest it. Then there is a huge policy which comes as part of governance. You really want to say that, hey, you're allowed to do this and not this and all of those things. That is a policy. You have an identity, which is like a closed problem. We don't even have to talk about it. Every agent have an identity, and then we do have standardization on the identities part too. And then you have a lot more other stuff. There is like 10 things which we talk about. Agent manifest says that is again the standardization, which we are going to work with the COSI and AI have to figure out where this sits. And we are launching the initial version today, which says when you deploy the agents to production, you can take the hash of all of these things, and you I think the three things which comes together is trace, CMCP, and agent manifest, and AGT, all of those things coming together. There is a huge, I have some demos which I'll show you, which can say that I deploy this in production and I have the hash. If something changes, it is not like something which I did intentionally, something got tampered with, my machines got hacked or something, those hashes are going to change. The attestation, or whatever I have been doing. And then I think the agent is something which I'm not going to trust anymore. So it's not like I have deployed something. Over a period of time, the prompt could have changed, the policies could have changed, and there is no way I can actually go figure out like, hey, is this really the agent I was running in production? Now you can, because you are going to take the take this hashes, and then you're really going to verify it against. And then you to make things easier, what we have done is, for all of the projects we have been working on, we are not directly starting with the confidential computing. We are saying that you have different levels of attestation you could actually work on, starting with the software. I think if you're like just running in your machine, I'll show that demo, and you really want to make sure your code is good, your deployment code is good, your CI/CD code is good, your agent code is good, you can make sure things work. But when you start thinking about deploying to production, you don't really have to change anything, because you're just going to say that where is the attestation coming from, and then you're good. So I think we have come up with all those kind of already different level of support, so you don't really have to worry about them. I think I'll skip this slide because I'll just show our demo, and then I'll come back to a few more stuff. All right, it's very easy to use. Everything is open source. Everything is available today to really just go get your hands dirty. To start with the CMCP runtime, you're just going to say pip install CMCP runtime. I've already installed it, so I'm not going to install it. I have 3 demos. I'll run the first demo. These are all, like I said, everything. Oh, it's a. Give me one second. Application control policy has blocked this file. Maybe let me run all the 3 demos and then I'll explain quickly. I ran all the 3 demos already, so maybe something is wrong, but I'll explain you what I'm trying to do here. I'll go back to the slides. All right, so maybe some things have worked, and that's good enough to actually for this demo. Okay, in the first demo, what I was trying to do, I think it's even the demos are available publicly. First thing which I was trying to do was set up a local MCP server and simulate that, hey, I'm deploying an agent, which is MCP client and MCP server, and I'm actually deploying my seeder policies as part of CMCP runtime. And I'm doing just some basic stuff saying that, hey, the policy says allow this, disallow that, and then whether things are working fine or not. And then this CMCP runtime generates the trace logs. In the second demo, what I'm trying to do is I'm simulating things where I'm changing the policies. And then if the policy change without me taking explicit action, it is like just simulating something which is happening behind the scenes, how things are going to get invalidated. And then I would get to know, and my agent will stop working. So I will have that guarantee. There are a lot of things which right now, as part of this demo, is not working, but they would work when you try in your machine. Or maybe I'm just rerunning things. And the third thing is important. So I think what we are also trying to do as part of this one is like, hey, as part of first, we ran this agent, and it was calling some MCP servers using, and then the CEDA policy was running as part of CMCP runtime. It generated a bunch of trace logs. We said, hey, agent was trying to call tool A, and then the policy allowed it, and this was the approval. So this already gets logged. And then we have this tamper evidence and bunch of stuff in AGT. I think behind the scenes we have this AGT and integrated. Now you get a trace log, which in the demo 3 you can actually verify whether like, hey, this is indeed the right log which got generated or not. So I think there's a bunch of things. Hope the demo is something which is available as part of the GitHub repositories. It should ideally work. Give me 1 second, I'll go back. Yeah, so a couple of things here in this slide I actually wanted to talk about is different personas and how they would be actually using this trace record. Developer would ensure that when they are working on the agents, shift left, they ensure that the agents and governance framework they are using is emitting the right trace logs. Operator, auditor, and counterparty. I think these are the different personas, and then there are different things which they are going to do. Developer is ensuring that trace is getting generated. Operator is where I think the trace records are going to get generated. Agent ran in approved TE and under approved policy version. Auditor is, I think, goes back to the compliance, I think, who actually are asking for some of these things, saying that, hey, we want to know when your agent made a decision, how it ended up making a decision. They would be using the trace to verify. And then I think one of the goodness which comes with the trace records is you don't really have to worry about the party which generated the trace has to do the verification for you. The verification can happen by someone else too with the private public key concept. So there is a notion around that. Maybe I covered this standardization. I'll skip this slide. I'll go to this one. Yeah, I think this one is important. I think this goes back to the question. I think one of the questions which we heard from everyone who are deploying agents in production, they said, governance is good, governance is fine, but it comes up with a lot of overhead, latency overhead. And we solved this problem in the agent governance toolkit. We said, hey, deterministic. We are going very deterministic instead of probabilistic, and then we have very lot less latency, things work fine. But now when it comes to hardware, you have to still think about things which you don't really worry about when it comes to software guarantees. There is going to be some performance overhead, but we verified, especially on the CMCP trace and the other areas which we are open sourcing. I think the performance overhead is not as bad, but I think the whole question is like, do you really want to do it for everything? And I think the answer is like, it depends. I think there are cases where you don't really have to, but then there are cases where you really have to. So I think one of the things which we really want to do as part of this AGT plus agent manifest plus trace plus CMCP is, you don't really have to use it, all of it, when you don't want to, but there are some areas where you might still want to, like financial services, sovereign, governance, and a bunch of areas. And then I'm almost done. Last slide. This is how everything will look like when you think about AGT, CMCP, trace, hardware thing coming up. And that's it. I think these are the thing which we are launching today. On the first track, this already exists today. It's already 2 months. Things we have a good adoption. On the track 2 are the 3 projects which we are announcing today. They're already available. You can go be part of the journey, and yeah, let's make it best together. And I think I don't think I have time for questions. Thank you.
Talking in a different lingo. You told me your heart broke. You've been reflecting, counting blessings, and now you know the love is never simple, no matter where it goes. And if it brings you pain, then it's okay for you to let go. Things are never simple. I guess if you don't wanna change your mind, you just gotta let me know. I told you before though. I just wanna dance with you, get involved. Forget all of this drama, it's getting old. And if it brings you pain, then it's okay for you to let go. We don't need no drama, don't need problems in my head. We don't need no drama, dance with my body instead. When the night falls on us one by one, we will forget every bit of that drama. Cause we don't need no drama, need that drama, cause we don't need no drama, need that drama, yeah. We don't need the problems in my head. We don't need the things we gon' forget. We don't need, oh, dance with me instead. We don't need no drama, don't need problems in my head. We don't need no drama, dance with my body instead. When the night falls on us one by one, we will forget every bit of that drama. Cause we don't need no drama. You stepped inside with a vibe I ain't never seen. Yes, you did. Ooh, so girl, if you talk like you walk, come and talk to me. But look here, it would break my heart, break my heart, break my heart if I find out you can't move. You better show me now, show me now, show me now. Cause when I take it to the floor, ooh, you gotta get down. You know what to do. Hey, Mr. DJ, play a song of this pretty little lady. Cause if she dances good as she look right now, I just might make her my baby. I just might make her my baby. Hey, I just might. Oh, I just might. But first, may I just say that your face got me so intrigued. I'm so intrigued. But what good is beauty if your booty can't find a beat? I don't wanna know, girl. So please don't do that to me. Cause it would break my heart, break my heart, break my heart if I find out you can't move. You better show me now, show me now, show me now. Cause when I take it to the floor, ooh, you gotta get down. You know what to do. Hey, Mr. DJ, play a song of this pretty little lady. Cause if she dances good as she look right now, I just might make her my baby. I just might make her my baby. Hey, woo, 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 woo. Woo, 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 woo. This the part where you break it all the way down, 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 down. This the part where I turn you all the way around, round, round, round. Put some but shine. And I know that you carry the world on your back, but look at you tonight. The lights, your face, your eyes, exploding like fireworks in the sky. Sapphire, touching on your body while you're pushing on me. Don't you in the party? I could do this all week. We'll be dancing till the morning, go to bed, we won't sleep. Chumma, 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 kiss it, daddy, body, touching on your body while you're pushing on me. Don't you in the party? I could do this all week. We'll be dancing till the morning, go to bed, we won't sleep. Chumma, 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 kiss it, daddy, body. Look what we found. Karma reached out into our hearts and pulled us to our feet now. You know the truth is, we could disappear anywhere as long as I got you there. When the sun dies, till the day shines. When I'm with you, there's not enough time. You are my spring flower, watching you bloom. Wow, we are surrounded, but I can only see the lights. Your face, your eyes, exploding like fireworks in the sky. Sapphire, touching on your body while you're pushing on me. Don't you in the party? I could do this all week. We'll be dancing till the morning, go to bed, we won't sleep. Chumma, 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 kiss it, daddy, body. Touching on your body while you're pushing on me. Don't you in the party? I could do this all week. We'll be dancing till the morning, go to bed, we won't sleep. Chumma, 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 kiss it, daddy, body. You're glowing. You color and fracture the light. Look at you tonight. Chumma, 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 kiss it, daddy, body. Touching on your body while you're pushing on me. Don't you in the party? I can do this all week. We'll be dancing till the morning, go to bed, we won't sleep. Chumma, 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 kiss it, daddy, body. Touching on your body while you're pushing on me. Don't you in the party? I can do this all week. We'll be dancing till the morning, go to bed, we won't sleep. Chumma, 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 kiss it, daddy, body. Touching on your body while you're pushing on me. Don't you in the party? I can do this all week. We'll be dancing till the morning, go to bed, we won't sleep. Your face, your eyes, exploding like fireworks in the sky. Come on, baby, turn the lights off. Ooh, 'cause it's getting late. I said, ooh, I know you're gonna try to hang tough. Ooh, you shouldn't hesitate. I'd love to burn. You had a wounded heart. Eyes across a crowded room. Should we let this start? I said, ooh, come on, baby, turn the lights off. Ooh, 'cause it's getting late. I said, ooh, I know you're gonna try to hang tough.
All attendees, please silence your mobile devices and take your seats. Our program is about to begin.
I'd love to burn. You had a wounded heart. Eyes across a crowded room. Should we let this start? so unforgiving. You've been a victim too many times, and I'll be the thread. Hold you together, I'll be forever. Will you be mine? So let me redefine you, and you can see the tide move, just like tears in the eyes do. And when you're feeling home, oh baby, I'll be right here between the sea and silence. So breathe easy, my dear. You can find sunshine in the rain. I will come running when you call my name. Even a broken heart can beat again. Forget about the one who caused you pain. I swear I'll love you in a different way. Hey, hey, I swear I'll love you in a different way. Hey, hey, I swear I'll love you in a different way. White paper planes in the sky, drifting where the wind blows. Yeah, gravity held me tight, but with you I can let go. I know, when I'm hollow, hollow, you take it all away and fill the empty spaces. Don't know about tomorrow, but I know that today I feel a little bit lighter when the world's heavy as stone, and the colors shine a bit brighter when I'm with you. Wherever we go, the goal ain't so cold as long as you're close to thought you should know. I feel a little bit lighter when I'm with you. The tide can pull us away, don't matter where we are, 'cause when you're inches away, heaven's never that.
Please welcome back to the stage, Aaron Fulkerson.
Hello, everyone. Thank you so much for sticking with us here. There will be prizes later, and the prizes are pretty cool. One of them, which is a confidential agent case. So what's inside the confidential agent case? I'm going to tell you. It is confidential. It's a flipper. So if you don't know what a flipper is, you guys raise your hand if you know what a flipper is. I figured everybody know what a flipper is. And it's not just a flipper, but it has a whole bunch of the peripherals for you to hack things. And I hope that you do, even though it'll probably drive the Linux Foundation crazy. So we will be giving away these at the close of day, both days, based off of today, audience participation. So I'll open it up for questions later. And there's a whole bunch of other prizes we'll be giving out both today and tomorrow. All right. Now into something much more important and significant, which is I am incredibly honored for this to have this individual in this next segment. He'd actually committed to coming in person, but given his role, things happen, and he couldn't make it. I'm referring to His Excellency Dr. Mohammed Al-Kuwaiti, who is the head of the United Arab Emirates Cybersecurity Council. So this gentleman sets policy for the nation of the UAE. Now, for all of us sitting in San Francisco, you might be wondering, well, wait a second, that's cool, but what does that have to do with us in San Francisco? A whole lot, and here's why. If you're aware of, let's say, Elon's Colossus, 2 gigawatts of compute. 2 gigawatts of compute seems significant, but the UAE is putting online 13 gigawatts of compute in the next, I think it's 2 years. 5 gigawatts of that compute will be in the United States. I might have my numbers a little bit off, but I think it's 5 in the US, 5 in the UAE, 3 in Europe, and they're going to add to that. There'll be some additional announcements of it. So Dr. Kuwaiti sets national policy in the UAE. In the UAE, they are leading the world in sovereign data, sovereign AI, providing verifiable assurance that you retain your data. And they're making that available to the world, so people from all over the world will run their workloads in the UAE on their 5 gigawatts of compute. But also they're rolling this out globally in other regions. So what happens in UAE actually becomes a global standard for the rest of the world. Great. And for those gentlemen in the back talking, go out of here. Go to the other room if you're going to talk. Come on, guys. Okay, so let me go ahead and hit play on Dr. Kuwaiti's video that he provided for us.
Hello, everybody. It gives me great pleasure and honor to be with you all today, even virtually, and I apologize for that. I want to highlight an important milestone for the UAE's digital future, mainly acquisition of Abu Dhabi developed cryptographic AI technology from the Technology Innovation Institute. This achievement reflects the UAE's vision to make technology a bridge for development, progress, and security. As I'm sure you already know that by now, artificial intelligence is transforming the world, but its success depends on trust. The most valuable data in government, healthcare, finance, energy, and critical infrastructures is also the most sensitive. To use AI responsibly, we must protect the data at every stage. This is where advanced cryptography becomes essential. The technology developed in Abu Dhabi enables confidential AI, helping organizations to use AI while keeping sensitive data secure, private, and protected. It supports secure AI processing, privacy-preserving collaboration, and trusted deployment in critical sectors. It shows that Abu Dhabi is not only developing advanced research, but turning it into technology with a great global impact. At the UAE government, specifically the Cybersecurity Council, our message is clear. Innovation and security must move together. Trusted AI, strong cybersecurity, and national resilience are essential to our future. The UAE is vigilant, the UAE is ready, the UAE is capable and emerging more powerful. And together, we are building a digital future that is secure, trusted, and strong. Thank you very much for your partnership. Looking forward to continue on that path. Thank you.
All right, thank you so much, Dr. Kuwaiti, for tuning in, or zooming in. So of great significance, in addition to what I've already explained about the UAE's leadership in rolling out compute for AI, another important note is there was an executive order announced yesterday by the Trump administration that everybody must have a plan for adopting post-quantum cryptography, which TII, who will be joining us on stage here again in a moment, Dr. Najwa, has developed a post-quantum cryptography that Opaque's acquired and built into our platform. Exactly what Dr. Kuwaiti was talking about here is securing the future in a quantum era as well as today. So We're really grateful that he took the time to film, and even though he couldn't make it here in person. Okay, so without any further ado, I'd love to welcome Dr. Najwa Araj and Priya Srinivasan from IBM on stage with me.
I'll sit next to you.
Welcome. We should start with Priya. You.
I want to sit here.
Yeah, come closer. I'd love to hear from you, your perspective on what you've been working on at IBM with your new product that you announced in May. It's very relevant to the discussion here at the event.
Hi, everybody. Thank you for having me here. So IBM launched a product called IBM Sovereign Core, May of this year. So May is when we do our big Think conference, which is when we announce our product launches. And what Sovereign Core does is essentially fits right into this topic of how do we ensure a true sovereign AI, right? Right from sovereign data to sovereign technology to sovereign operations to sovereign AI. And ours is a software that essentially does 4 elements across data sovereignty, technology sovereignty, operational sovereignty, and AI sovereignty. And that is the product that we launched in early May.
Well, congratulations.
Thank you.
Yeah. So we spent a lot of time today on compliance and architecture. If we zoom out, now that nations are standing up its sovereign AI at scale and verifying how it's governed, what does holding the proof yourself unlock economically, strategically, militarily, that trusting an operator never could? And I'd love to hear from both of you, but Najwa, why don't you start?
Yeah, I think, and to what we mentioned earlier, especially with the fast adoption of agentic AI, there is always this hesitance of what if the agent does something suspicious or malicious to my data? What if data gets exfiltrated? What if the model gets poisoned, etc.? So with all these cryptographic proofs and cryptographic guarantees, I think we're unlocking a big part of the adoption that the organizations, especially critical infrastructure and the defense sector, are still shy to take that step to adopt agentic AI. And I'll give you an example from the experience we're having in the UAE. I think Dr. Shawki mentioned before about this geospatial platform that we have launched recently that has been deployed with defense. Of course, in the deployment, that there has been a lot of thought into the security of the platform, but it has been deployed into an air-gapped environment. It has been deployed on-premise. But in addition to that, if you deploy it outside the premises of this defense clients and you provide those cryptographic guarantees, etc., you will be able to scale much faster, and you would be able to ensure adoptions but by more units and departments of that defense client. There is a very big unlocking that will happen and can happen in the healthcare sector, because this is one of the sectors that's still shy because of HIPAA, because of regulations, because of standards, data privacy laws, and the sensitive nature of client or patient records that comes with it. There is also the financial sector that will be unlocked, and in general, critical infrastructure will be unlocked. If we look into the UAE, for example, the energy sector is one of the biggest adopters to AI agent and AI agentic platform, but also with confidential AI technologies being there, with security and cryptographic guarantees, with identity management of those agents, I suspect that this can increase at a much more exponential rate.
Thank you, Najwa. And Priya, you're talking to a lot of entities that are looking to adopt sovereign. What's your experience with this as well? Like, what is it unlocking for them? What are they interested in?
I want to start where she left off on adoption. So around 95% of enterprises around the world, they're in some form of AI journey. But it's really only 20-25% are able to truly unlock the value and the productivity and the outcome that they want out of AI applications. And if you look at the delta, there are a few reasons, and they're the same patterns over and over again. But one of the key patterns is around what she was referring to, around regulations, right? It could be regulations
local, regional, country-specific, whatever it is. There are so many different regulations. And there is a level of trust, but verify, that everybody is looking for, right? And they want to make sure that it is done in a highly, and we were talking about this earlier, like people confuse sometimes compliance versus governance versus sovereign, but the needs of today is changing rapidly, and there is a huge expectation of, do I have the control? Do I have the independence? Do I know where my models are running? Do I know where the inference is happening? And to what you were referring to, you're building a lot of agents, right? Like you do not want to make a costly business decision that fundamentally affects your business operations, right? Everybody is expecting that resilience to stay, irrespective of what you're modernizing it with. And how do we do that in a real sovereign manner, which means you have the control, you have the independence, you know exactly where the models are running, you know where the inference is happening, and do all of that in automated, compliant, ongoing manner. You used a term, by now I loved it, but I should have registered it, verifiable trust?
Yes, correct. Yeah.
Verifiable trust, and that's really it, right? How do we make sure that it is an actual verifiable trust? Is the conversation we're seeing over and over again. Just based on the country or the region or the regulation, the framework might differ, the aspects that they're looking underneath may differ a little bit, but at the basis of all of it, everybody wants to make sure that they're compliant, they're highly governed, they know, that the things are in an automated manner, and it's truly, truly verifiable, and the evidence is right for them to see.
So the sovereign AI spans everything from running a domestic data center to owning the entire software stack from top to bottom, or maybe the hardware stack. What are we seeing as a minimum that has to be true in order for an entity to consider this as sovereign? Priya, I mean, you've been working on this product at IBM for Sovereign Core for, as you shared with me, years now, and I know you've got a ton of market research across the globe. What did you hear?
So it's a combination of different things. So we started, and like with data sovereignty, we actually started right there. Data and rest, data and use, data and motion. How do we truly make, and that was the initial set of demand that we were hearing, right? Data sovereignty, and that's where we were focusing. From there, we started looking at, okay, operational sovereignty. Do I have the keys to my kingdom? Where are my keys? Where are my secrets? Where's the identity? Where is that happening? From the operational sovereignty, it went to technology sovereignty. How open is my stack? How hybrid it is? Can I deploy it no matter whether it's on edge, it's on-prem, it's on cloud, multi-cloud, that whole technology sovereignty. And then more recently, I would say in the last 18 to 24 months, it's been a lot around AI sovereignty, and especially the last 12 months, it's even more increased, where it's about, hey, again, do I have the model flexibility? Can I bring my own model? Can I bring my own inferencing? Is it pluggable solution? Can I, the stack that you give, can I plug it with something else? And people are looking across the entire stack, meaning from infrastructure to the software, to the application, to the data, is all of that in a manner that it is truly sovereign. That's where the conversations are all shifting. And the other aspect I would say is, it depends a lot. For a while, people thought sovereign was a Europe word, okay? And then they thought, okay, maybe it was in Middle East word, then it is an Asia word. It's really everywhere. You could be in US, the word sovereign fits perfectly well, just as much as it fits anywhere. I would say it took a bit of realization. It just is control and independence. And who does not want control and independence and really understand what they're running, where they're running, how they're running? It is, at the end of the day, their business, their applications, their operations. But that, I would say, took a bit of education and working together with clients, with partners, and coming to that understanding that it's for everybody across all regions and all industries. And to her example, right, healthcare might have some different types of nuances, like HIPAA versus, the financial sector might have different versus telco. Telco has its own regulations. It's just catering towards those needs and making sure we're able to meet those needs.
Okay, thank you. And Najwa, what's your strategy in the UAE for sovereignty? I mean, you're at the forefront, as we all know, in thinking about this. And you're working collaboratively with not just the governmental agencies, but also let's say G42 and other neo clouds that are exporting the concept of sovereign to other nations.
Yeah.
Tell us about your strategy and how you think about this.
There are multiple layers to this strategy. So as you mentioned, we work closely with G42, which is the main government cloud provider, and their partnership with Azure in order to host the government cloud. And in this government cloud, obviously, you have all the services that are needed by the Department of Government Enablement, by all the Abu Dhabi entities, etc. And this is where G42 would provide the infrastructure layer that is hosted in the country, and then there are the model layer, there is the software layer on top, there is the agentic layer on top, etc. From a model perspective, as some of you might be familiar, at TII we have invested into our own large language model, or the UAE sovereign large language model, which is the Falcon large language model, multimodal models, perception models, etc. That's it was a good
fireworks.
Good fireworks, yes. So we have invested in foundational models, and now we are investing into the development of these various agentic platforms. And maybe this was a question that was asked for me before. Do you only use your own models? No, we look into what are the best models that are out there that would perform for a specific task. We contextualize them in certain aspects. We host them on-premise when, of course, for the sovereignty aspect. There is also the other side of the coin where we as an institute work very closely with the cybersecurity regulator, and you heard from Dr. Kuwaiti. The same way we have pushed with Dr. Kuwaiti the post-quantum migration in the UAE, now we are working into putting a foundation for confidential AI into the UAE. How are we going to deploy confidential AI? How are we going to leverage the confidential GPUs that are coming in the country with the deployment of the data centers with G42 and the government cloud services, all the cryptographic guarantees that will be there. And another thing that we are doing is we are working into the governance of the models. So which models will be deemed enough to be secure, to have the proper guardrails in order to be used in governmental services. So in a nutshell, this is how the sovereignty and the confidentiality of AI services is being thought of. That's in addition to the technology that we are developing, from federated learning to MPC to fully homomorphic encryption to our partnership with you for to collaborate on the opaque platform and the rest.
So the keynote, I shared with everybody my thoughts on the significance and importance of sovereignty, and specifically what I talked about was how sovereignty, meaning the freedom to choose the best model for the job, knowing that you can set the rules and verify that the rules are enforced, unlocks tremendous value globally, because it ensures that we have a thriving ecosystem in which we have the ability for industries and government agencies and social systems to get the benefit of AI without losing the ownership of their data. The alternative path that we've seen, and I shared in the keynote, one in which we've seen repeated through every single tech cycle, which is to say, we end up with one or two large companies that control. Like in this world, it's even more obvious how that would happen is if we aren't enabling data sovereignty, we'll end up with the data pooling into one or two intelligence minds that then become the cognitive layer for the globe, creating not customers, but dependents that are reliant upon that, and it's a very brittle, fragile system. So I just want to get your two opinions on, that's my opinion, is like, hey, this is the most important technology that anybody can be working on that ensures a strong, thriving ecosystem from AI. The alternative seems pretty dystopian to me, but I'd love to hear both of your opinions. And Priya, perhaps you first, like, if we don't nail this, like if you're a nation that isn't able to retain sovereignty versus one that did, what does that look like in 5 years? What are your thoughts?
It's going to sound like I'm repeating you, or maybe rephrasing you, but it's pretty much what you said, right? Number one, freedom, right? And you could say control, you could say independence, you could say freedom, but that is actually more important than we all right now realize or respect it, that actually having the freedom of choice, having that independence to be able to run your business the way you choose towards the outcomes you want. Like that's like, it should be non-negotiable for everybody, and people who make those strategic decisions are going to stand much longer than others, I would say. Two, like I said, it's going to sound like I'm repeating you. You mentioned about the whole data aspect. Why is that so important? What is one thing that's going to differentiate is that domain knowledge, the domain data, what you hold, like the keys to the kingdom is really the data of your enterprise, your nation, your region, whatever that is the keys to the kingdom. And having that and having a view around it and making sure that is sovereign, 5 years from now, if I get an opportunity, if they call me again here, we would be able to see examples of those who made the right data sovereignty decisions versus those who did not. And then the third thing, there's a lot of AI tools. My daughter builds so many things. I mean, I'm not questioning her intelligence. She's super smart. My point is, she's not even interested in tech, but I'm amazed at how much of tech and AI and stuff that she just grasps. Like, there's so many tools. There is so much available, right? Non-technology people can build stuff. That's not the thing. But doing it in a truly governed manner, in a sovereign manner, that is where the challenge is going to be for the future. How do you make sure that people who trust on you, right? You're a bank, right? Your customers completely trust that they know what you're doing with their data, how you're using the data, right? And I work for IBM. One thing that we've earned is trust, right? And at no point, irrespective of the AI transformation we do, that will be a non-negotiable thing, that we will not compromise on trust of our clients, which means everything that we do with AI, whether we do it in our procurement, we do it in our sales, we do it in our marketing, we do it in our customer support, it will be done in a highly compliant, highly governed, highly sovereign manner, no matter. We operate across 150 countries. Based on that country's policies, rules, regulation, we will follow to the right T, but using technology, not just using humans and controls and contracts, but really using technology. We will follow on the decisions that we're making today is what is going to stand the test of time 5, 10, 15 years to show the differentiation. So I would say domain and data, freedom, control, independence, and truly the trust of your clients and how you are doing that AI sovereignty in a manner that they'll continue to put the trust. At the end of the day, we're all companies are here for their clients.
Thank you. So Najwa, what are the two paths over the next 5 years? Those that retain sovereignty, those that do not. I mean, is my rendering of this an accurate portrayal, or do you have a different view?
I think maybe I fully agree with whatever Priya said, and just to complement it, right? There is a big merit in open source standards and what the likes of the Linux Foundation is doing, with the Agentic AI Foundation is doing, to keep those open source standards for the whole community to be able to use those standards, to use the tools that are being developed and then being put in the open source, and the ability to contextualize, to host on-premise, and to maintain the privacy of the data. There's a very big merit in there, and as long as you have new models that are being deployed in the open source, new tools, new libraries, new MLOps platforms that are being put in the open source, I think this allows you to adopt such technology and then to incorporate them with your sovereign AI and the sovereign security stack. As we have been discussing since early in the day, there are new standards that are needed for the identity and agentic platforms, for security, for confidentiality, for developing cryptographic standards and cryptographic guarantees that have to also be standardized and being adopted that enable this sovereignty as well. So this is from one aspect. The other aspect is technologies are needed. So whatever you're working on confidential AI technologies, whatever we're working on confidential AI technologies, what the new software that IBM has released to contextualize things, to enable the sovereignty of operations, sovereignty of compliance, and sovereignty of governance also is quite important. And then the final one is the availability of compute and hosting data centers in countries, and not to be localized to a specific geography is very important.
All right, well, ladies, thank you so much. I know that we've got limited time because we're already over, so I'm gonna thank you so much for joining us on the panel and sharing your insights and experience. Thank you.
Thank you.
All right, next I'm excited to welcome panelists for our quick takes. I guess that's a thing. Quick takes panel discussion. Please welcome to the stage Erica Brescia, Managing Director from Redpoint. Where is Erica? Is Erica here? Okay, great. Hey, Erica. Also, let me bring up Anand from Fortanix and Marvin from Fala.
What's up, yo? Good to see you.
Good to see you.
Hi, Erica. Nice to meet you.
I should give everybody a hug when they come on stage.
No,
Okay, great. So what I want to do is I want to kick off asking some questions, and then I want to open it up to the audience because that affords me an opportunity to give out audience participation prizes.
Oh, exciting.
So in order for us to facilitate questions from the audience, why don't we start off by introducing yourself, your organization, briefly what it does, so then maybe they can get a sense of a good question to ask the group, and try to keep it to about a minute. Start off with you, Marvin.
Okay, sounds great. Hi, everyone. My name is Marvin, and I'm the co-founder and CEO of Fala. We are founded in 2020, and our main product is a DStack, open source framework that enable anyone to use Docker to run their own confidential compute infrastructure. So, and we also have Fala Cloud, cloud infrastructure on top of DStack. So, you can run CPU or GPU or private inference on top of it. Most of our use cases are cryptographic, AI agents, AI models, confidential AI endpoint. So this is our main business. Yeah, thank you.
Thank you, Marvin. Anand.
Hello, everyone. My name is Anand Kashyap. I'm co-founder and CEO of Fortanix. Fortanix has been around for 10 years. We just celebrated our 10-year anniversary. And
congratulations.
Thank you. We've been doing confidential computing for a long time, even before it was called confidential computing. I remember the time when we used to go to VCs trying to raise money and describe the technology, saying, hey, people secure data at rest, data in motion, we secure data in use. Later on, the term confidential computing was adopted or coined, and we adopted it as well. So we have been building technology, solutions, products on top of confidential computing for a long time. Our flagship product is what we call Data Security Manager. It's a key management, enterprise key management product, as well as a hardware security module. And in the last couple of years, we have been collaborating with NVIDIA and the broader technology partnership to build a confidential AI solution, which we have taken to the market. And securing proprietary models, bringing them on-prem, that has been a big use case for us.
Awesome.
Great. Erica.
Yeah, I'm Erica Brescia. As you mentioned, I'm a managing director at Redpoint Ventures. We've been around for about 27 years now. We have $7 billion under management, invest from the earliest stages through about Series D, like in the early days in companies like Snowflake and Stripe and Twilio and HashiCorp, more recently in companies like Mistral and Anthropic and OpenAI and Modal and Railway. And I spend most of my time on the infrastructure side on the early stage, so inception through Series A. I'm also on the board of Linux Foundation. I've served as one of the 3 independent directors for a decade now. So it's been a really fun journey to see how much things have evolved and new organizations like Confidential Computing have popped up. Before this, I was COO of GitHub. So I do have operating experience. I was there through shipping Copilot. So I know it's fallen from grace a bit, but it was fun to be a part of that. And before that, I founded a couple of companies.
Great. So Erica, I'm going to start off with a question for you. It's actually a two-parter.
It better be an easy one. You gave me 0 prep for this.
Explain how keys are managed in the...
Oh, dear God.
So
managed very well.
5 years from now, where does the durable value accrue? The model labs, the infrastructure layer, the builders on top, all 3? And then here's the second part, and you can pick how to answer this, because I'm going to cram 2 in here.
All right.
Where are you writing checks today, and where are you not going to write checks?
Okay.
So they're related. It's not like completely...
And I have 30 seconds to answer.
No, you've got time. Take your time.
Okay. Look, I don't think anyone really knows exactly what the world looks like in 5 years. There are a couple things that I strongly believe to be true. Like the frontier labs are not going anywhere. Like they are here to stay. I think of them like cloud vendors. This is not a new mental model, but it has served me really well through investing. And I remember in the early days of AWS, because we're old enough to have seen that whole movie, like everybody's like, oh, the cloud's going to be commoditized. Well, yeah, commoditized into massive businesses. And I would have loved to put a check into the Series A of AWS or, Google or Azure if I could have. So I think they're here to stay. A big part of our thesis is that enterprises are going to be running a lot of their own models, their own like SLMs, and open source is, as always, going to win in the long run, or at least take a huge part of the market. And so this answers both questions. Like, I think there's a lot of opportunity to be captured, and we have been actively investing and looking to write checks in any companies that are enabling enterprises to run their own models, whether that's in a VPC or on their own hardware, which we're seeing more and more folks doing. It is really hard to build at the application layer today. We do have some investments like Serval and ITSM that we're super excited about, and we continue to look for like really big categories with incumbents who might be structurally challenged, where we think there's a real opportunity for someone to come in without all of the technical and organizational debt, build fresh, and build something that is so ingrained in the way a company operates that it will be hard to rip out. But for those like app level investments, we're really looking at like, once somebody implements this solution, is it going to get better for them over time? And so as you might expect, we're also spending a lot of our time in like continuous learning, and some of the labs and other companies working around like, how do you help models like self-improve as they get deployed inside an organization? That's the thing that's going to allow the application vendors to actually like build, I think, defensible and durable businesses. So I know that was a bit of a cop-out. Like, I still think there are opportunities and value will accrue at every layer, because I think we're seeing one of the biggest technology transformations, or probably the most significant one of our lifetime. And there's value to be captured across the stack. And we're looking to write checks across all of it. But I will say, I think most VCs, and we just did a study of our peer firms, it was really interesting. Almost everybody that has been focused on investing in apps is doing a lot of frontier tech. So they're looking at chips, they're looking at space, they're looking at power, they're looking at robotics, because we see that as like the next area of opportunity, where the app layer is, at least for now, getting a little bit more thinned out.
You crushed that.
Oh, thanks.
So you didn't answer one part of it, though.
Yeah, where am I not?
Where are you not writing checks? You're like, I'm not going to do that.
Oh,
I know you guys have had this conversation at Redpoint. You're like, yeah, we're not touching that.
Yeah, but to be honest with you, most of the time that we're not touching stuff, it's not because it's not interesting. It's because we don't think we're best suited to win, or the market's really tough. Like, I think like medicine for us all, I'm so excited about the next 5 years. I think healthcare and longevity, I'm a total longevity nerd, is going to be completely transformed. I think we're going to cure a lot of major diseases in the next 10 years. But there's also companies like Isomorphic that have already been funded, that have piles of capital where it's hard to invest. The other thing is space. Like, I actually spent a bunch of time looking at a data centers in space company. I think it's super cool. I do believe we're gonna run data centers in space, probably below the ocean first and in some other more sensible places. But yeah, don't you love having VCs on a panel with all these crazy ideas? But
yeah,
like,
we do.
I don't want to compete with Elon. Like, regardless of what you say, I think what he's done with SpaceX is incredible. And like trying to fund a company that is dependent on SpaceX to be shipped into space to build data centers to compete with Elon, like that seems like a tough proposition. Somebody might pull it off. We are investors in K2 on the satellite side, but yeah, it's categories like that. It's like there's so many things that as long as you're building like really interesting technology, there's probably an opportunity to capture some value. It's just not always for us.
Okay, great. That was a great answer. All right, I've got one for both of you. Okay, and I might have this wrong, Marvin, but I think it's accurate. So trust has to be rooted somewhere. Marvin, I think you root it in decentralized networks, right? And Anand, in enterprise hardware platforms, you're rooting it in the hardware, right? One of you is more correct than the other one. So why don't you guys individually make the case for decentralized networks, for hardware root of trust?
He's the outsider.
I don't know who wrote this question,
He
but
should
I
go
think
first.
it's awesome. It might have been my personal agent who wrote this one. It's a great question. Sorry, do you want to go first, Marvin?
Yeah, I'm going to start. So our clients are decentralized, purposed, and not our service or platform. We serve them to reach out their goal, for decentralization. So I think there's two kind of key value out there. First is like the model accessibility. There's a lot of things happened between borders or countries for model operation, and I think open source model is one thing that everyone is expecting from the decentralization world. And there's a one very interesting case. Just imagine, right? Just out of the box. Imagine, okay, you create a system that anyone can contribute their GPUs to that system, and there's a consensus among the society to how to utilize these GPUs. For example, let's train a model, or let's provide an inference service on top of these decentralized GPUs. But problem is you don't want to send prompt or your model weights to any dude's server or GPU in their home. And in that perspective, how to measurement the contribution and how to keep things in secret is a key friction for that world. So many of our clients working on that, and that's the reason why they pick up confidential compute as a key technology to enable their work. But back to the topic. So I personally think like decentralized AI won't stand for the current stage because if it failed to provide, let's say, a high token throughput performed model, or it failed to be able to orchestrate these GPUs as strong as B300 or NVL72, then if the performance is bad, then it doesn't make sense. So how to have that system in the middle, providing a very good, stable, high-performed, inference service is the bottleneck for now.
So you believe hardware is better than decentralized?
I think
I believe that we have to solve some issues first, and after that, there's another world out there.
Well, are there use cases in which it makes sense where performance isn't a bottleneck around distributed AI workloads?
For example, like GPUs pricing are different, in different world. For example, like there's many San Francisco, YC startup, they raise a couple $1 million and they buy a lot of GPUs for their in-house using. And after that, the idle rate is probably 50%. So there's a 50% of GPU resources are wasted out there. There's a San Francisco computer, there's RunPod, there's a lot of platform you can contribute your computer in to utilize the idle GPUs. I think that's the where it begins to make sense. It's not about like purchasing for the highest performance. It's more like use the idle GPUs. So yeah.
I think actually, if I can jump in for one
of
second,
course.
we did an investment in a company called Sail Research that lets they're tapping into all of these idle GPUs and letting people run their workloads on them. But the use case to your question, it's all for long running like background agents. That's something that us and a lot of other firms are spending a lot of time in as we move into this like agent first world, and companies go from like people just interacting and giving agents like real-time instructions to, hey, there's like almost like agentic cron jobs that are running and agents are just going about doing their business. And when they're running in the background, then the performance is less of an issue because it's just like happening behind the scenes and you don't really care about latency and things like that. So I suspect we'll see a lot more of that in the coming years.
I think that's what Chris Ray, when they started together, was intended to do, was to take the unused capacity across people's private or public clouds and then repurpose it for workloads. And then they pivoted to the Neo cloud, which has gone vertical.
Right? Yeah.
Anand, so back to the original question.
Yeah, I think, look, there are a lot of different types of privacy enhancing technologies. And in the past, confidential computing has been compared to a lot of them, right? Multi-party compute or fully homomorphic encryption. I've not seen the comparison with DLT that much, but it's obviously there. And all of these technologies, essentially what they have is the fundamental building blocks are, there's some math and there's the systems and protocols and algorithms and how things work. And part of the systems can be implemented in hardware. And everything is a combination of both math and systems. Even DLT, if you're using a consensus protocol like proof of stake, how do you manage your encryption keys or your digital signing keys over there? How do you protect that? When you run your smart contracts, how do you make sure that that runs in a secure environment and how is that protected, right? Hardware and using hardware as a root of trust, that is a more complete solution in my mind. It is more performant. So using that as the basis for building trust going up is more practical in today's world. The math still has not figured out how to make FHE, a fully homomorphic encryption fast, or DLTs fast. There are performance bottlenecks for all of that. But with hardware, you get native performance or near native performance. The performance is much better. And then if you can trust the supply chain, then you can get much higher levels of security with practicality. But that's not complete. You still need to build out guardrails and other forms of protection. Maybe if you're generating some encryption keys, how do you make sure that you require a quorum to make sure people authorize? So you want to put in a human element there as well. And security is always a collection of things. It's not one single thing. So you can have a hardware root of trust, but you have to build more scaffolding around it to make it even more secure. And that's how we have been building our products.
All right, so here's what we're going to do. We have 3 really world-renowned experts on stage. You've got Marvin, who's doing confidential from both confidential compute as well as decentralized network. You've got one of the OGs of confidential with Anand, who's been pioneering the category for 10 years around confidential. And then you've got Erica, tier 1 VC, rich history both in operating her own businesses, CEO GitHub, and has been on the forefront at a tier 1 VC doing investments. I'm going to open it up to the audience. There's 2 mics in the audience out there. I want to get your questions for our esteemed panelists. And as a reward, everybody who asks a question will win a prize. It could be a confidential agent case. It could be one of the other prizes, which I'm not sure what they are. I'm just excited about the flipper. So who wants to take the first question? Great, come on up. Were you the one talking in the back? Are you redeeming yourself now? You have redeemed yourself.
Yours okay?
Yeah. What's that? Yeah.
Should I? Yeah, no. I have a question for Erica. You said the big labs are here to stay. And on the other hand, you said you really believe that small models are gonna, in enterprises, are gonna be the next big thing. How does two claims work together?
Yeah, it's a totally fair question. Look, I think we're going to use different models for different use cases. And so I think in the enterprise for very specific workloads, like it makes sense to take an off-the-shelf open source model, use existing fine-tuning tools or, other systems around it to get the value that you need at a much lower cost and latency. And then for other really intensive tasks, you'll use the foundation model, or the frontier models, which will continue to get better. And like, there'll probably always be some lag with open source, but I think open source models, even if the lag is 3 to 6 months at any given point in time, are already so incredibly powerful that we'll be able to get a bunch of value out of it. I heard somebody describe it the other day as like, you don't need to drive a Ferrari to the grocery store to buy some milk. And like, that's kind of a good analogy, right? For certain types of things that maybe open source isn't able to deliver yet, you'll use frontier models, and for everything else, you'll use open source. I think it'll always be a mix.
Yeah, if I can add to that, maybe just like a couple of other places where we are seeing more open weight models being used or different types of models being used. Dr. Najwa talked about sovereign AI, so a lot of sovereign models are being built as well, domain-specific models, as Erica was talking about. And then cost is becoming a big factor. The cost of tokens is going through the roof, and people are using all kinds of models to reduce that cost.
But building on this example, Toyota is valued much more than Ferrari. So like, still, if you see Anthropic as the next AWS, let's say, how do, what's your view on the other companies, the Toyotas of the world, the neoclouds that are going to host the models?
I think, I'm not sure I totally understand the question, but I'll try to answer and tell me if I got it wrong. Like, look, I think Anthropic could be a multi-trillion-dollar company one day, and that doesn't mean that there won't be a bunch of other $50 billion companies along the way. And if I have a $650 million fund doing the VC math, like if I get a 50, I'd rather be, Series A in Anthropic, but being the Series A in a company that hits 25, 50 billion is also great. And there's plenty of opportunities for that outside of the frontier models.
Okay, yeah. Maybe just to finish the question, I don't want to take too much time, but my point is, if you look at Anthropic as the provider of let's say the best models and not the infrastructure itself, so sounds like CoreWeave, Nebius, the neoclouds who are providing the infrastructure are going to be much, much bigger. So just your opinion on that.
That's a really good question. And we have some investments in this space as well. I'm on the board of a company building its own data centers too, poolside, that's released some really cool open weight models that you should check out. I don't know that they'll be bigger because I think that's going to be a bit more fragmented than the model. There's only going to be so many labs that are like a very significant scale. Maybe it's 3, maybe it's 4, it's tough to know exactly how that'll net out. I just think with the neoclouds, there's so many of them, and they're largely fairly undifferentiated that I don't know that there'll be one that actually wins the day. I mean, there's still companies like constantly raising funds for new data center businesses all the time, new neoclouds, and I don't think that will stop because there's so much money to be made, but it's not at the same scale.
And that's Alpha Compute's business, by the way, is one of the sponsors, is building out the infrastructure for the data centers.
Oh, awesome.
Where's my prize?
Good place to be. Flipper 0. Is that what he's getting?
What's that?
Did you say someone's getting a flipper?
Yeah.
Those things are
filled. It's got all the peripherals for it too.
Oh, dope.
Yeah. Who's up next for questions? Great.
Hi, my name's Derek.
Hi, Derek.
I have a question for all of you, but I'll start with Anand. I view things through a concatenation of technology, policy, business, and people, and they always impact each other. Privacy has a cultural understanding, but a universal value. What combination or steps do you see as businesses and how they communicate in the language they use, as well as policies that could lead us to a better, less dystopian future?
Yeah, so the question is about the interplay between the policy being set by regulators and how are businesses responding to those policies?
Or influencing the lack of policy.
Or influencing the lack of policy.
So a lot of the problems are for a lack of policy, not bad policy necessarily. So, businesses participate in the success of cultural changes as well. So the move towards, by default, Microsoft infrastructure will be confidential. This is a great, hopeful move that we heard about today. So as an example.
So when we started Photonics, that was a time when the GDPR had just come out in Europe. And I think that kind of set the benchmark for how privacy policies should look like at a big scale, right? And a lot of other countries have adopted GDPR-like policies, and some of the things that are in there, like right to be forgotten, the data residency requirements, sovereignty requirements, have been adopted in various parts of the world as well. Some people hate GDPRs. A lot of large internet companies don't like GDPR as well, because now they have to build fragmented infrastructure in various parts of the world. But it's here to stay. And what we have seen over the last 10 years is that different forms of GDPR, the EU AI Act, some of the regulations in the US as well, they've continued to change the way people have been thinking about data sovereignty, security, privacy as well. And enterprises, large enterprises, we work with a lot of banks, we work with healthcare providers, we work with governments. They've all been responding to that. There are two things that are important when responding and even influencing these policies. One is on the technology side, other is the policy and the influencing that part of it as well. We are focused more on the technology side and looking for technological solutions to these problems. And thus we're focusing on technologies like confidential computing, providing the basic layer on top of which you can build use cases and applications that allow data to be processed, AI to be run, applications to be run, different parties who don't trust each other to be able to come together and collaborate with each other in privacy. That has been the technological layer that we have been providing and trying to address the policy and the basic issues around privacy and human rights that people have been trying to build around.
There's, if I may.
Sure.
Oh, please.
I'm going to use the last minute, sorry. So to my perspective, I think there's two types of privacy preserving business out there. The first type of business is policy driven. Let's say, because of GDPR, CCPA, HIPAA, so like the companies, the enterprise, they have to purchase certain type of technology or service to make them compliant. And I think a lot of startups and companies sitting out there doing that type of business. And what I'm personally more interested is the second type. Like check out iPhone, right? Apple, WhatsApp, Telegram, Signal, Proton Mails, VPNs. These products sell itself. There's no policy behind it, right? To drive the demand. It's just a better word, and people want to use the privacy preserving product when the product performs really, really good. So yeah, I think like there's many ideas and opportunities out there, even in the AI world, to be unlocked after privacy enabled. So I think this is the second type of business. So yeah.
Great. We are at time, but let's get another question in. What? Oh, Nelly, there you are. I was wondering where you were. Hey, did you select somebody from the poster session? Excellent. This is one of my favorite parts of the conference. Thank you all, esteemed panelists. Nelly is going to come up and announce the poster session that she has selected to take the main stage and give their presentation, I think is what you're telling me.
I hope so.
Okay. Cool. Okay. What is their name?
So the winner of today's session is ML Commons with their solution called Matburg. This is By the way, applauses, everybody. NetPerf is actually systems the standard to verify.
Oh, yeah, that's what we need.
Trying to scream. It's why nobody applauding. Okay, it's okay. So NetPerf is using confidential compute, point number one, to address very big trust gap in healthcare AI, point number two. And they're doing this, again, in very open, standard way, utilizing ML Commons. They demonstrated how they can validate efficacy of the models running them in confidential environment and fitting confidential data to do the evaluation. They're using the concept of federated evaluation, FE, and they're focusing on detecting tumors and segmentation in their study, helping real people to figure out what is happening with their brain tumors. So huge impact, incredible, interesting use case, and very impactful work. So do we have people from NetPerf to get on stage
we
and
do.
talk about that?
Okay, great.
Great.
Come on up. We're going to get off stage. You come on up. Try to compress it into 3 minutes. So, because they're not going to listen anyway, they're thinking about the social section.
The social tonight is much more important. I will say that a lot of this work is being done in the context of ML Commons, and many of you know ML Commons as the organization that's responsible for setting up benchmarking and performance tests for machine learning. MedPerf is one of the working groups. The principal issue that they're trying to address in MedPerf is the siloization of data that exists in the medical industry. There's a number of regulatory, financial, fiscal, and kind of institutional issues that prevent it from happening. So MedPerf originally was designed as a ship your model to the data benchmarking system. So the benchmark maps interfaces for the data onto interfaces for the model in a way that allows mixing and matching of models and data sets. And the result being that you can go through and take a model and apply it to a set of data sets and get a score out for it. That works really well in the case where everyone trusts the model to be moved to the data. As we know, models have intellectual property in them that wants to be protected. And so the work that we've done recently moves the model and the data into a GCP container with full attestation so that both sides can trust the data provider and the excuse me, model provider can trust the results that come out of it and understand that their information is protected. And that's it. Thank you.
Thank you so much. So for everybody who asked questions, meet me over on the side of the stage over here, and I'll distribute prizes in just a moment. I just want to thank all of you for your participation today at the 4th Annual Confidential Computing Summit. You guys have been terrific. Thank you for the questions, and I can't wait to see you all tomorrow. We have an incredible lineup tomorrow, including the architect of the world's largest confidential AI deployment across billions of iPhones, Ivan Kristich, here tomorrow, along with Jason from Anthropic and some other incredible speakers. So see you all tomorrow, or I'll see you in the social setting. Thank you so much.